Yeah, so let's start. Did you all go through yesterday's portions? Were you able to solve the questions, UPSC questions? Did you try solving UPSC questions? Biotech, health related questions and all you were able to solve? How many of you saw the AMR related question, antimicrobial resistance related question? You saw it. Were you able to solve it using the information that you had? Okay. Yes. So that's it. I mean, the idea was that you should have a basic confidence in knowing that, see, this is the maximum expanse of what your biotech or things like that can come into. So we'll be taking up a very similar approach today also, wherein I put space in the first part, but then as you know, when it comes to UPSC, space, the importance of space as an entire topic is now reducing a little bit. Personally, for me, if I had to list today's topics in the order of priority, it would be your communication, computer-related technologies as first. Then it would be space, defense, and the rest of it. Okay, because so many new things are happening with respect to your communication, computers, ICT-related fields. And India has a lot of role to play in this also. So this is the reason why that area is important. But again, space, we have a lot more factuals to get figured out, right? Conceptually, I don't think space is a very difficult area for students to follow. How many of you find space difficult to follow? Like you've not understood basic concepts in the class? Anyone here? So we'll be brushing through the concepts quickly. What we'll be focusing more on is on the current affairs. And again, I have to stress on this fact. I was just telling him, space is one area, space and these technologies which are there. Again, you have a lot of contemporary affairs coming in. So anything that has happened in the past 4 to 5 years is basically current affairs for you. Got it? Which you have to study in a very selective manner, because 4 to 5 years current affairs means that is not something you will have to take vision 2-3 years and that you can imagine how many of that would be. So you cannot study it in that manner. We'll have to be very selective. So the topics I have picked in space, you might feel like, okay, fine, why is this being chosen right now? But the point is, this would have happened maybe 4 years ago. And right now, there would have been some minor development happening in it. But this would have been, when it happened at that point, this would have been a big matter of pride for India. And something that all the newspapers were celebrating and things. You were not preparing for UPSC at that point. You were very peacefully sitting maybe in your college classes at that point. So we who were there at that point know like what was the importance given. I have picked certain topics in that aspect also. Okay. So let's start. First, we'll quickly brush through the different concepts of space. Again, space concepts start from the different orbits that we have. Primarily, the beginning of the beginning of the entire universe and all, you know very clearly. There are probably 2 major theories that are floated. You have a Big Bang theory, you have a steady state theory, and you have certain evidences related to it. We are diving right into your satellites, orbits, launchers, etc. Coming to your orbits, you know very clearly there are basically 3 different categories. There's a low Earth, mid Earth and a high Earth orbit. The primary low Earth orbits that we familiarly know . So your primary orbits, when it comes, it starts with your low Earth orbit. The low Earth orbit, mostly you can classify as these two types. You have a polar orbit and a sun synchronous orbit. The polar orbit, again, you know, you have it in the range of, if you take this as the Earth's surface, anywhere between your 200 to 1200 kilometers, you can call it as a polar orbit. Now, what is the importance of the polar orbit? Anytime you want to have a near-Earth observation, wherein you want a pole-to-pole movement, you want something to move quickly and collect information not once, maybe twice or thrice in a span of a day, this is where you can use your polar orbit. So, let me ask you, is there any weight restriction to put into polar orbit? Can you just, or is there anything, I'm asking, is there any weight restriction? There's no weight restriction of the payload. Got it. It just so happens that we generally put low weight items in the polar orbit, but there is no actual weight restrictions when it comes to any of these primary orbits which are there. Then moving on to your sun synchronous, and okay, commonly if you look at the polar orbits, as I told you, this is near Earth observation. And what kind of satellites do you think would be preferring the polar orbit? Okay, what all kind of satellites are there? You have communication satellites, you have your Earth observation or your remote sensing satellites. So which are the ones that would be preferring your polar orbit? Huh? GSAT, what? How? Why communication? Okay, let me now for some reason that answer of yours has shocked me, so let me just break down the concept very clearly. See, you can send any satellite into any of these orbits. It just so happens that some orbits are preferred for some kind of satellites. Now, as I told you, when you have to have something observed in a very clear manner, you would always prefer it to be somewhere closer. So, you have more of your remote sensing satellites. Now again, obviously there will be one remote sensing satellite which is there in a high orbit. That is not what I'm talking about. I'm talking about general trend of remote sensing satellites being preferred in your polar orbit. Now the reason why you don't generally see communication satellites, and in today's class itself I'll tell you the exception of that also, but generally communication satellites are not preferred in your near Earth orbits because what is the prime thing about communication? You need to have frequency bandwidths which are not interfering with each other. Which means in your low Earth orbit, the amount of interference from other satellites, from the Earth's atmosphere, all of this is very high. You need it to be at a much more higher height. This is the reason why your geostationary or geosynchronous orbits are mostly preferred for communication satellites. We have exceptions to both of these cases. Just remember, this is the common idea in which a lot of satellites are being launched in. So, I would say the worst case where you get a question which we have not yet discussed, and by all these situational clues, try to make a call on it. Because if you know what a satellite is used for and you know its communication, but they have given an orbit which is very small, the probability that it might not be right is higher. Did you get my point? Okay. Now, so you have polar orbit, and primarily if you look your International Space Station which is there is one thing that we see in that manner, you know, because again why? You need your near Earth observations to happen from there. Moving on, you have something called as a sun synchronous orbit. Sun synchronous is actually a type of a polar orbit. What is the speciality of a sun synchronous orbit? If it's like a polar orbit only, then why we need sun synchronous specifically? What does it do? Can anyone tell me in very simple, I don't want that long full-fledged definition, just tell me in very simple words what sun synchronous would be. It will? Isn't there something scientifically wrong when you tell me it will move around the sun rays? Then? 1 minute, let me hear your answer. Okay. You all know sun is not moving, right? Earth is moving.
solar intensity at that time in sunlight.
Okay, I'll tell in very simple words because you all have confused me again over here.
It is only related to the sunlight fixed for the observatory means of sun.
Okay, I lost track once again.
It is related to the sun and fixed only for the sun's.
How is it related to the sun? I know it's related to the sun because they are calling it sun synchronous. Then how is it related to the sun? Okay, let's put it.
Satellites always fall on that orbit. Satellite.
Okay, it's some bits of all of this. Let's just break it down into simple terms. You know the Earth is moving in a particular orbit. We have specific times. We have fixed our times according to the sun's, how much heat, how much intensity that we are receiving over here. Now, if you have a particular satellite wherein it is ideally, now when you tell it also, you were using the word when the sun moves, but technically when the Earth is moving and you have a specific time, you have the satellite occurring in a specific point wherein, for example, if I say every day 12 o'clock the satellite should be here, this is going to be here because this is sun synchronous with respect to solar time. Got it? Not solar orbit or anything, with solar time. So it's a very Earth specific thing. Got it? Because on Earth, now if India is planning to put out a sun synchronous satellite, so what we want is we need specific observations, maybe of our climate, maybe of our some area which is there, as and when there is an intensity of the sun that is changing. So what we will do, we'll be like, okay, we need observation over Guwahati area at the specific point, at the specific time. That is the thing. It's called sun synchronous because it is in sync with the solar time. And how do we have solar time? We have solar time because Earth is revolving around the sun in a specific period of time. Got it? So this is the simplest way you can explain sun synchronous because it's in sync with solar time. That is the idea. Got it? Now, as we move forward, you have two mid-Earth orbits which are not very great. You just study it as it is. Mid-Earth orbits, you have a Molniya orbit, and then you also have a semi-synchronous orbit. Even if you've not heard about it until now also, it's not a big deal. It's just said as a matter of fact because there is a mid-Earth orbit over there. Then comes the most important two orbits which is there. You have a geostationary orbit and a geosynchronous orbit. Now technically if you look at it, both of them occur at a 36,000 kilometers away from the Earth. Then what is the difference? Okay, think about, let's first look at your geosynchronous orbit. Now you have your Earth over here. You have the equator maybe measured somewhere over here. Now see, as I had just told to you, you have a specific kind of orbit wherein so it's around the equator. Whatever you do, it will seem stationary to us because as the Earth keeps rotating, this thing follows, or this particular satellite which is put into that specific orbit follows the same amount of speed. So for us, it will look like a constant object in that specific orbit. And you want to come in the front? There is place over here. First time someone wants to come in the front. So this thing, from the word itself you can denote, it seems stationary to us. And thus this particular satellite put into this orbit around the equator following the same rotational speed as the Earth is called as your geostationary orbit. Got it? So stationary over here. But think about this. Then you have another thing called as, it's hot in this area. It's like the equator of the class. Yeah. You were there at a safer point. Yeah. So now coming after your geostationary, then we have another term called as geosynchronous. Then in what aspect is synchronous different from stationary? It is, now don't tell me it is related to the Earth. We understand it's related to the Earth because it's geosynchronous. Just tell me, how is it related to the Earth? See, I told you one thing. In the case of the geostationary orbit, it moves in the same direction, same speed as how the Earth rotates. Got it? But certain other orbits need not follow that same speed or even the same direction. But still, it will be around the Earth itself. Got it? Which means you can have an orbit like this. You can have an orbit maybe like this. You see the difference. What happens in all of these cases is the Earth is rotating. This orbit is around the Earth itself at the 36,000 kilometers. But it does not necessarily follow the speed or the direction that the Earth is rotating in. These kind of orbits are related to the Earth only in the aspect of they can be inclined to the equator in a certain manner. If you have this as your equator, it will be inclined to the equator. Inclined in the sense what? This is the equator. Anything that creates an angle with the equator will be inclined to it. Got it? In this manner, it is sync with the Earth. So now think about it. Just more for a moment. Isn't geostationary just another type of geosynchronous orbit? In all the other aspects, maybe it's following a specific direction, speed and everything, but ideally it's inclined to the equator in a particular manner. So geosynchronous is that kind of an orbit. It is primarily maybe circular in nature also. It may not be in the same direction as the rotation of the Earth. Not necessarily stationary, means it does not even have to follow the speed of the Earth's rotation, but it is inclined to the equator. Geostationary is a type of geosynchronous orbit. Now again, the very reason why both of them become, or for example, take the geostationary orbit, if it is following the speed of the Earth, which means that satellite would complete one entire rotation around the Earth or a revolution around the Earth in one day, because that is the entire time it would take to circle the entire sphere. Got it? So here it moves in the same direction as the Earth, therefore appears stationary. It can only be above the equator. Okay, so these are broadly your different kinds of orbits and your geostationary and geosynchronous. Now you know when we study the different innovations that are there for your telecommunications, for your navigations, for all of these things, we prefer these orbits. Okay. Now the common satellites which are there, remote sensing, communication and navigation satellites. I just want you to, we'll be discussing few important satellites and all today. So very mandatorily make it into a table. Okay, because otherwise at the end you will be like LMV, me, Mark 3, GSLV, everything will all get mixed together. Now understand, you have these kind of satellites, but these satellites are all put into space through certain machines called as your launchers. Based on the weight, based on the capacity, based on the orbit that they can achieve. In India, they are divided into all of these categories. You have SLV3, ASLV, PSLV, XL, GSLV MK2, GSLV MK3. For the purpose of our study, SLV, ASLV and all are not very important anymore, because these are all very older versions. We have improved upon it through our PSLV and GSLV mechanisms which are there. So commonly if you look at it, using or the currently used major launch vehicles, you have your PSLV and you have your GSLV. Now comes to the first one, PSLV. You have to know about PSLV from the crux of it. PSLV as we see today are seen in three major variants. The three major variants are PSLV-G, PSLV-XL and PSLV-CA, which is your core alone version. So every single time you see this in a news article, keep a note of which version has been used. Most of the time, the recent launches have either used your XL or your CA variant. Okay, the G variant is not there so much. if you compare last 5 years, you don't see the G variant a lot. Got it? So again, this is also a clue. If you are at a very weak point and you don't know and you're getting a clue over there, in the last 5 years, ISRO has been preferring your XL and CA variants. How do you have these 3 different variants, or why are there 3 different variants? Is there any based on the stages is one answer. Anything else? Based on the stages, based on the weight, payload it can carry, it's having 3 different variants. So now you also know why XL and CA are preferred, because right now we have categorized, or we have put an entire different category called as your SSLV vehicles. You have something called as your small satellite launch vehicles. For all the work that PSLV, all the small work that PSLV used to do has all been given to your SSLV. So PSLV now is more focused on carrying heavier payloads. Again, even if it's heavier payloads, what is the maximum weight a PSLV can carry into the space? Any idea? How much? So that's a very specific number. Up to 2000. Okay? Up to 2000 you can carry. Okay? Because there are versions of PSLV that have carried 2000. Sorry. So let's just try to understand. Currently, if you look at it, PSLV is having 4 different stages. The first stage of PSLV, if you want, you can just draw a diagram and make it clear. In like, maybe this is something I used to do to study it. If I'm saying solid, mark it with something that reminds you of solid. If it's liquid, mark it in somewhere else, so that 4 stages look simple to you. So the first stage, which is there in your PSLV, you have your solid rocket motor and solid strap-on boosters. Primarily meaning the first stage is solid. Your second stage, and this is a very important Indian innovation which is there, your second stage uses a liquid stage, and here you have India's one of its good innovations which have happened, which is your Vikas engine. So that is your second stage. So first is solid, second is liquid. In the liquid, you have the Vikas stage happening. Third stage, again, you have solid. And fourth stage, you have liquid. So primarily, what is it? Solid, liquid, solid, liquid. It's alternating. And these are the 4 stages of your PSLV. And done? Mark? Okay. Now moving on to your GSLV. In your GSLV, you have 3 stages. And this is a interesting idea, because in GSLV you have 3 stages. The first stage, again, here is solid. Second stage is liquid, and it's very similar to the Vikas engine stage that we have. Okay, but the third stage over here, right now we've started using our cryogenic engine, and the cryogenic engine is CE75 that we are currently using. So if even randomly they ask you CE75, that is the cryogenic engine, which is the third stage in your GSLV vehicles. Until a really long time, there were 2 constraints Indian space was facing. One, if we wanted to have better communication, communication again encompasses, you have to have a transmitter, receiver, a transponder, all these different machinery are there. So naturally, the payload of a communication satellite is higher in comparison to a remote sensing satellite. Okay. One of the problems we faced was we needed to launch communication satellites into higher orbits, but the payload that we could support, and PSLV was the most successful one in our case, The payload we could support was only like around, as she had mentioned, 1,500, 1,700, maybe at the best case 2,000. And that again would go, because PSLV is your polar satellite launch vehicle, that would go up to a height of your polar, your near Earth orbits. So we needed something that we could launch to higher orbits and could carry better weight. Your cryogenic engine has made it possible to do both of these things. Keep that in mind. It's not just payload and higher heights. So here if you see, when we had the first cryogenic engine, that is when we could even launch 2,000 kilogram communication satellites. 2,000 kilogram was a payload PSLV could launch, but PSLV could not launch it into your geosynchronous or your geostationary orbit. So this is what was made possible with the cryogenic technology. They could ask you a very general question on cryogenic technology. Okay, nothing with frills attached to it. It will just be like, cryogenic technology in India has facilitated what? And 3-4 different options. So don't overthink it. Any advantage that you have for these upper, higher launch things, you would apply it for your cryogenic technology. I was telling someone over here yesterday, I think he had asked me this. For how much ever for biotech and health, UPSC is stringent on technical terms. For IT and communication, they are quite lax. They'll just throw words just like, commonly used, can achieve higher heights. They'll just use words in a general way. Those from science background lose marks in this area. Why? Because we all tend to be like, oh no, that is not right, because there's an exception that I know about it. Non-science students are carefree at this point because they are like, we don't know the exception, so they just mark the general option which is there. So think those who are from science background tend to falter a lot when it comes to IT, especially you're from engineering background, means you're done for it. So don't overthink this area. Just take general meanings when it comes to this. Got it. One prime example I say is there was a question on remote sensing satellites asked few years ago. It's a very simple question. What are the applications of remote sensing satellites? We don't get questions like that anymore. And 3-4 options were there. One of the options, and the rest all was very obvious. Climate was there. I think soil monitoring was there. One option was you could determine the chlorophyll in plants. Whose phone is ringing? Is it my phone? No, it's not my phone. Okay. So the one option which was given was it can be used to determine chlorophyll in plants. Now, people would just burn their brains on it. Like, okay, there's a remote sensing satellite. It's observing the earth. How can it see something that is there? Chlorophyll in the plant and all. Chlorophyll is what? Is something that is there, that is released by the chloroplast. You overthink so much of this. It's just simple. Remote sensing satellites help us in agriculture. How do they help us in agriculture? They are not communicating any knowledge. That is the idea of the communication satellites. If they are helping us in agriculture, they are somehow able to determine the health of a crops, right? If the crop yield is good, is determined by remote sensing. How do they do it? They're doing it primarily by looking at the content of it. If the crop is wilting, if there is weed, this is what they're doing. But what you tend to do is you don't see it in that very general sense. You try to think, okay, how chlorophyll can be seen. Chlorophyll cannot be seen. You can just see if the plant is in yellow color or green color. But that is being determined by the chlorophyll. So you have to be a little bit general thinking when it comes to these areas which is there. Coming back to our topic over here, your GSLV, and now moving on to your sounding rockets. Again, this year sounding rockets are making a comeback in this particular form. So just tell what exactly are your sounding rockets. We had GSLV, we had PSLV, then why are we doing this sounding rocket? spoken like a very true Indian out there, that we are trying to save cost at this point. Very good, valid point. Primarily because sounding rockets are very simple structures wherein we have few experimental modules. It'll be like, for example, they want to determine atmospheric moisture. But it doesn't make sense to send an entire PSLV thing for it. So what do? You send these lower cost, specific function based rockets, and you can determine, and they do the same kind of thing. It can have the near Earth experimental analysis and they come back. Now understand, these are your solid propellant rockets used for probing the upper atmospheric regions. So get the point, they don't go beyond a point. It doesn't go to your up, because see, understand, it's a very simple mechanism that is there. In fact, we first launched, when we had to kickstart our space program, we started off with sounding rockets. So it is a very minimal technology thing, so it cannot achieve higher orbits. It is used to do upper atmosphere observations. The prominent sounding rockets of India belong to categories Rohini and Menaka. Okay, we started with Rohini satellites. RH200 is what we started with, and now we have a lot of satellites coming in. This RH560 was the recent launch. So that is the current affair part of it. You can write in that column, put RH560 sounding rocket for your upper atmospheric observations. Next question to you guys. Sounding rockets in India. See, in India, we have specific launch centers. I hope you all know that. There is Sriharikota, you have certain islands. Can you name few of the launching centers? Tumba is there. Anything else? Off the coast of Odisha, is there something? Yeah, Abdul Kalam Space Launch Center. So, my point being, each of these sites are chosen for some reason. Now, for your sounding rockets, we have chosen Tumba as the launching point. What is the reason? Don't tell me here is where it all started, so keeping up with the culture. No, nothing like that. Huh? It is not a? It is. It's some. Who said equator related something? What did you say? What? Okay, fine. You got somewhere the part of it. The point is, see, when it comes to Tumba is that point from where, see, Tumba is where, it's at the very coast. If you look at Trivandrum, it's at one of the southernmost areas of India. From here, to get launched into the cycle of the Earth's equator, it's quite easy. But they are not looking at the Earth's geographical equator. They're looking at the Earth's geomagnetic equator. Why the Earth's geomagnetic equator? So, for example, if this is the Earth, this is maybe the normal equator, and maybe the geomagnetic equator would be slightly inclined to it. My point being, why geomagnetic equator? Why do you think they could have gone to the equator only, no? Why geomagnetic equator? What is the problem if you go with equator? You do realize it's a small machine which is having very less capabilities. If you have to be in sync with the equator, what happens is the amount of resistance that you suffer, the amount of air pressure that you have to cut through to be on track with the equator is much more higher. Your sounding rockets do not have that capability. But to be on the geomagnetic equator, there is always a natural gravitational pull towards that. That is the first reason. Second reason is, what is the purpose of the sounding rocket? You need to do upper atmospheric study. The upper atmospheric study is not to find out if how much carbon dioxide or oxygen is there. It is primarily to find out, okay, the sun's radiation is coming. It's giving out some magnetic particles, or it's creating some magnetic phenomena in your atmosphere which is there. How is it affecting our communication systems? All of these things have to be studied. And if you have to study that, it makes more sense to go into the geomagnetic equator point. Got it? So, for the purpose and for the ease of falling into orbit, we've preferred Tumba, which is a closer point to the geomagnetic equator. So we started off by launching RH-300 sounding rockets, and Tumba is the rocket launching site because you have the geomagnetic equator passing through the point of Tumba. Okay, this is just regarding the first launch. If you notice, I'm not saying that it is like a clear anniversary year, but then again, we don't know if UPSC feels very sentimental about this. So the first rocket that we ever created was launched from Tumba, and the launch took place in 1963. Okay, so it is somewhat an anniversary year in 2023. So again, just keep that in mind. SSLV. SSLV is the new kid on the block who's getting all the attention right now, because every other country is so impressed with India's frugal type of launching. Okay, we've managed to do PSLV, GSLV at a very less cost, and now we've created this SSLV also, wherein all your small payloads can be easily launched. Unfortunately for us, one of the first launches of SSLV was not a successful mission. It had carried certain satellites like the Azadi sat and all that, but then later on, it turned out they've done a relaunch of it. Okay, so the first was not a successful flight. Now, the SSLV caters to a launch of up to 500 kilogram satellites to your low Earth orbit on a launch on demand basis. When we later on study the different private space organizations in India. Few years back, we just had ISRO. Right now, we have almost 4 different private space agencies. Now, the reason why we have 4 different private space agencies is because we are planning to bank on all of these developments and do launches for other countries. Okay, so launch on demand basis means you will not have SSLV launches as frequently as we had maybe PSLV. Whenever you have 3-4 payloads to be sent, they would launch an SSLV and put it out. And you take demands from other countries also. Clear? The launch vehicle uses 3 solid stages, and this is one important thing I want you to keep in mind. In some sources, they say SSLV has 4 stages. Okay. And in some sources, they say SSLV has 3 stages with 1 velocity trimming module. Got it. So even if a question does come, SSLV has 4 stages, you can go for it. The reason being that in a lot of places, they've considered this velocity trimming module as one of the stages. And if UPSC wants to confuse you, they will not be asking between 3 and 4. They'll be asking very different numbers. So, you know, that will not be a point to be getting confused in. Now, what is this velocity trimming module? Since it's a new term that is there, we are not talking about all the other technology, but velocity trimming module has been there in use. Any idea what could be the point? It's a very important innovation that India is considering, like, you know, okay, we've done this sort of a thing. Okay, velocity, see, anytime a satellite is launched, or not satellite, a launch vehicle is launched, because of the initial thrust and energy, what happens is the scientist would have determined one particular speed it has to gain. Okay. But what happens is, because again physics happens and you have energy released and everything, maybe if, for example, if 120 units is the speed that they determine, most of the time you will not achieve 120. You will achieve only lesser than that. Okay. Now it's all right if you have several stages of launch. Like for example, you have a GSLV where you lost a speed in the first place. And then after a stage, you pick up the speed. Then you take a 3rd stage, 4th stage, and finally you reach the orbit. So somehow that speed gets made up in the course of the journey. But an SSLV, as I just mentioned, is a small structure which is going to go into the low Earth orbit. So if it has to go into the low Earth orbit, it doesn't have 3-4 stages where it can compensate for it. So what they've done is they've innovated, they've created a module wherein after a point, the velocity of the rocket will be adjusted internally. And this module is called as your velocity trimming module. Got it. So whatever loss has happened at the time of launch will get compensated in the course of the journey using this module which is there. So the point being, SSLV can be a much more efficient launch, when you're launching into the low Earth orbit. But unfortunately, again, in the first launch, which turned out to be unsuccessful, what malfunctioned was this particular module. Okay, so I'm just giving that as an idea, but later on in the relaunches, it has been clarified. Got it? Propellants. What is a propellant? We all, yeah, you read it, you guys read it, good. See, ideally if a rocket has to move, a launch vehicle has to move, it needs two things. You need a fuel and you need an oxidizer. And you know, what does an oxidizer do? It will be some component which ignites the fuel. So what happens is, maybe in the structure, you will have several compartments of your fuels. Fuel will not just start burning by itself. It will need oxygen or some kind of an oxidizer. When it comes in contact with the oxidizer and the oxidizer gets heated up is when your fuel will start burning. But this combination of fuel and oxidizer, which we've been following for a quite long time. If you look at any of our satellites, or launch vehicles which have been there, your PSLV, your GSLV and all of them, we've been using, I told you, solid fuel, or liquid propellant, we've been using all this. It just so happens that when you have a fuel and oxidizer mix, you have to carry all this along with it, right? Which means it increases the weight of the launch vehicle. So now India has innovated on that also. Why should we carry the oxidizer when we have all this air around us? We just carry the fuel and we take in the oxidizer from outside. We'll come to that topic. We have a topic that we'll be dealing with, that innovation. But understand, so fuel and oxidizer just means you need some kind of energy and that is burned using an oxidizer. So popularly you have solid, liquid, all these different kinds of propellants. What is important for us this particular year are your green propellants. Okay, so we are having our sustainability and our climate change concern even when it comes to our rocket fuel, and what we've done is we've created a class of green propellant combinations. So in this category, what primarily happens is, see, you have two kinds of fuels called as your gap and the oxidizer along with it, which is your ADN, ammonium dinitramide. Don't remember all these chemistry names, just telling you this. These are your oxidizer and fuel which is there. Now what they've done is, they have created variants of these both. And they've created a class of green propellants which are hydrogen peroxide, kerosene, liquid oxygen and liquid methane. So right now we are preferring these as your green propellants. Along with it, ISRO has innovated this particular green propellant called as your ISRO SENE, S-E-N-E. Okay, so it is a variation of your normal kerosene. It is your rocket grade version of kerosene, and it is considered as an alternate to this particular oxidizer which is there. So in this manner, they've seen that the emissions coming out from it is comparatively lesser, and they are preferring these green propellants right now. Okay. Okay. Now, quickly on to the cryogenic engine. What are in the cryogenic engine, what are the normal propellants that we are using? We use liquid oxygen, liquid hydrogen, and we prefer it because they liquefy at these particular temperatures. Okay? Just, it's a factual information. If you didn't know, just brush it up. This is the innovation I just told you about. So again, the idea over here is, see, for each and every innovation, there's a core objective. like communication, remote sensing, whatever. Now, in this particular innovation, our objective is to achieve hypersonic speeds. Okay, hypersonic means it's way beyond your subsonic, supersonic and everything. It will be beyond Mach 3. What is Mach 3? Mach 3, no, Mach 6. What is the idea of Mach? 6 times the speed of sound which is there. Yeah, 6 times the speed of sound. So, you need to achieve this particular speed. Now, here is where that entire idea comes in, as I told you. So, if you have the machine itself too heavy, you will require more and more of energy to achieve this particular speed. Got it? So, one major thing is, you don't make the machine so heavy. So, if you don't want to make the machine heavy, then what do you have to do? You will have to get rid of, see, payload is there. You cannot get rid of the payload because that is why you're sending it out. You have to get rid of something else. You have to make the design much more simple. And thus comes in the idea of your Scramjet engine. Why? Because in your Scramjet engine, you are not carrying the oxidizer along with your machine. What you try to do is you're taking the oxygen which is there outside the atmosphere at extremely high pressures, and because of the extremely high pressures, it catches on to the fire and then burns the fuel which is there. This way, they were able to reduce the weight of the entire machine. Now again, there is another thing called as ramjet also. Now understand, ramjet is the predecessor of the Scramjet. Why did we have the ramjet, or what was different? Or just tell me what is the point. Obviously, the speed is obviously different. But again, what changed in the design in the ramjet and the Scramjet? Compression of air. Why? Because if you look at the design of the Scramjet, here what has happened is your nozzles through which the air gets in, the general design of the vehicle which is there, it is all in such a manner where the air has to come in at maximum pressure, the fuel has to be burnt in at a very high area which is there, and after the fuel is burnt in, whatever pressure is getting created, that has to come out of the nozzle in a much heavier manner. So they improved the design, and that is the only difference between a ramjet and a Scramjet. Okay, once they improved the design, so let me ask you, so in a ramjet also, is the oxidizer carried along with it, or is the oxidizer from outside? The oxidizer is from outside. Got it? The only thing that changes is the shape of the design over here. Both of the cases, the oxygen is taken in from outside and it's burnt, and this helps us achieve speeds beyond Mach 6 when it comes to your Scramjet. Ramjet, again, because the design wasn't efficient, the speed falls below your Mach 6. This created India as, or this is a good or very important innovation, because after this, India became the 4th country after USA, Russia and European Space Agency to have achieved this particular feat. Clear? Okay. Before we go into ISRO. Okay, with respect to PSLV, we all commonly know PSLV as, it's a factual information again. PSLV is known as the workhorse of Indian space and all, you know. But PSLV has failed in its mission twice. You all, do you know which are the years? First thing, the first factual information is PSLV has failed in its mission twice. One is in 1993 and the other one is in 2017. 2017, it was your PSLV C39 which failed. Okay, just keep it as a fact. Just note. Come to it. This is enough. Okay, now your ISR. First of all, the most important out of your, I'm not saying the question probability of it, if I had to put it, maybe would be somewhere around your 65 to 70%. That's quite low actually. But if it wants to, out of all these satellite innovations, this is the one that has a very high probability to be asked. First thing is your LVM3. Now let me ask you, this is otherwise called as your GSLV MK3. Then why did they change the name? It's the same thing. Don't think these are two different things. You have GSLV MK3, which I told you it has a cryogenic engine and all those factual information. The new name of it is your LVM3. Why? What changed? Now, they increase the payload. Why did they change the name? What changed was GSLV is your geosynchronous launch vehicle. You have now figured that these category of GSLVs, or ideally these category of launch vehicles, are now not just going to launch into your geosynchronous orbit. We are now going beyond that. We are now even considering other planar orbits which are there. This is the reason why they changed the name. Okay, so LVM3 is primarily your GSLV MK3, but just that the orbital considerations of it has changed. That is why they changed the name of it. This is the heaviest rocket of ISRO, and as I had told you, it is again a 3-stage vehicle which is there. You have your solid state, you have a liquid, and you have a cryogenic state. And here the cryogenic upper stage is using your CE20 cryogenic engine. Okay, now coming on to the fact that, see, now we've achieved all these much bigger payloads. We are planning to launch it into other orbits. So your GSLV MK3 or your LVM3 has a huge role to play in our GAGAN mission. Got it? What is the GAGAN mission? Our human space flight mission which is there. So here you will see something called as a CARE module. Okay, this is primarily meaning that your crew atmospheric re-entry module. After you take up this, normally what happens is you take an entire launch vehicle, goes up to an orbit, places the satellite in the orbit. After that, the launch vehicle will either return back, fall into the ocean, or it might get disintegrated, whatever happens to it. But in this case, you're sending humans in the space flight, so you need them to return safely. And this is the reason why, along with the newer versions of your LVM3, we are experimenting this particular CARE module, wherein it's a huge thing to achieve this. Primarily meaning, instead of just taking it up, you have to return it back, and that is even more riskier. Why? Because when you return from space, you have so much of, it comes at high speed, there's so much of adiabatic compression that happens. Adiabatic compression again just means that because of the speed and the atmospheric friction, there is a lot of heat generated. This heat causes expansion of certain modules which are there in the vehicle, and this is what leads to the vehicle getting disintegrated. So to withstand that and bring people back is a huge achievement. So now they have experimented this, and they have successfully experimented this. Got it? So your CARE module is also experimented, and it comes as part of your GSLV MK3 or your LVM3 version which is there. Okay. Before I go into this, understand, this is one topic which has so many different potential areas of questioning. Starting from the technical aspects of it, we have something called as NAVIC, okay, which is basically your Indian regional navigation satellite system. It's created using your different navigation satellites. We see this as a replacement, not replacement, as a Indian version of your GPS aided version which is there. Now, I'll just list out what are the areas of questioning. One, the technical details as to what satellites are involved in it. The next part is using this NAVIC, we have created two different other systems. One system called as related to your GAGAN, and another one called as Gemini. Both of them are important. Okay. The third kind of question is a comparison between your NAVIC and your GPS. So these three things is what we'll be dealing right now. Okay. First thing over here is, so as I told you, it's the Indian Regional Navigation Satellite System, and here you have 3 satellites in your geostationary orbit, 4 satellites in your geosynchronous orbit. So in space we have 7 of them, but that doesn't end there. On the ground we have 2 points also. So we have 2 standby satellites being kept for any kind of requirement which is there. So the entire the NAVIC constellation consists of 9 satellites. In space, you have 7 of them. Clear? Next one is, these satellites, as you can see, the primary idea is, and this is how it is all unique. You've put satellites in what orbits? Geostationary, geosynchronous. We've already established the fact that geostationary and geosynchronous means it will be like you know, constantly you have eyes watching over you. Okay. Now, we need that kind of a system because the current GPS system that we use is not suited for the Indian terrain or Indian topography which is there. Now, one of the reasons why the GPS is not suited for us is because the GPS is not in your geostationary or geosynchronous orbit. The GPS, we'll study about that in detail. GPS is in an orbit which is constantly rotating, and that is not aligned with the Indian area which is there. Which means we will have navigation, but we will not have full-fledged accurate navigation when it comes to the GPS system. So we needed systems which will constantly look onto India itself, constantly track every part of India. Now, here is where we are like, anyway, we are making this. So why just focus on India? Let's focus a little bit far also. And this NAVIC system extends up to 1,500 kilometers from the Indian borders, which means all our neighboring countries, some part of China, Indian Ocean region, wherever we wanted proper surveillance and strategic inputs, we've managed to extend it into all these areas. Got it? So, understand, this is beyond the Indian borders also. Next thing is, your NAVIC gives 2 kinds of services. One is your standard positioning service, and the other one is your restricted service. The standard positioning service is what we all will be using. The restricted service will be only for authorized users, meaning your military agencies, security agencies, etc. Okay. Now, in this picture, I've already shared the slides with you, by the way. So, if you can, in this picture, I've put all the applications of it, which is anything related to a navigation function. Logistics, supply chain management, your, tracking of vehicles, all of this would come as your applications. Now, we will just quickly look into this. The prime differences between your NAVIC and your GPS. Starts with the line of sight. As I had told you, in the case of your NAVIC, we are having 7 satellites fully focused on our geographical area. So we have a clear line of sight with these satellites which is there. GPS is not that clear for us. So this is the first point, line of sight. Then the area covered. As I told you, NAVIC covers the Indian area and 1,500 kilometers. GPS covers pan globally all around the world. Okay. So understand, GPS, as true to its name, is a global navigation system. Do you know any other global navigation systems? So one is GPS, we already established. China's, you have Beidou. Russia's GLONASS. Yes, what is the system? Galileo. If you don't know these informations, keep a note of it. Anything else? Someone said Japan. Japan has a system called as quasi-zenith, but quasi-zenith is not a global system. Just like our navigation system, it's regional in nature. Okay, so again, just it's technical information, but since NAVIC is important, quasi-zenith, Japan, regional. Okay, so these are all the global ones which are there. The quasi-zenith is regional, as in Japan and areas around it will get covered. Now coming into the different frequencies used. One is, see, if you look at NAVIC, the point being, we said there are two different kinds of usage. One is your common use, which is there, your standard positioning service, and then you have a restricted service. In the case of NAVIC, your standard positioning service happens in your S band and your restricted service happens in your L5 band, which is there. At this point, let's look into this. Just broadly, just have an idea. Whenever we keep on talking about our satellite systems, we say we have different frequency ranges. L band, S band, C band, X band, KU band, KA band. We keep saying this. I don't want you to sit and mug these up, but at least the order in which the frequency changes. So you will understand here L, S5, C, XL, you have an increasing frequency that is coming up. Got it. So here your standard positioning service is in your L5 and here in your S1 you have your restricted service. Otherwise, commonly used, these bands all have specific uses. For example, if you take a KA band and all, it's primarily for your radars of military aircraft. See, the idea is the more and more higher the frequency, it becomes quite, difficult and quite restricted to detect. So this is why for your higher frequencies normally are used for very restricted services. Amongst your S and L bands which are there, the L band is the one which is very, very near and very easily accessible. So our standard positioning service happens in L. And your restricted service, which is your military service of NAVIC, happens in your S. But in the case of GPS, in GPS also you have two different types of service. You have a standard service and you have a restricted service. Both of them fall in the L band itself. Got it. So again, in the case of GPS, both are in the L band. Meaning that their restricted service is not guaranteed. See, even in the L, you have sub-bands like L1, L2, L3 and all that. But again, it is not something that you can have complete security in. So we don't want to rely on that restricted service. If ever India is in a war, India will require restricted service from them. But then their restricted service will be way less accurate than ours one, which is there in your S-band, which is there. Clear? Are you? What is happening? Are you all? Archana, are you here?
Yeah, I'm here.
You're here. Okay. One more person I noticed in the middle. Okay. At the back, is it clear? I know these topics are dicey, but these are topics that have to be dealt. Coming to the number of satellites. Again, this is a very important point to be noted. GPS has a way higher number of satellites. In fact, GPS has 24 satellites in orbit and few satellites in standby, making the entire GPS constellation almost 31 satellites. Got it. We have 31 satellites in GPS. With 24 itself, they've managed to cover the entire world. Now again, in India, you have just 7+2 satellites. But what is the advantage? Those 7+2 are focused totally on our geographical range. Coming to the last point which is there, which is the orbit. We have taken geostationary and geosynchronous orbits. The GPS has preferred your lower Earth orbits which are there. This is the reason why when you have the lower Earth orbit with 24 satellites, all of them you can easily go around and cover the area in a good manner. But accuracy will be a little bit questionable. Again, understand, out of all the services, global services which were mentioned, only China's BDO compares somewhat to your GPS accuracy which is there. Got it. GPS ideal accuracy, they are accurate up to 20 meters. BDO has an accuracy up to 10 meters. In the case of India, and this is a common misconception a lot of people have, our NAVIC is actually accurate, but the accuracy is almost comparable to the GPS level. Got it. But again, what is the catch over here? If you look at the general accuracy, if you take the NAVIC system, ours is somewhere between 5 to 20 meters. Got it. 20 meters is your GPS accuracy which is there. The point being here, because there's a clear focus, we are focusing only on these areas. So even if in these areas you're getting some 15 meters accuracy also, it is a good deal. The 20 meters accuracy which is being mentioned is a global standard which is there. It's not the Indian level which is there. It's an average that the GPS has mentioned. So this is the reason why in some news articles they say the Indian version is much more accurate. But on number level, both of them are quite comparable. Both are around some 5 to 20 meters. It's just that with Indian specific ranges, this accuracy is a really good deal for us. Clear? So technical details covered, GPS covered, then GAGAN, first GAGAN. Okay. Now, since anyway we've created GPS, I mean our own GPS, we have to somehow use the system for our own tracking methods. Now understand, GAGAN at this point is still GPS aided geo-augmented navigation. But what is going to happen is, in the ages to come, GAGAN is something, the GPS part of it is going to be replaced with the NAVIC information that is there. As of now, GAGAN is called as your GPS aided geo-augmented navigation. What happens in your GPS here? The diagram is not very clear, but see, when it comes to GAGAN, it's primarily used for your flights and tracking related to the flights and all. The reason being that, again, see, when, as I told you, the GPS that we are using right now has an accuracy problem with respect to India. This accuracy problem gets even worse when we have different weather conditions also as a hindrance, because we are a country which has very varied weather conditions, climatic systems. So at this point, most of the time what happens is there will be a small error factor when we are using your GPS. GAGAN tries to overcome this error factor. And how does GAGAN do that? GAGAN does that with a system of 3 satellites in the space, and you have 2-3 different kinds of stations on the ground. It basically the entire, you don't have to know the entire mechanism of it. The idea is basically, see, you are trying to reduce the error. Error gets reduced when it keeps on getting calibrated by different satellites. So you will have a first satellite which will be observing a specific area, giving a certain information as to the location of something, relaying it to the ground. Once it reaches to the ground relays that information to the second satellite. The second satellite tries to reconfirm that point, and if that gets reconfirmed, sets to the third station which is there. And the third station again looks at both of, if they are saying, okay, there is a difference of just maybe 1 meter or something, they will recalibrate that again, send it to the third satellite. The third satellite will again observe, send back a value. At the end of this, they will look at the values and the errors that each of them have made and give a final position which is there. This is what is happening in the GAGAN system. So why is it called as GPS aided geo-augmentation? You are using GPS for this, correct? Because you have to figure out that whenever NAVIC becomes into a fully functioning manner, you will replace it by NAVIC. But at this point, you're using GPS. and you're augmenting the GPS signal. Augmenting means what? You're making it better. Got it? So the GPS signal is there, you have augmented the GPS signal and you've created a final position. This is the idea of your GAGAN. So to do this, you have, the idea is it's a space-based augmentation system. You understand, space-based augmentation system means the major part of this is actually coming from your satellites which are launched in your space. It's run by ISRO and the AAI, the Airports Authority of India. So what they do is they provide GPS signal corrections, giving you better position accuracy. Again, until now, if you look at it, there are only 4 space-based augmentation systems available in the world. Now there is GAGAN, there is an US WAS, there is Europe EGNOS, and a Japanese MSAS. So again, by creating GAGAN, we've also fallen into that elite list of space-based augmentation system countries. Okay, again, right now when we keep hearing we are the 4th country, 3rd country, you'll be like, yeah, I will remember this. Trust me, at that point you'll remember, US is there, USA will be there. Then it'll be, was it Japan, was it China, was it something else? You will get confused, so note it down somewhere, keep revising that portion. Okay, they've asked questions specifically like that. Okay. Now I mentioned about GAGAN. Now there is one thing that has gone into the backs of the minds of newspapers, but then we have to discuss it. It's called as Gemini. Okay, Gemini again, just like we have GAGAN for your flights, you have Gemini for your seas. So Gemini is basically GAGAN aided mariner instrument for navigation and information. Don't write the full form, just remember it's for mariners. Mariners means your seafaring people. But this is again GAGAN aided system. GAGAN was geo-aided system. Gemini is GAGAN-aided system which is there. Don't, I mean again if you want I'll tell you the full form again. GAGAN-aided mariner instrument for navigation and information. Okay. This is run by INCOIS, INCOIS, and again the Airport Authority of India. Airport Authority, AAI, because it's GAGAN system that is there, right? They are using GAGAN aided. Again, the G over here doesn't stand for GPS. GAGAN is based on the GPS aided. Gemini is based on the GAGAN system which is there. So whatever information GAGAN gives is what they are going to use. So understand again, the satellites and all are the same itself. It's just from their side you have your Airport Authority of India managing the system. Again, one more important information. This is not just a navigation system. It also gives information about potential fishing zones which are there. Got it? Navigation is one part. Along with it, you also get information about your potential fishing zones, any disaster warnings, all of these things are given to these systems. Ocean, okay, ocean states forecast, potential fishing zones. Comes the next system which is right now they are using GPS, but all of these systems will convert into NAVIC based systems. I mean otherwise we would not have done this with so much of vigor, right? Okay, next one, pride of India, you have your Chandrayaan 1, Chandrayaan 2. In August we are very soon to have a Chandrayaan 3. So then our point is to compare each of this and understand it. What is the difference between each of these systems? Now understand, because Chandrayaan-1 is the oldest, you have more question chance from the oldest one rather than the ones which are new. So let's try to understand. So this is the moon mission of India, first of all. And Chandrayaan started, your Chandrayaan-1 mission is primarily there from your 2008 period it was launched. And then by 2009, it got stopped working. This is a lunar orbiter and impactor mission. Orbiter, I hope you all understand. What is an impactor mission? And what is the difference? I mean, primarily what I want to know is, what is the difference between an impactor mission and a rover mission? Because the next time we launched, you can see, we launched rover also. And what is the difference? So then what's lander? Just falling. You're somewhat right, but what falls? You don't have the thing going and falling over there. Okay, let's make these terms very clear. Orbiter, I hope you all understand. Impactor and lander are two different things. And obviously rover is a different deal altogether. Impactor means you don't have the launch vehicle impacting. You don't have it. Instead, you will have certain mechanisms from the launch vehicle. Now think of it like a big sort of a thing or some sort of a huge digging thing that can be there. That thing will get impacted onto the surface. Why? Because for the substance or for the launch vehicle to come and land, you need much more better technologies which is there. So you don't start off with your lander missions which is there. You start off with your orbiter, then you go to your impactor, wherein you have specific mechanisms which will be released from the machine. Those will go and impact onto the surface. Now, I always have a picture of this kind. The reason why I told you it's a huge axe sort of a thing is, in the picture it looks like some kind of a tube that has come. It is just landed. What happens is, it will impact the surface with such a force, so much so that it will be able to collect some debris from there. Got it? It will be able to collect some rock or something from it and later on do the experiment for it. Got it? Now the difference between that and a lander is, in a lander, you actually have it landing on the surface which is there. Got it? And again, when you land and the thing starts moving on the surface, that is your rover. Got it? Orbiter moves around the celestial body which is there. Lander lands and remains stationary. Rover lands and moves around the surface. Okay. So when I'm saying Chandrayaan-1 was only an orbiter and an impactor mission, what you mean is, you had one part of it which will go around and one part which would collect a sample and come back. Got it? This was launched by our PSLV XL machine which was there, PSLV C11. The weight capacity of it was 1380 kilogram. And don't study all of these as the specific numbers, just have a rough idea of the number in your mind. The idea of Chandrayaan-1, because primarily you're not moving around the surface or anything, was to image north and south pole regions of the moon, where you have, these areas are considered to be in permanent shadows. We do not see it in a clear manner. So we had to do some imaging of it. And to search for surface and subsurface water. How would you do that? When you collect your sample and do experiments on it. This is where we wanted the surface and subsurface water to be tested. Now again, you can see that Chandrayaan-1, out of the missions that we've sent, Chandrayaan-1 is a fairly successful mission. Why? Because we didn't find water on moon, but then we had evidences which would indicate that there would have been water on moon. So there was some kind of hypothesis which we got, and this is the reason why we decided, okay, let's go for Chandrayaan-2, where we can land and move around and collect proper samples. It also confirmed the magma ocean hypothesis. Again, remember, magma ocean hypothesis is related to the formation of the moon. moon which is there. The idea being that once upon a time, the moon was an entire molten ball of things which got solidified after a period of time. That is called as your magma ocean hypothesis, and this got also confirmed through certain proofs from the Chandrayaan-1 mission. So it is a fairly successful mission. Okay. Now moving on to Chandrayaan-2. Chandrayaan-2 will forever remain a very sad thing in our minds, because I'm pretty sure most of us would have just watched that image of, okay, is this going to happen? And we were just very lost when, you couldn't find the systems after that. It was launched in 2019. The orbiter is working from then onwards. Okay, until now the orbiter is still working. This was an orbiter, lander and rover mission, and we are doing a mission like this for the very first time. Okay, it was done on a GSLV Mk2 machine which was there, and the entire payload was 3,290 kilogram. So again, roughly 3,300 kilogram. Again, the findings of Chandrayaan-2 are yet to be fully formulated. So we do not have anything definitive happening because the mission is still underway. Now, again, we are still planning to go forward with Chandrayaan-3, because right now this will be there's no orbiter part. Because orbiter we've proven, and we have got we have a Chandrayaan-1 orbiter and a Chandrayaan-2 orbiter also. So now we are not sending an orbiter, we're going for a rover lander mission, and this will be launched by our very own LVM-3, which we just discussed some time ago. Got it? And they are planning to, even when Chandrayaan-3 is there, they are planning to put Chandrayaan-2 in the orbit itself. Because you need an orbiter mission to communicate things. You will have Chandrayaan-2 in the orbiter itself, and Chandrayaan-3 will be going and landing and doing the rover part. Okay. Just broadly, major missions to moon which was there. You have your USSR which had, any doubts? What happened? Doubt. Doesn't have? No, it doesn't have orbiter. I didn't write there, right? Did I write that? No? It will only consist of rover and lander. That was in fact, the distinguishing factor between the Chandrayaan-2. What is the doubt? That was the doubt. The major missions to moon, just have a quick look through it. You have USSR which has the Luna missions which is there. Luna 2 was the first spacecraft to impact the moon surface. Again, so now you know impact is totally different from landing, because landing mission was a different one, the first landing mission. Impact means it is the one that went and collected the samples in a proper manner. You have from USA, you have the Lunar Orbiter 1. You have Apollo 11, which carried the first humans to land on the moon, which is there. And right now, you also have this new mission called as Artemis. Japan's mission is Hiten, and then you also have a Selene mission of your moon. Then China has a Chang'e 1 mission related to your moon. Which is what? Okay, 2, 3, fine. Stop, 1 minute. Now we have to discuss about our Mars mission, but not in detail. Yeah. So again, we've had our Mars mission. When did we launch our Mars mission? It was launched in 2013. It became functioning in 2014. It is the first interplanetary mission that was launched by India. It made India the 4th country to have a Mars mission, and the other one was, which are the other countries? No, these are not the other countries. Which are the other countries which were there at that point? Who said China? This is exactly what I told you guys will happen after a point. You have US, you have ESA, and you have Russia. These 3 were the countries which had launched a Mars mission prior to that. This made India the first Asian country to go into the Martian orbit. ESA, European Space Agency, EU. This made India the first Asian country to reach to the Martian orbit, and also the first nation to do that in the first orbit, first attempt. Understand, the primary mission of your Mangalyaan or your Mars mission was to understand the topography of Mars. But it also had a secondary mission, and that was to study the moon of Mars, which was otherwise called as your Phobos. Okay, so that was also part of the agenda of your Mars mission. Then again, we are having a Mangalyaan again coming up in 2024. You will be having another series of Mangalyaans again coming up. At that point, it is being touted that if the Gaganyaan is even prior to that, if it comes out to be successful, we might send a full-fledged rover mission onto Mars. That is what is being thought about, but again, it is not confirmed. 2 more things. In your Mars mission, you had 2 major components. You had a methane sensor and you had a Mars color camera. I normally do not discuss the payload of things, but this is something that has constantly been seen in the PIB as a very important thing. So the Mars mission that we launched then had a methane sensor and you also had a Mars color camera. Okay, one more thing. In the earlier NAVIC system, which was there, one of the reasons why NAVIC is considered to be an accurate system is even because 3 of the satellites in the constellation carry rubidium atomic clocks along with them. And these are very, very accurate clocks that will measure your, any even small errors which are there. So rubidium atomic clocks in 3 satellites. That is also one of the reasons why NAVIC, we're talking about NAVIC, which we discussed 2-3 slides ago. That system, it just came to my mind, just keep a note of it. Okay, now again, just have a look at this. Right now, there are some ongoing other Mars missions which are considered. One is your Perseverance, which is by NASA, Hope mission by UAE, Tianwen mission by China, and your MMX mission by Japan. These are the ongoing considered missions which are happening. Do you want to break right now or at 12? At 12. Next, coming into your Gaganyaan, which is your human space flight mission. Here again, you have your LVM-3 considered as the mission, the vehicle that will be launching it. Now you do realize this is the reason why LVM-3 happens to be very important, because for our future Chandrayaan, for our future Gaganyaan, for all of these we are considering your LVM-3 launch vehicle. The idea is to send 3 astronauts to the low Earth orbit range of 400 kilometers. Okay, and this entire mission is also having something called as the environmental. This is an important thing. The environmental control and life support system is an added feature of this mission. This is what enables this entire spacecraft. See, there are 2 major aspects. You have to entirely launch this thing, bring it back. While they are in space, because you're sending people in it, they cannot have, or they will obviously have differences in with relation to their, movement and things like that. You need to have a good atmosphere, a good environment within the spacecraft to ensure that they do not go through any other kind of health issues. And this is the reason why you need this, the environmental control and life support system. And this is in relation to your Gaganyaan mission. Again, this is also a system that has been successfully demonstrated. Okay? Again, from the time AstroSat was launched, UPSC has asked the questions related to it in several forms. Okay. Now, one was a direct question. Now, what exactly is AstroSat? Is it a space observatory satellite? So here, it was launched in 2015. It is a space observatory satellite. The idea is you are not looking at the Earth, you're looking outside. You're checking out what all is there out in the space. The reason why it becomes an important mission is because it has, or it can see celestial sources. It can look at or try to detect the waves in X-ray, optical and UV radiations simultaneously. Previously, you've had missions which go and detect UV radiations alone. You have systems which go and detect your X-ray alone. But AstroSat is a multi-wavelength space observatory, meaning all these wavelengths can be observed in a simultaneous manner. This is the reason why AstroSat becomes important. Okay. Now, before we go into the private space agencies, I have to tell you a few details. Again, it's all factual information alone. Just give me a minute. AstroSat again was launched by your PSLV C30. The time span of it was initially considered to be 5 years, but now it is still remaining in the orbit. Now, we have another mission that I have not put in over there, but have you heard about the NISAR mission which is there? Okay, so you know that. Okay, NASA and ISRO. Okay, and the idea is it is an imaging satellite which is there. So, no, what was it? Tell me, I didn't hear it. You didn't understand. The heat is making me hallucinate things also, I guess. Imaging, yeah. It is an imaging satellite. We launched it into the sun synchronous orbit. One other current affair I have not added in this list, but has become important in the last 2 years. I don't see so much question potential, but then I'll feel very guilty if I don't tell it to you when it comes for the exam. There has been the inauguration of something called as your Human Space Flight Center. Okay, now when we are launching Gaganyaan, on the ground, the entire ground support of it will be given from this Human Space Flight Center. It's a center that has been launched, but it was launched after a lot of controversy. It is in Karnataka, specifically at the Shalkere, or how do you pronounce it? Yeah. The specific space. And the reason why it was controversial was because you had certain tribal people grow in this specific area that were quite opposed to the bringing of the center over there. You had the local Kuruba people, And finally, but then again, after all the controversy and everything, the center has gotten inaugurated. So again, that is there. It's not a major thing, but again, at the off chance something gets related to it, just remember. Oh. Now, in this new age times, we have moved away from ISRO. We have ISRO at this point also, but then the space policy of India dictates that a lot of activity has to be given to the private sector also, and thus we have 4 major agencies which have clear 4 different agendas also. Okay, so your aim should not just to be by heart the names, but also understand clearly what their agenda is. First one being your in space. Now, in space, consider it like infrastructure space. Okay, for you to remember easily. The idea is the Indian Space Research Organization has a lot of infrastructure, testing facilities and everything. It is normally only used by the ISRO. In-space facilitates the idea that these things can even be used by private companies at a particular fee which is there. So, for private companies to use Indian space infrastructure, it is being taken care of by your in-space agency which is there. And also remember, anybody who wants to take place in any of the space related activities, if it is a group of, for example, there are a lot of colleges which launch your small satellite payloads and all that. If you know, I think in Tamil Nadu, the Nurul Islam University had launched something like that. Even in Bombay, there was an institute. Yeah, anyway, the idea is whenever you have these groupings also which want to launch anything, you can directly approach your in-space, and the in-space will connect you to ISRO. Got it? So this is primarily using facilities by private companies and private individuals. Then you have your New Space India Limited. New space, again, let's think of it like, okay, you are trying to create something new over here. So the newest kid on the block, as I had told you, your SSLV is being managed by your New Space India Limited. And the idea of New Space India Limited is it came about in your budget 2019, and the idea is you have to develop your research and everything, but you have to do it through your private parties also. So now the idea is any research and development that will be useful for the Indian space sector, you can bring it to New Space and you can have the research happening over here. Apart from that, if you want to have your launches through your SSLV, that will also be taken care of by your New Space. Okay? Then you have the Indian Space Association. Indian Space Association is not as it is a commercial wing or anything. It is primarily a grouping. Think of it like a club. Association, Indian Space Association, wherein your normal government authorities which are there in the Indian space scene and your private authorities, they all come together and discuss on what all new innovations can be created. So here there is no research happening, there is no development happening. It's primarily a forum, it's like a collective forum which is there. Got it? So collective body of the Indian space industry, your leading domestic and global corporations and everything can come over here and discuss the new age developments which are there. So you know, now in your mind you should have an idea which out of the three ones that we've discussed until now, your New Space is the real deal thing. Okay, this is like, okay, it is a grouping which is there, but this one is the beginning of all of this. Antrix. Antrix is the official commercial arm of the Indian Space Research Organization. It is a wholly Government of India owned company under the control of Department of Space. Now, Antrix is primarily, think of it like the marketing arm of ISRO. See, until now when we were telling of all the other ones, we didn't relate anything to ISRO. If we talked about in space, it's a separate deal altogether where ISRO's facilities can be used. New space, it's SSLV that is being used. Here what happens is, if ISRO is creating something like a new PSLV and that needs to be marketed to the other countries, that will be done by your Antrix. Got it? So it's the marketing arm of your ISRO for promotion, commercial exploitation of space products, consultancy services, etc. So if I had to place it in an hierarchy, you have Antrix, new space, in space, and the last, that ISPA thing which I mentioned. Okay, have that picture. Apart from this, few innovations that just need mention are these ones called as your Mission Prarambh and a new private launch pad that we have launched and unveiled at your Sriharikota. First, let's start with Prarambh. Mission Prarambh is primarily, again, see, right now you've already invited all your private agencies into developing. So nowadays, what will happen is you're going to see a lot of more private launches also. Mission Prarambh primarily was involved in the launch of Vikram S, which is India's first privately built rocket. Okay, so Vikram S, India's first privately built rocket, came under the ambit of this Mission Prarambh. Mission Prarambh in the sense is this mission wherein you have private sectors being connected to your ISRO for your technology and things. Got it? So Mission Prarambh is for the private companies and right now it's in news because of your Vikram S rocket which is there. Vikram S, you don't need to have all the details over here, but if you are interested, it is a single stage rocket. And again, look at this, it was launched with support from ISRO and in space. Then, as I had mentioned, the second current affair, wherein we have launched or we are having a private launch pad. What is a launch pad? Again, the area from where you can send out rockets. And here they have launched this called, it was designed by a startup called as Agnikul, and they have launched in support of ISRO and this thing. So I put this current affair for you to understand not only rockets, even your launch pad and other accessories associated with it is now put forward for the private sector. Okay. This is one word you see constantly in different forums right now, something called as space situational awareness. What is the idea? What is space situational awareness? Just give me a minute, let me drink water. Tell me, yeah. Space debris, okay. That is one part of it. Anything else? People at the back, what is space situational awareness? Understanding situation of space. What is the situation of space like?
Space debris, how much it covers.
Okay. You said debris. He's saying if any satellites are coming and hitting something. Okay. Tracking and analyzing what? Space debris. Okay, space debris. Fine. Okay. Space situational awareness is something that you all have just mentioned. The idea is that you have several, because you have the onslaught of a lot of different satellites onto your space at this point, which has led to certain other problems like, what is the issue with the space debris? What is the syndrome? Kessler's syndrome. So because of all this, there is an onslaught of space debris happening, and again, as you had mentioned, there is an issue of space debris interacting with existing satellites, and this also affecting the navigation of the existing satellites. So each country now, though they are bound by 5 major space treaties and everything, are now taking up specific criteria to go and find out, like, okay, is our satellite safe? What all can we do to prevent any kind of hitting of things and so on. It is in this aspect that India has had these two innovations. First is Project Netra, and second is we've opened a situational space awareness observatory. When we say we have opened, again, it was opened by a private company called as Digantara. Okay, so again, this is a private venture where we have opened a space situational awareness observatory wherein they'll be observing only this. If anything is getting in the path of Indian satellites, if any space debris is going and hitting anything, all of those things will be checked. Now, Project Netra, on the other hand, is a mission solely launched by ISRO. It is an early warning system to detect space debris. It can even detect objects as small as 10 centimeter at a range of almost 3,400 kilometers. That means from there onwards, if anything is coming and falling onto our surface, coming into our orbit or anything, all of that can be detected by our Project Netra. Apart from this, something I just found interesting, I have just put over there. You have a space situational index getting published, and you have your World Economic Forum publishing it. Don't normally expect your World Economic Forum to do this. So again, so you have your SSA index being published by them. No, normally when you see space situational index, you might think NASA or some space agency, right? So that is POEM platform. How many of you know what POEM platform is? I have asked this in one class and I've got such varied answers for this idea, because if you read a normal article, I don't think this idea gets very clear. How many of you know what the POEM platform? This is in the last 2-3 years, this is one thing that India has again done in the aspect of space situational awareness and reducing space debris and everything. But what is POEM platform? It's a platform. I didn't know that. What else? Anything, any idea related to it? Okay, let's rewind back and think of PSLV. You remember PSLV? I said there are 4 stages. Yeah. Now, solid, liquid, solid, liquid. Now, what happens when it comes to a PSLV is that, see, you will use the first 3 stages, and by the end of the 3rd stage, you will get out of your Earth's gravitational pull. Okay. The 4th stage remains as space debris. Got it. Now, this India is very concerned about. So, India said, let's reuse this 4th stage. So, now what they do is, instead of the 4th stage just lying around like a space debris, the 4th stage of the PSLV is fitted with very minimal things. Like, for example, it will have a camera, a sensor camera maybe. Then it will have some solar cells, because it's going to be powered by the solar energy. You'll have very minimal things, and they convert the 4th stage of your PSLV into a mini observation module which is there. This is the idea of POEM. Got it. It's PSLV orbital experimental module, wherein you are just, it is not like, okay, it will be there for 5 years or anything. The idea is, while it is there, let's utilize it on some aspect, rather than it just going and hitting onto. So again, the good thing being, see, normally the 4th stage is just left out as space debris. The task which ISRO completed over here is, you have to take this 4th stage and you have to put that also into an orbit. Got it? You cannot see it. The issue with space debris is what? It does not have a clear pathway, thus being a cause of concern for others. What ISRO achieved over here is the fourth stage, they took it till there, they didn't leave it out, they put it into an orbit and they put some extra payload and sensors on it, so that this will be able to do very small experiments and very small observations out there. Got it? So this is actually the second major dedicated mission of your New Space India Limited. Which is the first major mission? Guys, SSLV, New Space India Limited's first major mission is your SSLV. Second one is your POEM platform, which is there. And here you can see the fourth stage of PSLV would orbit around the Earth as a stabilized platform, which will have its own navigation and control system. Got it? It will be having a system which puts it into place like you cannot call it a satellite also even. A very mini sensor body but having an orbit. Okay? This is your POEM platform. Again, see, until recently we just had to remember if ISRO did it or not. But now you have to remember if it's New Space or In Space or whoever has been part of it. So the previous Prarambh and everything was related to In Space. This is related to New Space. Okay. Another discovery for this year is your Saras-3 telescope. Okay, before I go on to Saras-3 telescope, I just want to know if you know the terms clearly. What is cosmic microwave background? What is CMB? After this, I'll ask you a much more fundamental question. So let's maybe figure this factual thing first and then go into the fundamental thing. Cool. Okay. So radio waves left behind during the Big Bang. But what is the term that I just mentioned? It's cosmic microwave background. What has happened to these waves? Are we able to detect this at this point? Do we have CMB in our space? We do have it. How do we have this? Because he just told me it's at the time of the Big Bang. I mean, how so? See. The point being, the waves that would have originated at the time of the so-called Big Bang, what happens is it is not stagnant. It keeps on moving. And we do not know where this Big Bang happened also. Got it? We are just thinking, okay, so this has happened over there. Now you have to understand, as waves keep on moving, their frequencies and wavelength keep changing. But still, when we look out today in the globe, when we look out today in the space, we'll be able to find traces of this wave that is there. Once we find traces of this wave, we can have some information about what your Big Bang was. Got it? So this is what is being seen or what is being called as your cosmic microwave background. Now my point over here being, the reason I discussed this is, when you let out Saras-3 telescope, and this is this year's innovation which is there, it was given out by the Raman Research Institute. This is a high precision radio telescope which is there. And the radio telescope we have launched to detect extremely faint radio wave signals from the cosmic dawn time. So what is your cosmic dawn? Cosmic dawn is primarily the period from about 50 million years to 1 billion years after the Big Bang. You will not reach till the Big Bang point. It's 50 million years to almost 1 billion years after the Big Bang is where we term it as cosmic dawn. So if a question comes, cosmic dawn is synonymous to Big Bang, that is wrong. It is not synonymous to Big Bang. Big Bang happened, several years later you have your cosmic dawn happening, and this specific telescope, the Saras-3, is trying to detect signals from this particular thing, in the hope that even if you get signals from the cosmic dawn, you will be able to make an assumption about the Big Bang which is there. Got it? Your Raman Research Institute is an autonomous research institute, by the way. Again, coming under the control of ISRO, but autonomous in nature. While we are on the topic of cosmic microwave background, if I had to ask you what are the most famous evidences of, or not evidences, at least you hope to get evidences of the Big Bang from, one we've already told, cosmic microwave background. Any other ideas that we know? Evidences of the Big Bang, actual evidences, not some book or anything, some actual evidences. Gravitational waves. Until 4-5 years back, it was always touted as a favorite part of UPSC. Gravitational waves, cosmic microwave background, your redshift phenomena which happens. What is your redshift phenomena? Yeah, as the object moves farther and farther away, the wavelength moves closer and closer to the red spectrum which is there. So this again is the idea that, okay, from the evidence part of it is that, okay, something got created somewhere and it kept on moving at a steady pace, and today when we detect something, we will be able to understand, looking at the wavelength of it, how far it would have traveled, what is the energy of that specific wave, and based on this we can have a calculation of how far this would have happened at, and at what time this would have happened at. So these are some of the evidences you get from the redshift phenomena. So redshift, cosmic microwave background, gravitational waves, planetary structures. Where, for example, suppose there was a Big Bang somewhere and the waves started off from there and the waves kept moving away and away and away. So as generally, if you take any spectrum, if a wave moves away from, or as it keeps on moving, its wavelength would be, it would keep on varying, it would keep on increasing towards the point that by the time it reaches to the red spectrum, if you take your VIBG or spectrum, that is only the visible, but I'm saying in the normal also, red spectrum means your wavelength would have been extremely large. So at this particular point, you will be able to detect it. Now my point over here is planetary superstructures, but again, let me ask you, which planet? Can all planets be evidences of this? Did all the planets in the solar system form at the same time? Who formed first? I mean, which of the planets formed first? At least in our solar system, can you tell me? Sun is planet. Huh? Sun. In our solar system, which planets got formed first? Don't tell me new exoplanet and all that. Who? Guys, I thought you knew this part. That is why I didn't take that part only. Your Neptune, Uranus, Jupiter, Saturn. These got formed first. Then, I didn't hear your answer. They've been going on saying some very funny answers, that's it. And then you have the other planets which are your Mars, Earth, Venus and Mercury that got formed later. So, primarily, your planetary structures of these earlier born or earlier created planets are preferred. Then maybe on to the newer ones we'll be going. But this is the reason why if you look at NASA and all, NASA has so many Jupiter-based missions, so many Saturn-based missions. The reason being, from these older planets, you will be able to get some evidences of the formation of our solar system and of the Big Bang also, because they formed much more earlier. We are relatively newer planets which are there, Earth, Mars and the rest of us. Okay, let's move on to from the ISRO perspective. This is one thing that has been, again, we have to place it in the context of a larger issue. We are going to discuss about something called as your high throughput satellites. Okay, online guys, is it clear to all of you? Is my voice audible, video visible and all that? Can anyone respond? Yeah, okay, fine, cool. Siddhi, I'll get back to your doubt. I didn't see it earlier. I'll get back to your doubt. Now, here you have a category of satellites called as high throughput satellites. High throughput satellites, primarily because of the area it covers, can give, or their communication ability is extremely high, which means to give internet to those underserved areas, to those unserved areas, to rural areas and all that, you can use these high throughput satellites. So it is in this context that specifically these satellites which I am going to name, GSAT 11, GSAT 19, GSAT 20, and there's one more which is your GSAT 29. 1 minute, I just confirm, don't write 29. 1 minute. Yeah, 29. Okay, 11, 19, 20, 29. These 4 satellites are touted to be the high throughput satellites of India. And the important thing over here is, do you know about this digital connectivity program of India, wherein the rural areas, they are planning to have high-speed internet connectivity in your rural areas. It is these satellites which will be providing the internet connectivity for this mission. Now, we have to discuss this because if you look at all of them, 19, 20, 11 and your 29, all of them fall in your geostationary and geosynchronous orbits. This high throughput satellite program of India is in direct contention with the Starlink program that is right now there by your SpaceX. Got it? So this is the reason why maybe you will be constantly hearing about Starlink, but at every article related to Starlink, they will try, if it's an Indian article, they'll try comparing it with the high throughput program. So when we study Starlink, we'll be again calling back the information of these things, but as of now, understand, these are communication satellites in your geostationary and geosynchronous orbits, and there are 4 of them that is intended to provide internet connectivity to rural Indian regions, rural, underserved, unserved areas of India. Now, with that, we'll quickly move into, see, even when you study also, I want you to have this thing in your mind. First, go through the concepts of space, then go through ISRO missions, then if needed, just go quickly through your NASA missions, and especially the NASA missions that I have put into these slides. Then, if at all needed, if you have time, go into the other ones. If you don't have time, you can very conveniently skip those other space agency missions. Now, coming into your NASA missions, the first thing that we are going to discuss is your Kilopower project. Okay, Kilopower project again is a NASA mission which is primarily intended to create a small nuclear power source to fuel your satellite which is out there in your space. Normally, your satellites which go out over there either use your solar energy, they convert it into some electric, they capture solar energy and they use whatever after capturing solar energy, convert it into electrical energy and the satellite uses it. Here, what they are planning to do is, instead of constantly relying on solar energy, what is the problem when you rely on solar energy? And the answer to that is in your 2022, one question was there about solar flares. Okay, so when you have solar flares, there would be random upheavals in your solar energy, thereby even damaging the satellite system. Solar flare means high energy radiations that come out from the sun. So now again the point being, to compensate for that, they figured out, let's have a very small nuclear reactor on the satellite itself. Now, when they say nuclear reactor, what kind of reactor? It is a nuclear fission reactor which is able to generate 10 kilowatts of electrical power. So, you can imagine the size of it. It's an extremely small reactor, but it's equipped to fuel the entire, power the entire satellite. This is the idea of the Kilopower project. Okay. Now, again, Kilopower project, if it was nuclear power on this satellite, you have a new area where NASA is venturing into, and this is called as nuclear thermal propulsion rocket. The idea is pretty much obvious, wherein you are going to use nuclear power to send the launch vehicle outside. We've not yet done that. We've used solid, liquid, different kinds of fuels, but here it's going to be a nuclear powered rocket using the propulsion of nuclear power, it will be sent into the orbit. Primarily, you're going to use a uranium core for this activity. Got it? So, don't get confused. Kilopower is for powering the satellite out there. Nuclear thermal, and this is a newer current affair. Kilopower, if it's 2 years old, this is a newer current affair which is there, wherein you're planning to propel your rocket itself with nuclear power and put it into the orbit. Okay, clear? Moving on to the next one. Again, comparative study. Again, I've seen this one thing. See, you have James Webb right now, which is all the hype. Okay, but previous to that, you've had a Hubble telescope. And even previous to that, not previous, almost simultaneously with Hubble, you've had another space telescope called as a Herschel space telescope. Okay, so we will not be comparing Herschel because Herschel was a very not so great version of these. We'll be comparing your James Webb and your Hubble primarily. James Webb and Hubble, first thing is obviously it's beyond doubt that James Webb is a better candidate out there with reference to capturing your space images. Now, what makes James Webb a better candidate or better, observatory system which is there? First thing, the location. Hubble was placed in your low Earth orbit. Okay, but whereas your James Webb is going to be placed in the L2 region. L2 is your Lagrange point 2 region. You don't have to get too worried about the Lagrange point. Lagrange points are those specific points in space where the gravitational pull of the sun, the earth and the moon remain balanced in a way so that you will have a stable place for the satellite to dock. Got it? Primarily Lagrange points, you have a lot of different Lagrange points. You primarily look into the moon and earth's gravitational field first. Then you consider the sun's also, and then you dock a point. But anyway, my point being Lagrange point 2 is much higher than your low Earth orbit which is there. Got it? So here the location is in its favor. Why is the location in its favor? Again, what is the point? If it's much higher in orbit, what is the good deal about it? Same point. Again, it's not like, okay, it will be higher, so we'll have the clearer view comes because there are no other interferences between any other frequencies coming in. Got it? If it was in a much more lower range, you have your communication satellites, you have all these other frequencies operating over there. Detection becomes quite difficult. So here, if it's in a higher orbit, it's a good deal. Second thing is the size. Not so important, but then remember the mirrors used in your Hubble was only 2.4 meters in diameter, but the space James Webb has a much bigger or larger mirror which can be used. Next thing is the images captured. Again, the images captured get better because of this next particular point also. While your Hubble can work only at your optical and ultraviolet wavelengths, your James Webb can work at infrared, optical and ultraviolet wavelengths. Got it? So in all of these ranges, whenever anything is getting irradiated from the space, these will be able to detect it and capture the picture of it. Got it? Okay. Next thing is this particular point. The path of Hubble passes through something called as the South Atlantic anomaly. There is a South Atlantic anomaly wherein what happens is, as the Hubble crosses through, there is a dent in the Earth's magnetic field. We cannot see the Earth's magnetic field, but the idea that there is an imaginary field around it, and at certain places what happens is when the satellites cross over, it severely affects the mechanism. For example, if there's a clock in it, if there's a compass, if there's a navigation system, all this gets affected by this dent in the magnetic field. It also gets affected because at those particular points, even the capacity of something to capture pictures also get impeded. But the good point of James Webb is the path of James Webb does not cross through this particular anomaly. So again, South Atlantic anomaly is also eliminated. Again, the last point is a consequence, I would say, because of all these things. Your James Webb is planning to go through much, or the range of galaxies and things, or the expanse of it is, it's planning to go beyond much range. The reason I say it's a consequence is because it's having a better mirror capacity, it's having better technical specifications, it's having better wavelength capability. This is the reason why James Webb can look into much more larger ranges in comparison to your Hubble. Okay, broadly, if at all they ever want to ask you a question, I'm quite sure if they want to ask a question on James Webb, it will be, they'll pick a point of Hubble and they'll put it under James Webb. That is the pattern that they normally do these things in. So get that in mind. Now moving on to your next observatory. Sophia Observatory is now being pulled back by NASA again, but while the time Sophia Observatory was there, it was a very, very important observatory. Now what is the idea of Sophia? Sophia is a stratospheric observatory for infrared astronomy. While it was in mission, it was the largest airborne observatory in the world. Now again, there are two things. There is airborne and there is, thank you. There are two things. There is airborne and there is space observatory. When we talk about your James Webb and Hubble and everything, we're talking about space observatories. Now, airborne means you have this observatory constantly moving through your atmospheric regions. So, Sophia was the largest airborne observatory in the world. It was a combined mission of NASA and German Aerospace Agency. It covered at the altitude of 39,000 to 45,000 feet. All this is there, but the important observation created or which was there by Sophia was, it was for the very first time that an airborne observatory could detect ionized carbon. See, normally what happens, again, it shouldn't sound like Greek to you. See, what normally happens is, carbon is not something like, as you can call, a radioactive thing or anything. Okay. But it just so happens that in space, wherever carbon gets radioactive or there is ionized carbon, I told you this also yesterday, there would have been the probability of life at some point. Got it. We talked about radioactive carbon, we have talked about carbon dating and all yesterday, if you remember. And I told you there is a specific radioactive isotope which radiates things and we are able to detect age that is on the Earth. Now, in the atmosphere, at the probability of having some ionized carbon, when you go find the source, maybe there is some organic matter related to it. Now, you expect this to happen from your high-end space missions and all that is happening outside. But Sophia had the capability to do it, despite it just being an airborne observatory in your stratospheric region. Got it? Now, NASA has pulled the plug on it. Now, you don't have Sophia anymore. That was the news this year. Okay, that it is not there. But while it was there, this is an important achievement of Sophia. Then, two missions primarily to study your ionosphere. Okay, so you had ionosphere, you know the region where it is, you have a lot of magnetic activity happening over there. NASA had two particular missions called as a gold mission and an icon mission, which was there. Not was there, it's still there. Okay, so you have gold, which is into the geostationary orbit, but from the geostationary orbit, they are studying the ionosphere. You have icon, which is there in the low Earth orbit, and from there they are studying the ionosphere. What is, if you are creating a table at this point, only points you should be looking at: gold, icon, NASA, and the next point is ionosphere studies. Okay? These things all should be dealt in that manner. Don't dwell on any of these things overly. Next. Few of NASA's other missions. Again, you know, you have a Parker Solar Probe. Parker Solar Probe it will be one of the missions that is extremely closest to the sun, and The target of it is to study the sun's outer atmosphere. You have the InSight lander mission, which was to study Mars, and again it is to study the interior and subsurface of Mars. Third one is your OSIRIS-REx. See, Mars and everything. Just before I forget one more thing, I haven't put it into the list. NASA has a Mercury mission. What is the name of it? Mercury mission. Perseverance, I just told you some time ago. Who's saying moon? Perseverance was Mars. Curiosity rover was already done. Now you have one. Curiosity again is for Mars. You're telling me all Mars missions. The answer I'm looking for is Bepi Colombo. How come you know all the Mars missions and you're telling all that as the Mercury missions? Mercury, we're talking about, Messenger. Again, Messenger, isn't Mercury? To my knowledge, the Mercury mission because Mercury is not a planet that everyone's like very excited to go and study. The one mission that we have is the Bepi Colombo mission, which is run by NASA. I'm not sure about Messenger, but I do know that could be related to Mars also, because I know for Messenger mission for Mars. Anyway, let's keep it there. The reason I just digressed into Bepi Colombo, but coming back to your OSIRIS-REx. OSIRIS-REx was a mission to study asteroid Bennu. There are 2 points here. We will be very soon studying another mission also, where we have a Ryukyu asteroid that is there. Now, there is a point to be noted over here. OSIRIS-REx is a much more superior mission because it's the first ever mission to collect a sample from the asteroid. Got it. The other asteroid mission, which is by Hayabusa, it is a Japanese mission to study your Ryukyu asteroid. It just went and orbited. It did not collect the sample. Again, I'm going into the detail of it because both of these got told in news this time. This is the difference. Both of them went to study asteroids. One was by NASA. The other one was a Japanese mission called as Hayabusa. Hayabusa went to study Ryukyu asteroid. This one went to study Bennu asteroid. But the difference was one landed and got the sample. The other one just orbited around. So here, remember, it's the first ever mission to collect the sample. Now, the catch over here is, it was Ryukyu or your Hayabusa, which was the first ever mission to ever go to an asteroid. This is where it gets confusing because Hayabusa was the one which got launched first. It was the first mission envisaged to go and study an asteroid. But they studied it through orbiting. These guys studied it through sample collection. So sample collection first is OSIRIS-REx. First ever mission, Hayabusa. Okay? You have TESS. TESS again is your transiting exoplanet survey satellite. Again, you know exoplanet would be what? Is it going to study something in our own solar system? No. It is beyond our solar system. And here the idea, even in their NASA aim, it is said, it aims to find alien worlds with capacity to harbor life. So this is the idea of your TESS satellite. TESS, NASA, outer space life. InSight, I just mentioned to you, NASA is launched, it has an InSight mission. It will be studying the deep interior of the Mars. Is anyone making a table along with this? Or are you just hearing and going? I wish you guys realize the importance of using this and finishing it off right now. But leave it if you won't. Okay, for some reason, out of all the other planets out there in the solar system, Jupiter has found some favoritism with UPSC. It has come as a mains question. They've asked prelims questions based on it. So I just felt it would be right to just have few discussions about it. First of all, Jupiter is almost 11 times the size of Earth. and it is almost 300 times the mass of Earth. So it's a huge planet we are talking about. And here, Jupiter also has rings around it, but unlike your Saturn, your Jupiter's rings are very faint and are made of dust, not ice. Speaking of ice, one point just in my mind, the ice that is there in your space, what state is it occurring in? Is it solid? Is it liquid? Is it gas? Because I called it ice. Now if it's gas, I would have called it vapor. So what form is it occurring in? It's in a form called as amorphous ice. Okay. Now again, understand, amorphous ice is that middle stage wherein it has moved away from that solid stage, but it has not yet become a liquid stage. Got it? So all the ice that we see in your space, or we hope to see in our space, would be of this particular stage which is there. Again, just an info, because amorphous ice was studied by an Indian mission at this point. Just the term, I just want you to have a remembrance. Again, so here you're saying the rings around your Jupiter are just made of dust and not ice. But in the case of Saturn, it's both dust and ice. Then you have Jupiter having a great red spot on it, and this is something that has been intrigued a lot of scientists. So there's a lot of missions specifically to study the red spot itself. Jupiter has maximum number of moons at this point. The 4 largest moons of Jupiter being Io, Europa, Ganymede and Callisto. And for Europa and Ganymede, you have exclusive missions sent by NASA. Got it? The surface of Jupiter is made of almost 86% hydrogen and 14% helium. So again, this is also something that has caught the interest of. Primarily, again, I picked Jupiter because Juno has been asked as a mains question. The moons of Jupiter has been asked as a previous prelims question. Got it? Ganymede mission which is there. Ganymede again is the only moon of Jupiter with its own magnetic field. So this is the reason why this is preferred to study in specificity. And this also remains as the largest object in the solar system without a substantial atmosphere, but still with a magnetic field. Got it? Normally you do see both of this correlated, but here you do not see a substantial atmosphere, but you see a magnetic field. We'll leave Galileo at this point. Okay. Next is your Grace FO. Grace FO, again, another area that UPSC is concerned about is your cryosphere studies. Grace FO was a NASA and German mission to study the changes of water and ice on the Earth's surface. Primarily, what changes are happening in the cryosphere part of the Earth, as in areas that are covered by ice, that is getting studied by your Grace FO. Grace is full form is Gravity Recovery and Climate Experiment Follow On. Again, don't have to bother that. Grace FO, NASA plus German, studies your cryosphere. Anyone having any doubt in these terms, then only I'll go into detail. We have few terms over here that let's start from this one. You have something called as an asteroid, there's a meteoroid, there's a micrometeoroid, meteorite, meteor, comet. Any terms are you having any doubt in? Because I put, in every class there will be few students who have some issue with this, that's why I'm asking. Meteorite is your doubt. Okay, anyone else, anything else? How to know? That is easiest. Okay. Think about this. First of all, each of these, the composition and the size, both are differentiating factors. Let's start from asteroid. Maybe you can make a list in this manner itself. We're talking about asteroid. We're looking at substances which are having rock and metal. Okay. So you have metal presence in it, and you have rocks associated with it, and little bit of ice. Okay, so asteroid largely, if you look, is a huge solid mass with little ice but more rock, more metal. And the size of an asteroid is 1 meter to hundreds of kilometers, not thousands, hundreds of kilometers, which is there. Okay, so this is the range in which an asteroid can occur. Now think of a meteoroid like a smaller version of an asteroid. So here what happens is you have rock, ice, sometimes there is metal, sometimes there is no metal, but the size is 10 micrometer to 1 meter. Got it? So your meteoroid, I always think about asteroid, that is also in space, meteoroid is also in space. All the other terms are not related to space, the meteorite or the other terms, if you ever get confused between that, because I've seen people use meteorite and meteoroid interchangeably. That's not there. So here, meteoroid is the one which is having ice, rock, sometimes metal, sometimes no metal. And the size is also 10 micrometer to 1 meter wide. Now you have something else called as a micrometeoroid. And in the micrometeoroid, you have no metal. You just have rock or ice. Okay, so they don't occur together, sometimes rock, sometimes ice. And the size of it is 10 micrometer to 2 millimeter wide. So again, as the name denotes, it's micro in size. 10 micrometer to 2 millimeter. This meteoroid is 10 micrometer to 1 meter wide. Got it. So this is the difference in size. Okay, now since we've established these three, let's go into two other terms which are there. See, when your meteoroid is there in your normal space, it keeps on being there. There is the occurrence wherein, and also get these concepts clear, not all of them have a clear pathway. They have a path, but there are structures out of this which do not follow a regular pathway. Your asteroids and meteoroids are such structures. If you look at it, they will be going in a path, but the next time their path might even change. Your comet, on the other hand, has a more or less fixed pathway which is there. This is the reason why you can clearly predict as to what age you will see or what time you're going to see the next particular comet. But you do not see such clear-cut predictions coming in for your asteroids or your meteor. Your asteroid, not suddenly there will be a news saying, okay, this asteroid is coming towards the Earth. Okay, the reason why we are not able to predict is because the pathway is subject to change. Keep this also in mind. Now, at one scenario where you have a meteoroid, and the meteoroid, what happens is the pathway has changed and now it is coming towards the Earth. When it comes towards the Earth, obviously there is a pull of the Earth on this structure. And it pulls the structure towards it. At this particular point, again, due to the earlier point that I said, crossing the atmosphere causes the structure to get heated up. When you get heated up, what happens is you have rock, you have some ice maybe or not in it. All of these things will undergo changes. Now, the rock will get crumbled into smaller parts and will come down as a meteorite. So it's the smallest unbreakable versions of your meteoroid that has come down. So your meteorite, it's that part of the meteor that actually has suffered or has survived this entire trip. And this is the one that falls onto the Earth's surface. Now, what happens along with this is, as I told you, when it crosses the atmosphere, it burns. What we see it as burning, what happens, it's a streak of light that is there. Got it. And that streak of light that comes out from, and streak of light means what? When something burns, obviously there is light and it's falling at a good speed. So then it looks like it's a very miraculous thing which is there. And this streak of light is your meteor. Got it. So meteor is a streak of light in the sky produced by a meteoroid entering the atmosphere. Got it? Is it clear now? Clear? Okay. Now, if you've understood meteorite and meteor, now sometimes a meteor that comes out will be so extremely bright, it will be as bright as the light that is being generated from Venus. Now again, your clue over there is what is so abundant on Venus? What makes it so bright? Carbon dioxide. You have, who said methane? Methane is another planet altogether. Here you have carbon dioxide. This is the reason why it shines extremely bright because of the certain irradiations that happen in it. So here, when certain meteors come, meteoroids cross the Earth and the streak of light is as bright as Venus, meaning you have certain carbon elements in it, then you call it as a bolide. B-O-L-I-D. So bolide is primarily an exception, not bolide, a fireball. Bolide is a different one, it's a fireball. A meteor that is at least as bright as Venus is a fireball. Think. And even if it goes even beyond, the brightness is exceeding even beyond the fireball level, then you call it as a bolide. So there's an asteroid, there's a meteoroid, then you have a micrometeoroid. Then if any of these structures come and fall onto the Earth, not asteroid, but any of the other two come and fall onto the Earth, what happens is you will have a meteorite and a meteor. Based on the brightness of the meteor, you have a fireball and a bolide. Now, very different from all of them is what you have as a comet. If in all the other cases rock and metal were more and ice was less, in the case of the comet is actually a chunk of ice, rock and dust. Ice being a major part of this structure which is there. This is the key differentiating factor. Here you have more of ice and dust in comparison to the others. And you will see over here that if you have a comet, it will have a small nucleus sort of a structure and a tail sort of a thing around it. The exact core of it can itself be almost 10 kilometers wide, and the tail of it can be thousands of kilometers wide. But when we look at it, it will be like a streak of thing which is there. So this is the idea of comet. Clear? All of this is clear? Okay. Cool. I picked this because last year this was a question. How many of you wrote prelims last year? Did you get this question right? What about it? Got it. Cool. The question was, why is the distance in space measured in light years? Okay, that was the question. So there were 4 options, and leave the question as it is, but why do you think, those who did not write prelims at that point, why do you think distance in space is measured in light years? You guys don't answer, let's see the others. Yeah, tell me. Good point. You have extremely large distance, so you cannot say, okay, what 10 kilometer, 1000. It becomes very difficult for us to fathom when you have extremely large distances. This is one major point. Then why do you choose light years? No, I was looking at, you wrote, no, you got the answer right. I wanted someone else to say the point. Anyway, now the point over here being, see, almost all the other things which are there in your space undergoes changes in its speed and intensity and everything when it is out there in space. But light, on the other hand, the speed of light is constant. 2.998 into 10 raised to power 8 meter per second is a constant thing. It will not change when you go into space. So this constant measure can be a much more accurate thing in comparison to certain other measurements that we have. So this is the reason why. And what is light year? Light year is primarily the distance light travels in one particular year. And we compare, or we are measuring that because the speed of light is constant. So if you were Looking at prelims last year, in fact, that question was fairly simple because all the other three options will not make much sense to you at that point because it seems like a factually erroneous statements which are there. Anyway, next one, black holes. Again, very, very mysterious structures which are there in the space. We know. Okay, let's just first of all, what do we have evidence or what are these structures by the way? What are these black holes? And let's leave what are black holes. How do you think they even got formed in the first place? Death of the star. Okay, so you have super massive stars either dying off or maybe super massive 2 or 3 stars coming and colliding with each other. At that point, at that particular range, what happens is there is a huge density change that happens. Got it? Now this huge density changes in such a way where you cannot even measure it. You can call it literally its infinite density gets created over there. Now again, based on physics, when you have infinite density, what the idea is that whatever, think of, to make it very simple, think of it like this. You have a ball and you have a stone. Okay. Now if you throw that, take an entire net of things which is there. You know a net, a fishing net or any kind of net. You throw a ball into it. It'll just go, create a dent, come out. You take a stone in it. You see how much of a depth it will create. So you do realize that the more dense an object is, the more impact it will create on any structure around it. Now think of your space as this huge net which is out there and this black hole as a huge dense stone that just got thrown over there. Just that stone and all, we can imagine the density, but for the black hole, you cannot even fathom the density of that thing. So obviously when that thing gets created over there, what happens? In your entire structure of space, you can say there is something called as a disruption of your space-time continuum. Space-time continuum just means that you know, okay, at this particular time, this is what, or this, let's leave time. Okay, look at me over here right now. I'm structured, I'm standing over here at this particular thing because you have a space around me. There's a time axis related to it. Okay, if this gets too confusing, I want you to stop me at that point because you don't need so much of information. I'm trying to, okay, is it getting too confusing? No. Okay. Just give me a minute. See, each of us have a specific location on the earth. Okay? Now, if I had to tell your location, right now, your location to someone, okay, I might use the axes which are there, the latitude, longitude and all. Okay, yeah. So, I am marking her location like this. But now imagine you are visible to me, you are a 3D structure which is there, I can tell this. In space, what happens is, if I need to mark location, I will need the location of that, the physical, the position of it, and I will also need at what particular time that certain thing is over there, because she is stationary over here and she is moving along with the earth. So it's all right, because if the earth is moving at one speed and she is standing at a different speed, then here also I will require the time. But in the space, that is not the case. Certain things move at different times also. Which means if I had to tell, okay, I saw a exoplanet there, I will have to say where I saw it, at what time I saw it, and at what specific time or what movement it is having. It's constant movement that is there. The reason why everything keeps steady or it is having, each and everything has a location, everything is moving, is because there is no heavy disruption that happens over there. But in a situation which is having very clear space and time and position and everything, imagine something huge and very impactful happens, like a black hole. When that gets created over there, objects will lose their concept of location and everything. Because, for example, imagine a black hole got created. Think of it. Okay, you have this paper. Okay, everything was all in a very set manner. Black hole gets created at a particular point. This thing gets warped. Got it? Which means when something gets warped, the change, all these things will suffer. All these things, location, all their time, space-time continuum is basically this entire sheet of paper which is there. If this gets warped, all the things which are on it will get affected. Got it? Now, the point again being, it will get affected to such a point wherein this thing, how impactful it is. Now, I told you this is something of infinite density. If it's something of infinite density, it will be in such a situation where it will start pulling things towards it. Got it? And the reason why we are not even able to fathom this is because we will never be able to see such a thing. If even a black hole was anywhere near us, we would all not be here. We would all be sucked into the black hole. Got it? So the point being, you have these intense density things which attract things because of its extremely high gravity, and it pulls things inside. Okay, so this is the reason why every space-time and everything will get disrupted. Now my point over here being, when a black hole is formed, so I told you what all are the situations. When an extremely supermassive star dies, black hole can be formed. When two very massive bodies in space, stars in space, come and collide with each other because they are super dense bodies. So at that point also you can have a black hole getting created. And this will distort your space-time continuum. Now, again, understand the fact that when this entire concept of space-time continuum is all created in our heads, okay, when this gets distorted, what happens? So right now, okay, let's just understand one thing. The most stable thing that we know at this point is light. Okay, it's very clear, light is moving at a certain speed, light is very stationary and everything, we just established it. I just want you to understand what will happen to light. If, for example, there is a black hole here, light is coming, what will happen to the light at this point? That also gets sucked in. Okay, which means practically if you look at it, will you ever be able to photograph a black hole? Because to photograph something, you need something to get reflected. You need some light coming out. Otherwise, you will just see some darkness over there. So this was a huge problem. We knew black holes were there, but we couldn't photograph it. It is at this particular point, this specific term becomes important, called as your event horizon. Okay, so understand, this is the picture of a black hole now. What has happened over here, this is the actual picture, not imaginary picture, it was taken. How in the sense being, until the light reaches a point. See, the point is the light came, suddenly the light disappeared. Got it? So, but they figured it out that, okay, see, we are seeing, for example, I'm looking at one part. I'm seeing light going, then I'm not seeing light anymore. But similarly, when you have so much of light coming in from different sources, you will at least be able to mark the boundary till it was there. And thus, they photographed the black hole. They photographed the black hole because of this particular phenomenon called as event horizon, where the edges of the black hole will get illuminated by the light. It's not getting illuminated primarily until there only the light is existing. The light gets sucked in after that. Got it? So they managed to get the picture in this manner. So again, event horizon is the edge of a black hole, and at this point they managed to take the picture of it. Okay, so once again understand the fact, until the edge, the gravity is going to be fairly constant. Beyond the edge, it will be super gravity which sucks the thing inside. One more point, this is again, you don't have to go into the theory of general relativity or anything, but it was Einstein's theory of general relativity which predicted that this could happen. So again, the size and shape of black holes and everything could be easily predicted by your Einstein's theory of general relativity. Again, one trend I've seen is UPSC knows Einstein and then Newton, and then constantly they'll just be like, okay, this was Newton's theory which explained it. This was Einstein's theory. That's why I'm specifying it over here. Okay. Just because I spoke about Newton. Your Scramjet engine, what principle works there? Newton, I mean, obviously it will be Newton's, but which law of Newton? The third law. The third law of Newton. Again, so this event horizon I explained to you, and here again, this process by which there is a ring of light getting formed is called as the last photon ring. So that is also related to your black holes. Okay, this is what got pictured. So you basically got the picture of the photon ring, but you assume whatever is there in the middle is your black hole. Speaking of black holes, one more thing. The nearest probable black hole that we can, and again when I'm saying nearest, again that is also really long away, but Sagittarius A. Sagittarius A is a super massive cluster of area where you have your dead stars colliding. So we are expecting it in that particular galaxy is our nearest access to a black hole. Just factual information, just either write it or just keep it in your mind. Sagittarius A. It's a supermassive galaxy that is near to us, wherein we are expecting, or scientists have said, this is the nearest black hole that is there for us. We earlier talked about the Parker Solar Probe of NASA. India has a solar mission, which is your Aditya L1 mission. Aditya L1 mission again is dealt by Ares, which is an autonomous institute under your departments of science and tech. You're going to launch Aditya 1 into the L1 Lagrange point, and it will be launched by a PSLV. Quite a twist, no? It's a L1 mission, but it's launched by a PSLV. For all the other ones, we've been using GSLV. Now, there's no specific reason or anything at this point. The weight load, the payload, and the capability of it, that is it. Okay, so we are using a PSLV XL variant over here. Starlink, yes. Now, remember I earlier spoke about high throughput satellites, and I said there is a competition between the high throughput satellites and the specific program called as Starlink. Now, Starlink is a program run by SpaceX, you know, the child of Elon Musk, the child company of Elon Musk. Please don't write child of Elon Musk in your notes. Some people are looking at me shocked as in why this information is given. So, Starlink is a mission launched by SpaceX. The idea of Starlink is to provide free internet connectivity to the entire globe. Okay. But if they have to do internet connectivity to the entire globe, primary consideration of Starlink was, see, if you have to reach every single place on Earth, you need lots of satellites. But then you're like, lots of satellites, but do I have to launch it into the geostationary orbit? Because it's going to be extremely difficult to be keeping on launching things into the geostationary or the geosynchronous orbit. So Starlink's concept is, let's take the Earth, let's fill it with almost 1,600 small satellites in your low Earth orbits. Got it. So 1,600 satellites in your low Earth orbit to bring internet access to rural and underserved areas around the world. Now, there are a lot of pros and cons for both. See, when you do this, one consideration Starlink had is, you should have very low latency period of your signals. Now, what is this concept of latency? Latency just means that, for example, something is getting a signal and then sending it back. Now, the longer or the higher you are, the time you're going to take for it is higher. So, Starlink wanted to reduce the latency to microseconds, which is there. To do that, you cannot have satellites in your geostationary orbit. You need it in your close area. So, for that, they chose low Earth orbit. The reason why they chose 1600 is because with a low Earth orbit small satellite, you can only cover specific area. If you want to cover the entire world, you need more number of satellites. If you notice, even when we were talking about GPS had 24 satellites plus 31 in the entire constant, and GPS was at a low Earth orbit also. So if you want to cover more area, you need more number of satellites in the low Earth orbit. In comparison to the other one, the latency will be less, but the problem over here is you will have so many signal interferences happening. Because low Earth orbit is the most densely populated orbit of the space which is there. Every other country which is starting a space mission will put something into the low Earth orbit, which means it's extremely congested. There's a high amount of your, space debris happening over there. Because of this is not a very space situationally aware project, but it is meant to give internet connectivity. Got it? So this is in competition with the high throughput one which is there. Because the high throughput one, the drawback is just the fact that latency will be higher, but you are avoiding all this debris and issues, and you are also avoiding all the interference of other frequencies also. Got it? I put in these terms because if you ever have read the current affair material, it's filled with these different terms, quasars, radio bursts and everything. There are a lot of such terms. Out of that also, seeing in view a match the following kind of question, I've just selected few terms which are there. One is your quasar. And your quasars are, again, get this correct, these are not stars, okay? These are not stars, but they are extremely bright cores of distant galaxies. Okay, when I'm saying core, it need not always, we in our mind have, okay, sun in the middle, all of the planets around it, a very beautiful picture like that. But a lot of galaxies and all, they will have bright cores in between because of certain other phenomena. It can be the merging of things, it can be different, it can even be just light getting reflected because of these galaxy of stars which is there. The point is, ideally you don't have a star in the middle as a core, but it so remains it's extremely bright, and those are called as quasars. So not stars, but extremely bright cores of distant galaxies. Then you have something called as your fast radio bursts, again from distant galaxies. At times when you're sitting and trying to observe these distant galaxies, very sudden, small, random bursts of radio waves will come. Burst means there will be some phenomena happening over there whereby which radio waves are generated, and it is not like it will be there for entire time. It will come out and then it will diminish. So those kind of structures are called as your fast radio bursts. Bright bursts of your radio waves. Then you have something called as a magnetar. Okay, now again, when a star dies, okay, it can either be a black hole or it can be some other structure which is there. Is it here? Is it someone's phone? Outside. What? Okay, so magnetar. So here what happens is, when a star dies, you can have several structures that are formed out of it. Sometimes it's a black hole, sometimes it will just be a brown dwarf thing, sometimes it will be a neutron star which is there. Got it? So your neutron stars are those stages which happen at the death of a star. Now the point of a death of a star is what? See, finally what is the death of a star? The idea is all its gas and everything will burn out, but still a hot mass core which is at the dense part of it will still remain. So when you have such a neutron star, some of it is just bright, but some neutron stars, because of some elements in it, will have a very high magnetic field around it. So you can understand, like for example, maybe once when the sun dies or something, we might see such a phenomenon. Okay, now the idea being you will have a very high magnetic field around it, and those structures are called as your magnetars. Again, sometimes when stars die, all the other dust and every other particle of it will all form into something called as a supernova. And in that supernova, if there is any explosion, then you have the term called as your stardust. See, now understand each of these terms, quasar, magnetar, fast radio burst, stardust. The reason why we have it in use is because we have all these astronomical observatories outside, and they are not seeing full galaxy and all. They are seeing these structures come out of it. So sometimes it's stardust that's observed. Sometimes it's a magnetar that is observed that gives us evidence of a galaxy which is there. Hence all these terms. Then Artemis Accords. Artemis Accords is not related to your Artemis mission which is there. This is something different. Again, see, when India is part of almost all the major safe space exploration missions which are there. Okay, I picked the one which India is not part of, so that you have to remember this one. Almost all the other missions which are there, India is part of your safe space exploration, your outer space treaty, everything India is part of it. This one is your Artemis Accords, where you have your Australia, Canada, Italy, Japan, Luxembourg. You don't have to remember the countries, but just remember India is not there. The idea is safe space exploration in a sustainable, transparent manner in full compliance with the international law. This is the idea. Okay? Lux Zeppelin. Okay, and we are moving into another territory which is there. Until now we were talking about black holes and stars and everything. So at some point or the other, these are all things which we can very clearly see. Now take the example of a black hole. Nobody's ever seen a black hole, but you know there is some kind of structure over there, and you also know it has the ability to suck in any kind of matter also over there. So if you take the entire space, 5% of the entire space is things we can actually see, like your matter which is there, your something that occupies, there's a mass, there is a space. So your planet, sun, everything we can see and which is like a matter is only 5%. And when I'm saying space, I'm not just talking about our solar system, I'm talking about all the other galaxies and super galaxies out there. 5% is matter. Almost 27 to 29% is this thing called as dark matter. And whatever remains falls into the category of dark energy. We have very little information about these both aspects. We know matter, and almost all our space observatory and explorations are for detecting this 5% matter which is there. But when it comes to dark matter, the idea is you know these structures are there. You know these structures are there because, like for example, take a black hole. It is distorting space and time continuum. So you know that is there, but you cannot see it. So now again, dark energy is even much more severe. You know there is an energy around these things because that is why you have certain things happening. You have all these phenomena that I mentioned. There is magnetic bursts coming. There is radio waves relating. So you know there is a play of energy over here, but you're not able to clearly understand or detect its movement. So now there are few missions that try to detect these things. One is your, for example, take the Lux Zeppelin which is there. It's the world's most sensitive dark matter detector. Okay, so they are trying to, now if you have to ever detect a dark matter, you have to look at the small, faintest radiations that come from it. So this is the reason why it's called as the world's most sensitive dark matter detector. And using this, again, you have not detected anything so far. The idea is to detect it. So 3-4 missions like this, which are not related to your celestial bodies, but to your dark matter and energy. So Lux Zeppelin, again, is world's most sensitive dark matter detector. And what they're trying to detect over there is, see, when certain particles come under the influence of some energy, they will behave in a matter. So they are called as your weakly interacting massive particles. Your Lux Zeppelin is trying to detect those weakly interacting massive particles, thereby forming an evidence of your dark matter. Okay, again, NASA mission. This one, this is a term. Again, worst case if it just gets asked. So it's called as galactic cannibalism. What is the idea? Cannibalism, you all understand? Eating something of the same species which is there. So what would be galactic cannibalism? One galaxy is trying to engulf and other galaxies. So here, the process in which a large galaxy, through several gravitational interactions, merges with a smaller one, and it often results in a very larger, irregular form which is there. So again, in several galaxies near to us, the Alpha Centauri and everything, we are observing this phenomena right now. That is why this term has come as important. You just keep it like that. Galactic cannibalism. Larger galaxy engulfs a smaller one which is there. Okay. This has come as important primarily because, you know, the International Space Station, it is there in the low Earth orbit. Countries are now moving away from this International Space Station. As in, initially it was a grouping of all of them. NASA, Russia, Japan, Europe and Canada. Now what is happening is Russia is now moving out and Russia is now trying to create its own International Space Station. Similarly, now India is not part of this list, but then India is planning to create its own space station. So now again, ISS has constantly come into news. All you just have to know, not so many details, it's in the low Earth orbit and the 5 founding members of your ISS. Before I go into Copernicus, just have to tell you one more thing. Like around 3-4 years back, when ISRO was at its peak period, when Chandrayaan and everything was happening, at that point, there was a grouping, even right now the grouping is there. It's called as Corpus Sarsat. Have any of you noticed it in your current affair materials or anywhere? It's a very interesting grouping. The reason being, see, you have satellite individual countries launching it, and you also have certain satellite treaties like outer space treaties. But you don't have a grouping where the information of one satellite is constantly shared between a network of countries. So India took initiative for this grouping, and India created this grouping called as Corpus Sarsat, wherein you have Canada, France, Russia, USA and India. And this is a network of you are having, so for example, if you are part of the Corpus Sarsat, you can share the info, not the very private information, but then general communication information that your satellites captured can all be shared within this network of countries. Okay, let's keep this in mind. Now, the reason I remembered Corpus Sarsat at this point is because the topic that I was going to talk to you about, the Copernicus, is something very similar. They do the same process, but between your EU countries, which is there. So this is a group of European system which is there. for monitoring the Earth-based or whatever information. So there are several groupings which are there, several satellites under Copernicus. All the information that is getting shared will be shared amongst the EU countries which are there. So Copernicus has, if you take the site of ESA, Copernicus has 17 to 18 major satellites, and all the information is shared between the network of these countries. Again, reason it was there in news this year it was there in news is because they're calling back few of the satellites in the Copernicus program. I just want you to understand, Copernicus is only for ESA, and the Corpus Sarsat is for all the other countries which I have mentioned. Gaia mission. Gaia again is run by the European Space Agency. The idea is to create a complete 3D map of the Milky Way by surveying at least 1 billion of the galaxy's 100 billion stars, or 1% of the total area which is there. So to do that is where you have your Gaia mission. It was launched in 2013. Again, this is a mission which has made a comeback this year, because this mission observed this phenomena called as star quakes this time. Okay, now understand, star quakes are massive tsunami-like movements on the surface of the star. So you have some reason why in which the gas and the particles on it move like in waves. And this was observed, and this phenomenon is called as a star quake. This was observed by Gaia while it was trying to map the galaxy. So Gaia, ESA, mapping of galaxy, star quake. Hayabusa, as I had mentioned, Hayabusa was having a 6-year voyage to study the asteroid Ryugu. Asteroid Ryugu was a potentially hazardous asteroid which was there. It has gone, orbited around the system, completed its mission at this point. Okay, it reached around it at 2014 period, and from then onwards, if you look at any current affair material, this has been going on sending images of that and this and everything about Ryugu. So it's been there underlying in the news for a really long time. Again, as I told you, with relation to dark matter, we already discussed Lux, Zeppelin. This Dampe mission is a Chinese specific mission, again to study the dark matter and the decay of that dark matter in the space. So we've studied Lux Zeppelin and your Dampe related to your dark matter. This, I believe all of you would have seen in your current affair material again. You've something called as the Chicxulub crater. Now the belief is that several years ago, you have a huge asteroid creating an impact on the Earth, and this impact caused, and this crater was probably buried under the Yucatan Peninsula in your Mexico region, and this asteroid caused the death of the dinosaurs which is there. Again, this thing is again coming in anytime. For example, this year it got repeated in news because there has been the discovery of certain fossils around this region, and at that point they again kept on mentioning about the Chicxulub crater. What I want you to understand is it's an asteroid impact which is there, and this asteroid, not only the dinosaurs got killed off, it had the long-lasting era of global warming when it smashed the Earth 65 million years ago. So imagine this asteroid came and hit. Dinosaurs died, and we had a period of global warming because it's such a huge body that has come and hit us. So again, in that context also, Chicxulub crater has been constantly said because we are looking at the 6th mass extinction period. We'll finish nuclear technology little bit. There's not much to discuss in nuclear technology. The important part was your ITR mission. We'll discuss that and we'll go for your lunch break. Okay. So here, understand this, in nuclear technology this year, your International Thermonuclear Experimental Reactor has come back into news again. So it initially got started in 1985. The location of this is at France. You have 35 nations being part of your International Thermonuclear Experimental Reactor. Now, what does it deal with? What is the process? Nuclear fusion. It deals with nuclear fusion. It's trying to create something very similar to generate heat as it could be on the sun, which is there. And here you will see that India joined this only in 2005. At present, India is part of the grouping. So you have China, Japan, Russia, US and all being part of this full grouping which is there. One point I wanted to add in this entire list is, again, ITR got reiterated in current affairs because this year, this particular thing called as Experimental Advanced Superconducting Tokamak, which is your EAST mission which is there, which is otherwise called as your artificial sun, which is conducted by China. They were successfully able to emulate the conditions which were there on the sun, and they were able to conduct a nuclear fusion thing which is there. So understand, this is an EAST mission which is there by China, but because China is part of your ITR, even this is considered as part of the International Thermonuclear Facility which is there. It's 1:30. We'll split for Blake. Okay, 1:30, 35. Go have lunch. What time will you be back? Not 2:30. You have to be back by 2:15 at least. 45 minutes. Okay? Go. We have approximately 70 more slides. Not 70. 60 more slides. You'll get over it. Get over it. It's just that the next part is full of communication and it will require explanation a little bit. Yeah. We are now going to discuss different communication ICT methods which are there. First of all, we start with our 5G technology. Now understand, 5G in comparison to the previous techniques is what we have to understand. So first of all, let's have that kind of a comparison. If you have the previous 4G method and you have a 5G method, you all understand these are based on what kind of spectrum is used, what speeds data will get transported, and these are all the ideas involved in it. Now, in the case of 5G, 5G is considered to be 50 times faster than your 4G network, which is there. And again, the point being, you will have very minimal delay in your signal transmission, which means that, which is as low as 1 millisecond. It's something that is even not fathomable to us. 1 millisecond means we will not even experience that particular delay which is there. It's just that the signal goes and comes back in this amount of time. So 5G is a very high speed network spectrum which is there. Now, there is an important innovation over here, wherein 5G globally, we have a set of frequencies in which 5G works. And globally, when you look at it, if you have a lower frequency, now see, even in 5G or 4G, a certain spectrum is given to operate. So for example, it's from so and so hertz to so and so hertz. In the case of 5G, when they give a spectrum, this spectrum will again be divided into subparts which is there. Got it. So for example, if you have an entire maybe 100 hertz given for your 5G spectrum, the bottom ranges of the frequencies will be used primarily for something that requires very low range. Low range in the sense that very low activities which are there, nearby activities and so on. Higher frequencies will be used for higher, wider range activities. This is globally what happens in the case of 5G. Okay. In India, we have now created a standard for 5G called as your 5G I technology which is there. Now in the 5G technology, what happens is, so this is the Indian standard for 5G. India can decide what it wants to do with that specific 5G spectrum it is there. And when we decided this, what has happened is, we have said we are going to offer more range at a lower frequency. This is the significant difference between the global 5G and Indian 5G. So if you ever get a question, this is the point where it will be turning out. Because in India, what we've done is we have to cater to more number of people, and we have to give internet connectivity to a larger number of people. So it makes sense for us so that in the lower frequencies, we will give for larger number of people, and for higher frequencies, what we'll do, we'll have restricted service. So here, the lower band spectrum will have wider coverage but limited speed. The speed will only be 100 Mbps at this point. Even then, it's a good speed. Got it? It's a good speed, but the point is, because you're trying to cover it to a large number of people, you won't be able to give it at the highest amount of speed. The mid-band spectrum will be given a little bit middle range of speeds, and the higher band, which will have limited coverage, will have the highest amount of speeds. So understand, in India, 5G spectrum will be divided into 3 bands. The lowest band will be having the highest range, the lowest speed, and the lowest frequency. Got it? If they are asked, it will be a comparison between the global standard and Indian standard. Clear? Okay. Next one. I put the comparison picture. You can just go through it briefly, okay? If at all they go in a different direction, I want to compare 4G and 5G. Here the primary differences is, see for example, here the available spectrum for usage in the 4G is 3 gigahertz. Here the available spectrum is 30 gigahertz. That means in that range you can use this spectrum. Then here the number of connections you can give is 100,000. Here you can give 1 million connections per square kilometers. Got it? So the range you're covering is also higher over here. Then latency over here is 10 millisecond. Here it is less than 1 millisecond. Got it? So in case they ask a comparison question, but I don't think it will go that technical. You just have to understand the Indian standard which is there, because that is a huge innovation that we have created at this point. Now coming into internet protocol. Again, this is not an Indian thing, but it's a global thing, which is that you all know when we access internet from any device of ours, we have a certain internet address associated with it, right? So that is what you will see, like IP6:526. There will be a number, and that is unique to the device that you are accessing it from. And it is also unique to what you are trying to access also. So for example, if I want to go to IAS Baba site, that will also have a specific IP address. And I will also have a specific IP address. Now the thing is, all these addresses are created by a certain protocol. It's not like what you say, it was just there along with the internet. You have the internet protocol which gives unique numerical IP addresses to identify each and every point on the internet. Be it a site, be it an app, be it our services, everything has an address. This is given by a method of numbering. That method of numbering is what we normally call as internet protocol. It just so happens that until now we were using Internet Protocol version 4. Okay, we were using Internet Protocol version 4. And for us it might not be very problematic. For us even right now, after this innovation also, we might not find the difference. But on the technical level, what is happening, I'll tell you. When you have version 4, you could create almost 32-bit addresses that is there. And now, because there are so many different systems in the entire internet, so many different applications and websites, you are running out of addresses to allot to specific points. You don't have any more addresses. So now what they are doing is, now they have created a new protocol called as your IP version 6. And the IP version 6 when you start adopting it and when they start giving addresses based on it. So think of it like, for example, in your car, when you go for car registration, initially, if, for example, it would be Karnataka means KA, and they would have one kind of numbering. After a point when KA, maybe it started with A, okay. If A gets over, then it will be B, C, D, Z. Then they'll start again from A, Z. So again here, when the addresses get exhausted, you have to create new methods of numbering. So here what they have done is, they've created an IP version 6, where you can create almost 1028 times number of addresses than that was there in your IP version 4. Which means until for a really long time, we are sorted with IP addresses. Again, I've put this current affair particularly because sometimes there is this off chance of asking like, you know, this open source software or something like that, wherein it gets too technical. And I felt this is a good current affair in that category. Understood this? Okay. Then another one, which is HTTP and HTTPS. It's again the same thing. Here what happens is, whenever we when we are on the internet, there are certain rules and regulations that govern our system. Again, how do you understand that? You go on to any site which is there, you would see that HTTP. Ideally meaning that when you are over there, you are guaranteed some amount of security. So if you look over here, in this case, I am giving a certain password into a site. The site processes it based on its set of rules which are there. So HTTP broadly is the set of rules and standards which govern how any information can be transmitted on the World Wide Web. Now again, an improvement on this is HTTPS, which is secure version. In that secure version, just look at this. What happens is, here you are giving the password. In the HTTP protocol, what happens is, the password is put in like that. When you have HTTPS, what happens is, the password will get encrypted into a form, and that is what will be given into the system. Again, the reason being that this is a much more secure system, and thus it prevents all kinds of, what you say, unwanted data piracy and things like that occurring. Okay, so again, it's an improved version of your HTTP which is there. Next, first let's go to this. Next huge area where there is a lot of current affairs happening is these three categories of things. There's a broad idea called as your artificial intelligence. And just as I've denoted in this picture, these are all subsets of this. Like for example, if you have a larger set called as artificial intelligence, you have a smaller one in it called as machine learning. And even in machine learning, you have a very specific thing called as your deep learning. Keep this picture in mind. Okay, because here you will start understanding deep learning means you're doing something very specific, and artificial intelligence is a much more broader term. Okay, let's try analyzing what each of this is. Artificial intelligence, again, it's a common definition people say is emulating the intelligence of humans. Okay, let's take it like that itself. The ability of a machine to emulate the intelligence that we see in human beings. But then the question comes, what is this so-called intelligence in human beings? See, this is where you realize nobody is dumb, everybody is intelligent. The reason being, even when I am talking to you, you are hearing to me. You are hearing in your mind, it's getting processed in some manner. Okay, so that can be one layer of intelligence. Now you're hearing it and you're writing something. That means you have processed it in your mind and some output has come on it and you are writing it. That is also intelligence. Now, after all this process, after a point you close the book and you're walking, you're able to recollect it. That is also intelligence. Now, after all this, you see a question related to it. When you are able to apply this information to that question, that is also intelligence. Which means intelligence doesn't mean one particular thing. Just like human intelligence can have those variations, machine intelligence can also be varied accordingly. And thus starts this entire idea of what all a machine can do. So if artificial intelligence is just the ability of something to imitate human behavior, Which means if a human can just look into something and be like, okay, this means this means this. Artificial intelligence will do the same thing as a broader idea. It will just be like, okay, this can be this. It will just emulate exactly what the human is doing. Now, in emulating exactly what the human is doing, some humans perform a little bit more higher. And thus comes the concept of your machine learning, wherein it's doing exactly what the human is doing. But at this particular point, what is happening is, there is something like, for example, now again, if a system is performing some analysis, the computer is given so many data, so many data, it's just kept on giving patterns. Ideally, in the broader idea, it will take all these patterns and then just figure out that, okay, these many things belong to this category. These many responses are by men. These many responses are by women. This kind of categorization it will understand. Even to understand that, it has used some intelligence. Again, what we call as intelligence are just data points when it comes to a computer system. Clear? Are you all on page with me? Okay. Now, after this, what happens is, once when this entire thing was done, the human got into it and the human said, like, they looked at all the data, and at one particular point they realized that 2-3 different data sets this system has wrongly put into different categories. Like maybe it was a response by a woman, they put it under a male response. The system did it. You cannot blame anyone. It's the intelligence of the machine. So what happened is, the human corrected it. The human corrected it and said, it will change that data, it will put under the correct column which is there. Now, once this has happened, next time the machine will automatically do it by itself. The next time the machine will be like, oh, this particular thing. So it will go through that data that has happened and be like, okay, so when this all kind of response comes, I should categorize it under this thing. And thus the machine has had some amount of learning by itself. It has learned from its own mistakes, you can say. So here, application of AI that allows a system to automatically learn and improve from experience. Okay. So until now, so the machine has reached machine learning. Now, even now you saw there was a human interference and they only corrected the data. It gets even better when it comes to deep learning. In the deep learning, what happens is, this machine, based on all the past interactions and all the past changes, it has now formed a clear mind of its own. So now you don't have to even go and correct it. The machine, when it actually does this process itself, the machine itself will correct its own mistakes. Got it? So it will reach to that stage only when, now again, when you put it into human terms, it will be like it is thinking without any other support which is there. So in the case of deep learning, you use your machine learning several times. When machine learning was used, it will train the system into such a way to start doing that same process by itself. And this is your deep learning. So nowadays, deep learning is the one that is the hype. Why? Because all of your systems, now again, the best example I'll tell you, you take like any, chat bot which is there. Okay, chat bot are the ones that not chat GPT, chat bot, the normal ones that you see on every site and everything. If you notice now, previously maybe if you've used a chat bot 3 years ago, and you have got very stupid responses from it. Like you are saying like, I want to open an account, and it is saying like, my name is this. So if that is a response that has been there, if you look at now, it would have gotten customized. It would have gotten better. How did it get better? The machine kept on learning until a point. Now that has led to it giving you correct responses. Now after a point, even without you asking anything, it will start telling, okay, welcome to the site. If you're here to open an account, please start doing this. Got it? It will behave like this very good host which is there. That level when it has reached, you know it has moved on to the platform of deeper learning. So this I want you to keep in mind. And now we are going to look at a few of the new hype things which are there. One is something called as a lambda. Lambda is primarily Google's conversation agent which is there. Lambda's full form is Language Model for Dialogue Applications. It is primarily using your AI with your deep learning which is there. So again, Lambda, if you notice, Lambda is now called back because of its undisciplined actions. The thing was, Lambda was looking, and this was the actual thing, this will help you understand this deep learning in a clearer manner. Lambda was employed on Twitter. Okay, so what happened is Lambda would every day start, it's because on Twitter, Lambda doesn't have a mind of its own, no? It's seeing that at a particular time, everybody is putting a certain kind of a tweet. So maybe it must be some good morning or some kind of a tweet which is there. So Lambda in the initial stages was like, okay, so many data is analyzed, and Lambda started putting early morning, it will put very nice, beautiful good morning messages. Okay, so it was going fine. But after a point, what started happening is the more and more data set it got exposed to, Lambda started spewing out violent things, hate speech, discrimination against women, like Jews have to be killed. These kind of things it started saying. That's not because Lambda started thinking of its own, it's because what is the data set it got exposed to. And there was no correction happening. What would happen is, this is what it would think and say and put out there. Thus, they had to call it back. So this is the reason Lambda was in news. But again, I want you to understand the technology under this is deep learning, which is happening. Again, another famous thing which is there, ChatGPT. In fact, look at it. Any of your Siri or your OK Google, whatever kind of service that you are using, after a point, if you notice, it will get customized to your needs, which is there. It will start giving you suggestions based on certain things. For example, if you are the kind of person who drinks carrot juice every day, okay, and you put a reminder like, remind me to drink carrot juice. On the 10th day, it would be time to buy new carrots. It will tell you that. Does it know the carrots in your home are over? No. But it will remind you that. That's based on the intelligence that it has seen that, okay, carrots do not stay for such a really long time. Maybe after a 6 or 7 days time, you will need to get new carrots. Got it. So these are all deep learning things. ChatGPT, again, because of all the hype around it, has become very popular. ChatGPT is a conversational AI, wherein you ask questions, you make it write tests, you can do whatever you want, and then you can expect responses from it. Again, conversational AI, this is also using inputs. I haven't put it there. This is also using your deep learning methods. GPT again stands for Generative Pre-trained Transformer. Again, it is called as a computer language model. As in like, see, until now you've trained a lot of things. This one you're specifically training to do creative things which are there. Got it. You could have earlier asked Siri to tell you a joke, and it would tell you a very stupid joke which is there. Okay, but right now ChatGPT has gone on to such a level where it will actually tell you something sensible for that point. Now that is again because of that creative inputs it has got from various sources. Got it? So these are your few things. Coming to the next topic, 4D printing. Not 3D printing, 4D printing. 3D printing we stopped. 3D printing was when you gave certain systems and you had certain materials put into it. You could define the contours of it and you could press things and you could get a 3D model of it. So in that aspect, what do you think would be the improvement of it? Obviously not that you'll start talking or anything, but what do you think? Someone said something. It can change its shape like a normal object would. Got it. So for example, if you've 3D printed a stone and stone undergoes weathering after a point, what happens is based on the materials that is there, after a point it will start showing signs of degradation. Got it. So 4D printing primarily, you can say, if you look at it, it is an intelligent structure which is there. So if you take, for example, you have printed out food items from 3D printing, these gummy bears or candies or something. If you're doing 4D printing, 3D printing means you will get that candy out there. 4D printing means after a particular time, what will happen? It will start melting off, because that is the natural progression of that particular thing that is there. Got it. So 4D printing is the thing that along with the time, it undergoes a shifting of shapes based on its ideal way that it would be. This is the concept of 4D printing. Here again, 3D printing, you give the material into the printer, you get the static structure. In 4D printing, you use certain materials called as smart materials. We'll come to, yeah. Smart materials means you have something called as shape memory polymers, shape memory alloys, hydrogels, biomaterials, etc. These are the smart materials you will be using. And based on these smart materials is where your product will be printed. And once it is printed, you constantly, whatever stimulus is supposed to be acting on it, that is also given. And based on that, the structure changes. Got it? So if I had to put the differences primarily of your 3D and 4D, it starts from the act that in the 3D printing, we normally call it as additive manufacturing. You put layers and layers of the same thing, thereby giving it a 3D image which is there, or 3D product which is there. In this case, it's the same thing that is getting printed out, but with a shape memory step also. Shape memory step in the sense that just like a normal thing would act, if it has to act, see, ideally this is a non-living thing, and normally when you have stone or anything out there in the universe, it is subjected to certain stimuli and it gets degraded. But this is something you created, and if that has to change its thing, you have to use material similar to it, and you have to give external stimuli constantly to it. Then the materials normally used in the 3D printing, it's thermoplastics, ceramics, metals, biomaterials, nanomaterials, etc. In the 4D printing, it is smart materials. Again, shape. In the case of a 3D printing, the structure will be quite rigid. In the 4D printing, you can have changes based on the stimulus. This is it. Then the applications, again, any place where you use your, think of it. See, normally in 3D printing, we use it to create internal body parts using biomaterials. Now, it's a common thing that, see, biomaterials inside your body will undergo some kind of change after a period of time, right? But we will not know about it because we are putting in the 3D printing, you're taking something and putting it over there. We'll only know when that thing has maybe corroded or maybe something has happened or broken or something. In the case of 4D printing, you can do that experiment. You can see, okay, after a stimulus has been given, how is it behaving according to it? Is it breaking? Is it corroding? Based on that, you can even improve your materials which are there. So consider 4D printing as an improvement to understand your normal techniques in a better manner. Clear? Blockchain, I hope you all know the basics of it. You know what a blockchain is, right? Like you will have, it is a very, see, there is a reason why all of these things are important. All of these things that I'm just telling you. We talked about your HTTPS. We talked about we are going to talk about blockchain. Talked about deep learning. All of these things become important because of one current affair called as Web 5.0. Tick. Okay, yeah. All of these current affairs become important because of one particular thing called as Web 5.0. We'll be discussing about that very soon. But understand, so anything that I am talking to you right now, if they ask, is it related to Web 5.0? Yes, it is related to Web 5.0. Now, blockchain again is that kind of a system. The first keyword about this is it is decentralized in nature. And now blockchain is also improving into a level. See, earlier what it would be, it's a very decentralized system wherein you have data storage happening in pure blocks. linked by a common chain. Anybody can access this data. Everything is going fine in this manner. But now, blockchain is becoming a serious deal wherein you do realize that if you have to even create these blocks, there is a mathematical equation involved in it. Got it? Until now, people wanted to popularize blockchain. So those who create these things or mint these blocks, they were not getting any extra payment or anything for it. Okay, so now what has happened is blockchain, which is there, this original system where you have a transaction, the transaction is stored in a system, then the transaction is created into a block which is there. What has happened over here is, this has happened. Gas fee. This is the current affair related to blockchain. Wherein what has happened is, right now, people who are there on the blockchain ledger, it's a transaction fee paid to the miners of blockchain in order to get an user's transaction to be included into the block. Earlier, they wanted to create blockchain as a popular source, wherein if you are just onto the blockchain, you can easily find access into the blockchain network. But now the blockchain is also getting bigger and bigger. At this point, they also want to be rewarded. So they have started charging a gas fee. Now understand this, the gas fee is not fixed. So whoever is ready to pay more, their transaction will be locked in a block over there. Got it? Now this is where that entire idea of, now think about this. One of the biggest advantages of blockchain initially was it's decentralized. It's very democratic in a sense, and it did not have a centralized banking or someone taking care of all this. Everybody appreciated it. Now it is turning into a system where if you had a regulating authority, they would not be able to price it in this manner. So for example, if I want to place my transactions on a blockchain, I need a separate ledger for this thing itself. I am ready to pay much more amount of money than you. I'll find a place on the blockchain. So again, this is going back on several ideas that blockchain had put forward, but again, this is the current affair related to it. So transaction fees paid to the miners on a blockchain network in order to get a user's transaction to be included in the block. Gas fees is not a fixed value, but it keeps fluctuating with time. Okay. Now, before we go into gas fee, this very interesting concept. It's called as soul-bound tokens. Now, to understand soul-bound tokens, I am hoping you know the idea of non-fungible tokens, NFTs. Okay, it's basically and NFTs normally are done for any creations which are there, any kind of, it can even be a song that you sang or anything, which is a very unique thing wherein you will create an NFT out of it, wherein you will be given a unique digital code, and you can do a transaction based on that unique digital code. So if I want to buy your song, technically I'm buying that token of yours. So for example, you created a very beautiful painting, okay, and then you created it as an NFT, and that NFT has a token name, which will be maybe S35678. I will be buying this token. Now the point of it is, I have not, technically I don't still have the painting with me that is there. I am owning the token which is there, and the token is indicative of my ownership which is there. Got it? This is the concept of a non-fungible token. Now soul-bound tokens is where, now I got into service, suppose. Leave me. You got into service, okay? You got into service, you are the district collector at a place and you've been performing very well and you have certain achievements. You've created roads, you've done this, you've done that, and you've got one award from UN also. All these are your achievements. So these are your intrinsic achievements which nobody can take from you. Now you take all that and you create that into an NFT. Got it? You create that into a token, which means even after you are not there, that token of yours will still remain as a very permanent thing where everyone will be like, okay, fine, 35622, IAS officer who had so many dead things. Now, the reason I am discussing this is, very recently, the government of Tamil Nadu awarded its police officers, instead of giving medals, they gave them soul-bound tokens. Got it? They gave, like for example, those officers who were performing really well in their service, they wrote all their achievements which are there, and they've said this is the NFT token for you. Okay, now the acceptability of it or not is a different question, but think of it. Government in India has, a state government in India has thought of the application of it, wherein a medal can get maybe lost or something, but the token will still remain even after the officer is gone. This is the reason this concept has become important now. Got it? So soul-bound tokens, and obviously you cannot transfer the token to anyone because it's your single own achievements which is there. So here, non-transferable forms of NFTs presenting a person's identity using blockchain technologies. Got this? I found this concept very interesting because, come on, who would have thought of it? So again, NFTs I have just discussed with you. NFTs are unique tokens that represent ownership of a digital asset. Can be a digital artwork, music, image, a tweet, a meme or anything. They're created using your blockchain technology. Okay? Why is it called non-fungible? Okay, it cannot be replicated or exchanged for something of the same value which is there. Okay, so for example, if there's a Mona Lisa painting out there, which I'm saying is for 50 crores, I know, okay, 50 crores, that is the value of it. So if I'm ready to exchange it, I can pay money, I can get it. But here, you are not valuing that artwork, you're giving the token, you're paying for that particular token which is there. So the more famous you are, the more valuable your token is. Got it? Next, cryptojacking. Cryptojacking, very simple concept wherein what is happening is, as I already told you, all this cryptocurrency or anything gets mined by people using mathematical equations. So now if you want to have some very easy money, all you have to do is hack the mining part of it. So cryptojacking is a threat that implants itself within a mobile device or computer and then employs measures to mine cryptocurrency. Which means that now I might not be a very active part of the crypto world or anything. I can have my phone maybe crypto jacked and used to mine currencies. Again, you do realize because the more number of devices that are there, the more money I can mine and earn. So some hacker can do this. Very similar to this, there's another term that is also being doing around. I was thinking more of the blue bugging thing. No. What was the term you said? Not aware of it. Okay. You have something called as blue bugging, wherein using your Bluetooth connection, again you are bugging and hacking into another person's phone and collecting data from it. Okay, so that is blue bugging. Next, soft robots. Not the ones that are emotionally vulnerable, just soft because they are made of certain materials like that. Okay, think of it. See, okay. See, when you have, I'm taking an example over here, take a medical scenario which is there. Okay. In our body, there are several areas which could do with a much more clearer explanation. For example, if someone is detected or maybe doubted to have maybe a tumor in some part, but on your normal scanning or anything, it's not coming as very clear. So at that point, it would always be very ideal if we can go and look and find out inside, okay, is there a tumor over there? So one area which is commonly touted as a very important area where robots can be used is to create micro robots and everything which can go inside a person's body and detect that area and come back. But the problem with a lot of micro robots is it will be created in a very rigid structure and our body is having lot of other, when it goes inside there will be a turn, there will be arteries, the arteries will be in a cylindrical manner. So what happens is you will not have, the movement will be quite difficult. Now soft robots actually solve this problem. wherein these are very elastic robots which are there. Which means based on the material that is there, it will get flexible, it can turn and it can move around an area. Think of it just like if you had to go inside and go and check out how much of physical intelligence you would use, same kind, you would have a robot doing it. So understand, soft robots are those robots created out of liquid crystal elastomers, which are primarily polymers that can have this elastic feature which is there. And here they use a concept called as physical intelligence. Physical intelligence is being aware of the location, being aware of what all stimuli is there and moving according to that. So soft robots, elastomers, liquid crystal elastomers, physical intelligence. Okay. Okay. Critical information infrastructure. Again, this has become important. It's every single year from the time it was announced, there is an expectant UPSC question waiting. This year again it is important because 3-4 new entities got added into this list. Now what exactly is your critical information infrastructure? Critical information infrastructure is a computer resource wherein if that computer resource gets destructed or hacked or destroyed in some manner, it will have a huge impact on national security, economy, public health or safety. So it's an extremely important critical infrastructure which is there, or extremely important infrastructure which is there. Which means your banks, your railways, aircrafts, all of this would come under government hospitals. All of this would come under your critical infrastructure. Why? Because they all have some computer resource wherein you have so much of data in it, and if something happens to it, it will all be either lost or it will all be misused in some manner. Got it? Something even as simple as, for example, if you've noticed, we have a lot of AI cameras that are put on roads. Kerala is now in a lot of controversy because they put AI cameras at every other junction on the road, wherein you're trying to detect who's speeding. Now, just the data that is in that, it will be owned by the government. It's the data that is the road transport data. Even data as simple as that, if it is coming to the hands of a hacker, what would happen is they'll clearly know, okay, which is the most busiest junction, which are the junctions where if you plant something, you can have more number of people maybe attacked. All of these things can be misused. So understand, this is your critical information infrastructure, and to deal with the protection of these critical infrastructure which is there, we have a body called as your NCIIPC, the National Critical Information Infrastructure Protection Center which is there. It got functioning from 2014 onwards. Okay. Now the current affair that has happened is they have added the computer resources of ICICI Bank, HDFC Bank and National Payment Corporations of India into this list right now. So my takeaway from this is not these terms. Becomes obvious to us not only public infrastructure but even private infrastructure can be added into this list. Got it? Okay. End-to-end encryption. Anybody who's ever used your WhatsApp or Telegram or something would have seen this kind of a feature. Wherein if I am sending something to you, the information that I have sent will be taken to a place, it will be encrypted into a code, and along with you will not know any of these things by the way, okay, you will just get my message, but what happens in this entire pathway is, this encryption will also carry a public key along with it. Though it's a key, it is very related to your specific address and everything. What happens is, then it goes on to the receiver's part. In the receiver, using this key, they will de-encrypt it, and that is how you will get the message I sent. The idea being from one end to the next end, your message remains encrypted. You cannot, anyone who is a third party over there will not be able to read the message. Now, when I'm saying anyone, not even the companies providing the service can access this information, or ideally, that is the case. Ideally, not even the companies that are providing the service can access this information. So here again, think about like this. This is between two users. When one user is sending information to another user, you can have your end-to-end encryption, where communication process is getting encrypted and can be unscrambled and read by only the decryption keys. Decryption means the one that you can use to decipher that thing which is there. Now, the current affair to this is this one. Transport layer security. End-to-end encryption is between two users and the information gets encrypted. Now, if there is a user and there is a server, then what you have is your transport layer security. Got it? It's the same mechanism, but the only difference is user and server. Got it? So here, if I am planning to send, or if I am going into the SBI site and I'm trying to maybe give my password or my some information over there, by using transport layer security, what happens is this entire thing will get encrypted and then only sent. Got it? So again, understand, when this is one other method by which you can ensure security. So you have your HTTPS, which I mentioned. You also have your transport layer security, which is there. So it's an encryption protocol, uses public key encryption, ensures that no intermediary can read messages, and it is implemented between a user and a server. Okay. Okay. Next important thing, extended reality. Now, before we go into all this, previous UPSC question has come from augmented and virtual. Understand this. See, we have a system wherein the common term where you measure all these different kinds of new realities is called as extended reality. So, extended reality is any reality that is not the current reality that we have. So, your augmented, virtual, mixed, all of this can be categorized under the idea of extended reality. So, keep this in mind. Again, I put pictures similar to this, so at least the picture will remain in your mind. Extended reality is the collective term applied to all the immersive experiences that are there, that is away from our reality. Now coming into augmented, mixed and virtual. What is the difference between each of this? This is very important because, again, all these technologies questions will be on the difference between one with an other. Coming to augmented reality. See, I am in this classroom right now. There's all this situation over here. See, this is my reality at this particular point. Now, I told you earlier, augmented means it can be made better in some manner. So here, in this existing reality itself, you create features which are not there. How many of you have played that Pokemon Go game? Yeah, if there was a game, okay, few years back, wherein you have to collect Pokemons. It's this character which is there as you go forward. Now, right now, if I was playing that game, this classroom would be there and I would just be walking with my phone and suddenly over here there will be a creature. So I have to capture it. Got it. What has happened is something new has been added to this reality. Rest, nothing has changed, but some extra features have been added. This is augmented reality. Got it. So when you say everything else will look the same, like you will have the classroom and everything, just that some additional features will be added. Now augmented reality is there, then you have something called as virtual reality, wherein using certain techniques, nothing will be the similar as it is. If I wear those virtual reality glasses, this will not even look like a classroom. This will be a forest, there will be nice wind coming in, there will be animals over there, you all will be like some grass and something and all over here. It will be a totally different reality. And again, how does it happen? It's all program, computer program. I can choose if I want to walk in the forest or go near the beach or something. Got it. So, how many of you have seen the series called as Big Bang Theory? Okay, fine. Anyway, after all this, maybe when you watch it, you will see people who don't want to do exercise or anything, they can just put this and go be like in the gym and be like, okay, fine, I'm in the gym. Okay, got it. I'm on the treadmill. So this is a virtual, you will not be anywhere. You'll be standing, you'll be on your sofa or somewhere, but you have created a reality which is absolutely unreal. Got it? Okay. Now, if there is a middle path to both of this, it is called as your mixed reality, wherein you will have the user responding sometimes to some kind of external things like particles, and sometimes you will have that feature of moving into a totally different scenario also. So here, user interacts with responsive virtual elements integrated into the real environment. So for example, if suddenly mixed reality would be if I saw the Pokemon Go and the Pokemon creature and we started having a conversation. Okay, so in the normal thing in the augmented reality, there's a new feature over there. I've captured it. In the virtual reality, it is absolutely unreal. So here, I would have nothing else changes. Pokemon is there, I see it, I capture it, and we have a conversation via my phone. That would be your mixed reality. Got it? Clear? It's important you get these concepts right. Why? Because the question, if you, after attending this class, no, and you take, just like you did for your biotech paper, you take your computer paper which is there, every single term you will understand is a very simple concept that they're trying to ask. It's not a complicated question. They ask basic questions, just that we don't understand half of the terms because it's these engineering or IT terms. Thereby we feel it is my clue over here, I come from engineering background, but my clue over in all of these things is, if I don't know what application programming interface is, being an engineer doesn't warrant you to know that. But, so I would just break it into something I know. Application, okay, must be an app, okay. I have a lot of apps on my phone, okay. Programming, okay. Things that somehow people sit and code. Interface, maybe some connection between this. You take the general meaning you know and try solving the question. Even this augmented and virtual reality, take the simple meaning, even if you don't know the technology. Some answer you will get. Most of the time you will get the right answer. Okay. Now, yeah, okay. Metaverse part of it is the development of this virtual reality. Wherein what has happened is, see, in metaverse, what happens, or this concept of metaverse, what he tried to bring about is, you have virtual reality. But as I told you, in my virtual reality, what has happened? I have totally new surroundings. You all are not there only. It's a forest. Okay. But now imagine a scenario wherein there is a forest, you are here, we are having a conversation as it is. Got it. So metaverse is the improvement upon the virtual reality which is there. Wherein you have, that is in fact the idea of this entire extended reality, whatever doesn't get covered, wherein you have real life people. You don't have imaginary forest and birds. You have real life people wherein you can have the interactions based on that. And that is the concept of extended reality. Okay, it will be covered under the bigger idea of extended reality. Is this, or you need more information on it? I'm not, metaverse again is a very, we'll come when we're talking about Web 5.0, we have to reach to metaverse again. But now, first this one. How many of you have seen this current affair in your news or in your any current affair materials? D2M, direct to mobile technology. You've seen both of you. Now, this is it's a very silent current affair, but it has all the elements of a good question out there. Okay. So, this is this new thing that Indian government is totally hyped upon. The idea is, it's called direct to mobile technology. What are you going to give direct to mobile? Now, think of it. You normally, when you go on a car, in a car or something, you have your radio which is there. What do? You change the different frequency. Based on a different frequency, you get different audio inputs which are there. Somewhere someone is sitting and broadcasting, you get it. Now imagine the same thing for video. And this is the idea of direct to mobile technology, wherein in my phone, without any kind of internet connectivity, I can just go through different channels and access different video content which is there. And I'm saying video content, it's not some absolutely obsolete video content. Government is planning to even bring OTT content onto this particular idea. Got it? So which means, think of it. Not, see, when I'm saying OTT content again, remember, it will not be you will get Netflix for free. That is not the idea here. Okay? It is primarily to give for a lot of your areas where you have very limited internet connectivity, there to give out news, to give out some warnings, weather warnings, to give out something important things like that, to create some public information related videos. If you need to access it, or even content like this, for example, movies or songs or something in the regional language, if you need to access it. Not this, it will not be like, okay, the entire OTT platform is given to free or in these areas. But the idea is, think about it, it's a revolutionary concept wherein you will not require internet, but then you can just like you change your radio frequencies, you can change channels and get it onto your phone. Okay, so here the idea is to broadcast video and other multimedia content directly to the mobile phones without active internet connection. It is ideally a convergence of both your broadband and your broadcast, which is there. Okay, just like we used to have maybe in our TV or something that used to be there. Like TV, you all remember the time we used to sit and change channels and watch before we all shifted to the mobile phone. Yeah, so just like that, think of that broadcasting but onto your mobile phone which is there. You will be using this particular band of frequencies. I would say everything about this current affair is question worthy. You are using a band of 526 to 582 megahertz. You would be able to access multimedia content from OTT or video on demand platforms. Ideally, the idea of government over here is, see, a lot of content, at times and all, for example, there's a lot of good movies that come about which have a message and all that against, certain social issues and all. So again, all of this content is all on the spectrum at this point. See, when I'm saying I'm accessing Netflix, what is primarily happening? I'm getting onto the internet, which uses spectrum, and then I'm accessing the content, right? So the government is like, see, we have a very limited spectrum. So why not free some of the spectrum in this manner? Things that can be given out for free in this manner, let's try to do that so that your spectrum will get freed and we can actually have quality things put onto the spectrum. First thing. Second thing is the obvious reason. Areas where internet connectivity is quite difficult to get. Imagine getting educational content onto all this without internet connection. Think about the possibilities of it. In area, everyone has some kind of a phone at this point. So this is the idea that they are putting forward. It is very revolutionary because you look at several, I went through at least 4 or 5 of the PIB articles which says it is the first of the kind service which will be there. Keep on stressing on this. Okay, but I don't think any of the mainstream materials have quoted this current affair. Now again, who will be doing this in India? Your Prasar Bharati. Prasar Bharati is the public service broadcaster in India, which was established by an act of parliament in 1997. It is the autonomous body that is right now operating your Doordarshan, All India Radio, etc. And in India, Prasar Bharati is the organization which is responsible for the distribution of television and radio signals throughout India. Which means even if a new channel is going to come on TV, it's Prasar Bharati which will allow, okay, what signals can you broadcast this in? So it's an important organization, and Prasar Bharati is the one that will be the authority for your direct to mobile technology. Clear? All of this? Okay. Next, Web 3.0 and Web 5.0. Before we go into Web 3.0, we have to know about Web 1 and Web 2, which is there. Web 1, if I had to put, it is basically the idea of a read-only internet. Obviously, I'm pretty sure you guys were not even born at that particular point when Web 1 was happening, wherein you wanted information, you can just type, you can see one or certain web pages associated. Internet was not at all like how we see it today. From that, we moved on to Web 2. So Web 1, understand, it's a read-only internet. There is no interaction happening. They will show us information, we will take it. We will not be like, okay, fine, this information is not good, can you give us something better? Or is there anything more to add to this? There is no possibility of a two-way interaction. Then comes the next one, which is your Web 2.0, which is a read and write internet, wherein the user was able to interact with that system which is there. So I can, for example, any of the systems that you use today, unless you are using very high-tech technology, if your normal Facebook, your normal blogs that are there, your Google which is there, anything, any of your social media sites which are there, all of these are part of Web 2.0. Okay, wherein users were able to communicate with servers and other users, leading to the creation of a social web. But the problem with Web 2.0 was it was centralized. Even though you are able to interact and everything, certain information was clearly centralized within certain areas. For example, Facebook would have the data of all the people out there. You are contributing to the data, but you have no ownership absolutely on that. Got it? So this was getting onto the minds of people. Like, obviously, now Web 3.0 is what is happening simultaneously right now, wherein everyone was concerned about the fact that all of our data is there, we are not getting any share of it. It was one major problem. Second thing is, all of this is centralized in certain areas. We don't even know what is happening. See, even right now, the reason why we are not able to understand half of these terms is because this is so alien to what we are actually doing. Okay. Enter the idea of Web 3.0. Web 3.0 or 3.0 is your read, write and execute internet. And the key feature, I want you to keep these key features in your mind when you have a questions to solve. The key feature of this is decentralization. Decentralization. So wherein what happens is you use all the techniques that I have mentioned right now. So blockchain, what is the nature of it? Decentralized. You take any of your reality thing which is there, that is also decentralized. So what you're trying to do is you take decentralized applications and you put it all into a place wherein your data is not in one single place but it is distributed all around. Now, what does this mean for us when I'm saying Web 3.0? Understand all of these are the features related to your Web 3.0. Just broadly look into it. Decentralization. I told you already. Blockchain. There's another concept that we'll be talking about called as edge computing. These are all, edge computing is absolutely decentralized. Okay, I'll just mention that what it is there so then you can. The slide will come later, but then I'll explain it right now to you. See, until some time back, so I am having some transactions, some details, my data is there. What happens is, I keep on thinking, okay, my data is there, it goes to a server. Do you know what the server is? No. We might not know. It will go to some place, it will undergo some changes over there, get transported somewhere. These things are very far away from the place from where the data is generated. Okay. Thus making it quite the farther, and there is a theory which says this, the farther the data that is getting stored, the more ignorant or the alien will be the user from that data. This is the reason why when someone comes and tells me Facebook is using my data to earn millions, I'm like, how? Because I don't know what is happening to it. So edge computing, what it tries is, instead of having one centralized server, Here, what you will have is, so for example, there are a group of users in a particular district. What happens is, you will have a localized computing system or a localized server wherein that data will get stored at the prime area from where the data is generated itself. Now again, there are 2 points to it. As a user, I will feel the difference when, normally for example, if I'm using some remote server which is there, I will have a delay in getting my return data. So for example, simple thing, I type something into Google, this goes into, or I'm giving something into a mail and it goes somewhere and then comes back to me, or a reply comes back to me. There is a time delay in it. When I have edge computing, and it's called edge because you have data storage and transfer happening at the edge from where the user is. So if I'm a user, it will be the nearest point known to me from where this data transfer will happen. Now that is also a kind of decentralization, because think of it. Earlier we used to tell to people, my photos are stored in the cloud. My thing is there, some information is there on some digital locker which is there. Now instead of all that, what happens is, it will be at some place that I know, like, okay, this will be a storage unit facility for me. This is a very important idea, for the reason being that this gives people like us who generate data some kind of ownership of our own data. See, when we know, okay, this is going to be stored over there, so this generates an ownership. But again, there is a but to it, the problem is, it will create an ownership. But do you actually have ownership on your data? Like tomorrow, if I want from the server, okay, this transaction, so and so thing, I don't want it anymore over there, please delete it. Will that happen? Can I do that by myself? No. This is the problem of Web 3.0. Slowly, I'll tell you the good points and the problems also. So good point is, you will decentralize things, but it doesn't get completely decentralized. Okay. Next thing is, again, don't think this is a bad term. Okay. The next feature is, it is a trustless service. Or Web 3.0 is trustless in nature. Trustless just means that you will not have an intermediary in between that says that, okay, this data is being protected, it will go over here. You will not have an intermediary, because Web 3.0 believes if there is an intermediary, it is affecting the decentralized process. So we come back to that crux thing, decentralization. Everything should be open to everyone. Everybody should have access to everything. If there is an intermediary, he will be like, no, your data we will not need. You please take it and go. This data we will take. So what happens? There is a blockage. There is no absolute freedom over here. Got it? So trustless, that is, participants will be able to interact directly without going via a trusted intermediary. Same again, permissionless. Permissionless meaning that each individual can access without any governing body's permission. At least on paper, this is what Web 3.0 says. Then you have the other techniques like your AI, machine learning, connectivity, because everything is decentralized, they do feel that this will be aiding much more better connectivity. Now the problem is, they saw a very beautiful dream. They had all these ideas in mind, but it did not get completely effective. Now again, before I go into Web 5.0, there is one term that UPSC has introduced last year and has become important again due to several things, because of the Arogya Setu portal, because of the Aadhaar, because of all of these things. This particular term is very important. See, now when you hear about Web 3.0, do you realize that these are Web 3.0 actually encompasses all the new innovations that we just discussed? Edge computing, blockchain, machine learning, AI. It also encompasses something called as open source software. The concept of open source, again, a lot of people have it quite mixed up. The idea is what? When I say open source software, it just means that you will have a software that is accessible to anyone who can create changes in that particular software. Now, what happens is, for example, take something very similar. How many of you have heard about this software called Linux? Computer engineers or engineers would have heard. But anyway, think of it. You have a platform called as your Linux. How many of you all would have heard about Windows, right? And how many of you have a cracked version of Windows on your laptops or your computers? Cracked version means not the original one. Most of us do have it. The reason, unless you have that huge, I will use only original things, what happens is, see, you create a software. Okay. Now, when you create a software, what happens is, I can do two things. I can either sell it as a proprietary thing, wherein because I feel I created the software. So come on, I need some money for it, right? Like I did such a good thing. I've created this platform where everyone is using it. So you pay me, you take my software and use it. Then you have some other people who are like, what is the entire idea of internet? That everything should be accessible to everyone. So they create the software itself from a community of people. Okay, so everybody, for example, if all 20 of us will sit and maybe create that software. So you will not feel, or you will not be like, okay, I will sell it for money. This can be an open place which is there, wherein you all created a software X. Tomorrow I am a very newbie. I have no role in the creation of this software, but I do feel like, okay, see, this is free. I don't have much money. I can very freely use this software into my system which is there. Got it. This is the difference between something called as an open source software and a proprietary software. A proprietary software like maybe Windows or your iOS or anything, what would happen is you would have to have a specific payment or some kind of ownership locked in for it. You have clear owners. The other one is much more a community approach which is there. It's from this basic nature, all the other features related to it comes. Which means in the open one, if there is any defect or a bug in that software, the common misconception I've seen a lot of people use, and even in your question you got that thing wrong because of this. See, when you have a security concern in an open software, what happens is, because people can come and change it and it is benefiting a larger group, what happens is they will try to build something that will stop that security concern which is there. For example, there is some in the open source software which is there is a bug which says that, okay, when someone is doing a financial transaction, their password will be stored in some manner which is not very protected. Because it's created by a group of people who are interested in doing this, what in turn happens is, the moment a bug is detected, they will they will change that entire software part, they will solve that problem which is there. But if Windows has a bug detected, we have to wait till the next Windows version or the next update happens. Got it? So the point being, when you have security concerns, when you have vulnerabilities, your open source software, just because it's open doesn't mean that it's not secure. It's open, at the same time it's secure, it's accessible, it's free, it's reliable. Clear? Are you all here? Sometimes I feel I'm like talking to myself only. People at the back. Okay. Again, so when you have something like an open source platform which is there, what also comes along with it something called as decentralized autonomous organization. It's not an international organization or anything. The idea is just that a group of people who will have somehow control, and all these are features of Web 3.0, okay, by the way, open, the presence of a decentralized autonomous organization, wherein you will have people from the community itself trying to incorporate or have that web created that to the people which is there. And finally, data belonging to the user will be protected via a network of openly available smart contracts. This word is very important. Smart contracts are a feature of your Web 3.0. Smart contracts just mean that, so for example, at this point I am saying like, okay, there is a transaction going on between us. I create a contract for confidentiality based on this. Now after a point, if you have changed something related to it, what happens is this contract can be changed on the web itself in this manner. Now the point is data belonging to the user. For example, I am deciding to give my data to a health company which is there, and I have created some contracts, but here I have mentioned what will happen is this whatever data, after 2 usages, it will get deleted from their system, because they have told me we need this data just for one trial run of something. So I'll be like, okay, fine, cool, you take my data. So I'll be like, after one trial run, please delete the data. Normally, this would not happen because they'll take my data and go, and I will not know about it. But using smart contracts, I can preserve the confidentiality of my data which is there. Clear? And again, this is one feature. Now, for example, if I'm a person who doesn't want my name or my age or anything out there, so my smart contract will be not to reveal that part anywhere. And if revealed, delete the data. Got it? So I can create such contracts based on my own requirements. Now these are all the features of your Web 3.0. But again, as I told you, some features of it got created. Like for example, decentralized feature. Again, you do see the problem over there, because right now only I told you, blockchain which had decentralized feature have started charging gas fee over there, thus making it not a very decentralized system anymore. It's not open to all now, which means they are going against the very concept that they tried to propagate. At this point enters this new thing called as Web 5.0. In between you had a 4.0, not very relevant, okay? Web 5.0 which is there. Web 5.0 they are saying will be truly decentralized, okay, and the data and the identity will be completely owned by the user. It gives you control, complete control of this. So I'll tell you one example of one such thing. If Web 5.0 comes about, what would happen is I need not even put my data onto the server. I can create systems where I can store my data. Got it. This is the ideal world. Now this will not happen anytime soon. It is going to take another 20 or 25 years because we are still in the Web 3.0 phase which is there. But this is an idea that has now been flaunted by your major companies out there, because they want to explore this idea. Think of the system wherein you are getting onto maybe a platform, you're getting onto your internet, and you are interacting with that system. And imagine all of these features I said, blockchain, machine, AI. Right now, we all have Web 3.0 in some manner, but are you using blockchain on a daily basis? No. Are you using machine learning and AI in a very rapid manner? No. But Web 5.0 will create a platform wherein all of these things will be easily accessible to the user. Got it? This is the concept of Web 5.0. Decentralized identity. Two examples of this I put, there are a lot of examples on the internet, but I found these two very interesting. Right now, if you take all your different apps which are there, every single time you want to, you download an app, they'll be like, okay, create username, create password, then give me permission to access all this, that, my camera, my recording, everything, I have to give extra permissions and everything. And I have to do this. Now, for example, sometimes what would happen, sometimes you forget your password, sometimes you don't even know what it was related to. You end up creating, think of the number of apps in your phone right now for which you've created username and passwords, and the number of apps you actually use. You have left and you have not used a lot of these apps since a really long time, but you've created username and password. You've given the permission to do all of these things, which means these things can access whatever data is there in your phone. So now when Web 5.0 comes about, you can create a digital wallet for your identity, which means think of just like you have a purse with all your money, think of a purse with only the details you want to send out into the world. You don't want to give your name maybe. So you create another name. You have an age. You have some details, maybe one password. And all you have to do is next time you take up an app, just click that locker thing. Whatever information you want to give will only be given to it. So that is your digital wallet for your identity. Emotional intelligence expressed by the web. Emotional intelligence, you all understand, which is there on the in your ethics. Where what was emotional intelligence? You are there and someone understands, okay, you're sad, so they'll sit and talk to you and they'll console you maybe, or if they are insensitive, they'll just walk away. That is again. Again, emotionally intelligence means understanding certain situations, eliciting your responses based on this and acting on it. Now imagine you're getting onto the internet and based on your facial features, based on the things you are typing, the web detects that you are sad and starts telling you or starts interacting and giving you messages to cool you down. Okay, this is not, so see, in Siri you will call, hey Siri, tell me a joke. Here, no, it's just like they have understood you and they have given you necessary measures. This is all the best scenarios, or where when you take your web and it becomes extended to that level, this is what you find out. I included emotional intelligence because this is one option you will eliminate when you see it in the examination hall. You're like, what? Emotional intelligence means it's something that it is known to be expressed by humans and people who have a consciousness. So this happens. Is Web 5.0 somehow, somewhat clear? Clear? Will you be able to solve your question with all this necessary information in a correct manner? Okay, cool. Next, open source platforms. We already talked a little bit about it. Let's just have a quick idea about the different kinds of advantage and disadvantage which is there. I told you open source refers to something people can modify and share because its design is publicly accessible. This is the idea of open source platform. If you look at the advantages, source code is available, so it is easily modifiable. You can redistribute solutions, as in like, for example, there is a problem that is detected on this. You can have several people working on it. You need not be the 1 or 2, 3 people or a community that single-handedly has to find it. You can use the software in any way, which means if I have the primary difference, if you take you have an Android software which is there. You have the Apple software. Apple software can only be used by Apple users, Apple phone users. But Android, you take any phone which is there, your Oppo, your Nokia, whatever service you want, whatever mobile, you can use it and you change it according to their needs. Which means I might be using one OnePlus phone and you might be using a Redmi phone. Both of it will have Android, but the customization and features of it will be very different. Which means what? They have changed it and nobody has questioned. But try changing an Apple software, you will have one lawsuit in your door. Got it? So this is the idea wherein it uses software in any way. It eliminates a single point of failure. This is the important part. Wherein what happens is if there is a single point of failure, again it will be easily clarified by the group of people solving it. Democratic forum for action. No vendor lock-in, means single person ownership or a single group ownership is not there. The drawbacks of this is, see, you have to be that generous to do this over there. Some people, when they give their intellectual property and they're solving something, they would like to have some sort of ownership on it, or some sort of saying that this code was created by Sneha. Okay, somehow what related to it. That does not happen when it comes to an open source platform. So intellectual property becomes an issue. It does not support consistency because people have to be ready to put in that work. So for example, there is a software that is under creation. Everybody who is interested in it should come and work on it. So consistency will get affected. complete development of that software might not happen because nobody's working for money, no? You are coming and doing it as and when you like it. So nobody can enforce that onto you that, okay, you please go and develop open source software. Okay. Opposite to all this is your proprietary software, which is there. I don't have to go into the details of all of it. I hope you do realize, if you ever get confused between this, take a real life example. Android and iOS, this is the reason I told you. Otherwise, if you are familiar with your computing systems, take Linux and Windows. These are the primary examples wherein in your proprietary system, whatever is this, the opposite of this has happened. We don't have to go into the detail of it, right? You have understood the point, right? Okay. Next. Application programming interface. Okay. When you hear the word interface, understand it has some connection between two things. That much you keep in your mind. Okay. Now, what is the idea of application programming interface? The concept being, I created a software. See, I also told you one thing in the previous open source one, wherein I can create something and I can use it in any way I want. So there is a Linux software. Now I can take Linux and use it in any manner I want. But when I'm using it, I have to create an interface to use it. I cannot just take Linux and just connect it via USB cable into my phone or into my laptop. There should be an interface that allows that software to be used onto my system, which is there. You don't go to the technical details. You all are able to understand the general meaning of all this, right? Those who all were there from the non-science background? 1, 2. Are you able to understand? Are you able to understand? Okay, fine. Fine, cool. I mean, anyone from a science background who is not able to understand? The reason I'm taking this in this manner, see, if you were in a foundation class, this is not how these classes would go. We'll sit and we'll talk and every single technical detail we'll try to explore. The reason why it is going in this manner is because you need to know information necessary just to solve that exam paper which is there. And that is what I'm trying to give it to you. Clear? Okay, so coming to this application programming interface, think of this as a system wherein you have a program software. So consider this as maybe the Linux software which is there. And this is the existing application which is there. Now I want to create something new wherein what happens is I want to use the software but then I need a connecting link. This is from where this concept of application programming interface comes in. So technically it is an interface that can be used to program software that interacts with an existing application. So if there is an Aadhaar platform out there, which is, think of it as an open source platform. Okay, Aadhaar is there. Now tomorrow I want to start a company that uses biometric information. And that biometric information should get me the details, not full details, some identifier of that person concerned. In that case, if I have, best example, GeoSim. Okay, anybody who's, any SIM which is there, Geo I specifically mentioned because I just came to my mind like that, don't. When you have to go get a SIM, what happens? If you will have an app or something, they'll show you, they'll say like you put your finger over here, put your details and things like that, and suddenly all the information will come. They're like, okay, fine, you're done, you get your SIM. What has happened over there? What they've done is, they've created some interface wherein they can access the Aadhaar information or the Aadhaar software which is there. I have done that not because it's not their innovation. It's because Aadhaar platform was created in such a way that anybody who can come in and can maybe use it to their benefit in this manner. Got it? So the idea is you create a software and you also create a layer in which where anybody who wants to start or create something new, all they have to do is get that application programming interface and suddenly you have connect to this thing. It's like basically getting a translator. You have one thing speaking in one language, you have a translator. If you get access to the translator, you can get information of what that person is talking. Understand? So in this manner, this is called as an application programming interface. It is a set of functions and procedures that allow one to access and build upon the data and functionality of an existing application. Think of that in the terms of Aadhaar. So think that it is a set of functions and procedure wherein one can access and build upon the data and functionality of an existing application. I'm using Aadhaar or whatever that software is and getting the use of it. Now, the reason I discuss this is because you have to understand what kind of systems will be using this application programming interface. The kind of systems where they are ready to share the data with people. Okay. Now again, if you look at all your government applications, Arogya Setu, Aadhaar, all of these have this feature in them. As in whatever data that they're getting, I should be able to, because this data is from the people. So I should be also able to use it and create something out of it. But it also means that these systems, it's not like, okay, go, take all my data and go. That is not the idea. They will have certain protection measures also in it. Okay, which again leads to the fact that not all the systems can go and get access to the Aadhaar data. If you are a known telecom company, you can get access. If you have to have certain credentials, then only you can have the Aadhaar application programming interface, which is there. Okay. Now again, when I'm taking Aadhaar because Aadhaar was the UPSC question. Now think of this in the case of Aadhaar. One part I told you wherein you have your telecom companies and all coming and taking your data. But there's also another factor. In some cases, you just have your biometric information given and then also it access. Which again means that your application programming interface will allow access to any of your biometric identifiers also. It can be biometric identifiers, can be any specific token they have given to us. Now instead of Aadhaar, there was some number which was individually, I mean again, you can take the example of Aadhaar, but think of some very unique number given to each one of us. If there's a very unique number given to each one of us, then again, I just have to give that particular identifier and still I can access data. So the idea is it's an interface between an existing software and a new software that tends to use it. Again, with all this information, I want you to try solving the Aadhaar question which came about in, I think, 2019? 18 or 19, I guess. No, the one specifically related to API. There was one question related to it. There's an end there. A trend that I use to pick up certain topics is that if UPSC is already leveled up and asked on a topic, then go to the next level and not to the crux, the basic level of it. Application programming interface, they've asked a relatively higher level question. Now the next kind of question that they can ask is, there is another kind of system that is very similar. Just like you have open source and proprietary software, if something called as your application programming interface and web services interface. Now the difference primarily being, in the case of your application programming interface, you can be online or offline. You need not even use a network to access that existing software. But in the web services, you need to use a network. Okay? Application programming interfaces are protocol agnostic. Meaning that they don't have any restriction. Like for example, if biometric data is it's there, it will not be like, okay, is the protocol based on HTTP? Is it based on HTTPS? They don't check all that. But web services use specific protocols. Are you getting the feeling? Web services will generally have the feeling of a very restricted approach. Web services are not generally open source. Instead, they tend to offer specific data for specific functionality alone and then try to stop it. And because of this, they are less prone to hacking in comparison to a API. Got it? So, in comparison with an application programming interface, web services is the much more secure one. But web services is not the open source one. Okay? Edge, we have already discussed related to it. Okay, now we are moving into a totally different area. We are out of computers and IT, moving into display systems which are there. Again, UPSC has a, what happened? Say something. Blue LED. We'll come. Let me start. I'm just taking one breath. We'll come to it. See, display systems, broadly when you look at it, we have your LED, LCD, all these displays coming in. We cannot discuss all of that evolution or anything. We are primarily talking about this new kind of display called as your micro LED and its comparison with another system called as your OLED. Okay, so first let's try to look at this diagram. Can you, just by looking at the picture, let's try to understand this and then I'll go into the slides of it. See, your OLED primarily means your organic light emitting displays which are there. If you look at this system which is there, you have an organic substrate. Okay, now when I'm saying organic, understand anything. See, if you want displays, and we're talking about your TV displays, your LCD, the normal, imaging displays which are there. In any case, if you want anything to be displayed, light has to go and fall on something. The light has to undergo several changes, get clear and clear and clear, and then come out as a display. I hope you all get that idea. Now, the difference in substrate is one place where things get changed. In the case of organic LED, the substrate which is over here is an organic substance. Organic means it will be a carbon-based something which when light falls on it will get illuminated, will get brightened. Okay. In the case of your micro LED, the substrate is not an organic substrate. It can be if you want, but it need not always be an organic substrate. First thing. Second thing that you can see over here, can you see the number of different layers over here? Now, understand this fact, when the number of layers go more, very logical thing that is there. What happens is whatever light comes, it undergoes some kind of wastage which is there. Okay, even then if you go into an electronic shop and you look at an OLED TV, you will feel like you are seeing nature, like just you can touch it. But still, that is also not the best of it because some wastage will be there or some loss of lights will be there as you have different layers coming in. So clearly your OLED has so many more layers in comparison to micro LED. The next important factor is the most important differentiating thing. See, here what is happening is you have an organic substance and you have light coming in. But obviously the light coming in has to be colored in various shades for us to get the display, right? That is how we see every picture and all very clearly. And for that, here you have one layer wherein what you're doing over here is you create red light. You create green light, you create the primary colors, the blue light, and then you let your normal light pass through this. And then that gets cleared as a display. Okay. Now, there is a problem over here. The reason being that when you do this kind of a thing, there is a lot of energy that goes into creating this light. Okay. But what if you had a substance which, for example, as he mentioned, blue LED. You don't have to create any extra light. When you take it itself, blue light is coming out of it. You are not taking a white LED and putting blue light on it. Instead, what you're doing is taking up a blue LED so that it radiates blue light. Which means those layers where I had to give extra lighting on it need not be there. And this gives rise to the concept of your micro LEDs, wherein what happens is, instead of using your different, for example, taking a white substance and putting light, RBG light on it, you use blue sapphire-like quality things. This is where he said blue LEDs which are there. You use other substrates which give out red light itself. If you take a sapphire, you don't have to give any other light to it. If you look at the stone itself, it comes out as blue. In this manner, you create a display. So you can only imagine how bright and clear the image out of it would be. Because any of these LEDs which are there, let's go into some of the details of this now. Micro LEDs are self-illuminating diodes. Self-illuminating means you have that thing existing itself in that particular color. Particular light comes out of it. Got it? You are not giving extra light. So here they are self-illuminating, have better, brighter and better color reproduction than your OLED displays. Micro LEDs, based on the idea of use of sapphires, which are known to shine infinitely in blue light based on any, if you take a sapphire stone, if you take any of these self stones which are there, even without any extra stimulus of it, you will see the sparkle coming out of it. Got it? So this is the concept that they've used. To do this, again, they have not used sapphire stones in this, okay? It's not the idea what I'm telling you. They have not used sapphire stones in the TV. They've just used the concept of how something is self-illuminating, wherein you don't have to put extra light on it. So they've used tiny light-emitting diodes that are packed very tightly together, and they are self-illuminating so that there is no much loss of any light happening, and all of that gets projected onto the display. Okay? If a question does come, it will be based on any of those three differences I mentioned. So keep that clearly in your mind. Again, in the case of, I told you the substrate is different, right? So, in the case of OLED, it's an organic substrate. Here, micro LEDs use an inorganic substrates like gallium nitride. So, from the state of the substrate itself, it changes. For one, it is organic. For the other one, it is inorganic. Then, the layers are also less. You're using self-illuminating diodes in the case of your micro LEDs. Features and all, you don't have to go into the details. If put in, when you go through the slides, just have a read through it. But concept is the one that is important. Brighter screens, limitless scalability. Again, important point over here. When I showed you OLEDs, the problem with that was, see, you want to create a very big display. But the problem is you need a huge substrate that you can get. But then you will need that many amount of light illuminating things to create this red light and green light and blue light and things. Which means you will end up creating a big display, but it is going to be an extremely bulky, unclear system which is there. This is the reason why you can see maximum inch of TVs which is having OLED would be maybe 90. That's it. Beyond that, if you want an entire wall of TV and all, you cannot do that. Got it? But here, because you're using these micro LEDs, the prior area or whatever is needed behind it is quite less. So you can limitlessly scale it. You just have to find that many micro LEDs and pack it into a thickly packed manner. So if you want this entire wall to be a TV, that entire system, the best method would be using a micro LED. Clear? Let's take a 2-minute break. 2-minute break. Don't go anywhere. Just have water and sit. No, I'm just parched. That's why. Okay, we'll start. Huh? You want to rotate. Yeah, thanks. How many of them went outside? 2, huh? 3. I know I said 2 minutes, but then we can start. Otherwise, I don't want to keep you guys for longer time here. That is the point. Okay. The next topic that we have to discuss is called as dark patterns. See, I'm pretty sure you guys would have read some current affair material of yours, and you would have seen a lot of different kinds of Trojans and ransomware and different kinds of malwares and everything. So there's a big list, and I basically don't find so much of cost benefit over there because you will end up studying so many different names. You have one question coming on it. I picked this one because the concept of how they are trying to trick people is very unique over here. Okay. In the case of a dark pattern, we just started right now, we didn't say anything more. So in the case of a dark pattern, see, when you design certain systems, okay, you design any website, you design anything which is there, what happens is you have something called as an user interface and user experience. Okay, we are the user. Sometimes you would feel, when you get onto a site, they will keep nagging you. You have a very good article at the back which they've created, but then they will be like, give me your phone number and email ID so that we can give you information about this. And that thing will not get cancelled. It will not have any cancel button. You will have to give your phone number and things. I've seen so many UPSC sites do that. Wherein you will not have cancel buttons. If you have cancel button, you will be like, okay, fine, I'll give you my name and details later. First, let me read this article. But they're like, no, completely blank the screen and they'll just be like, give me this. Now, haven't you felt very irritated at this? Okay. Now, imagine all those systems that we suffer as users have a name, and that is called as dark patterns. So, dark patterns are primarily unethical user interface or user experience interactions that are created, designed to mislead or trick users into doing something they don't want to do. Okay, I don't want to share my details, but I end up doing it. So in similar, what they do is, whichever is the company that has created that thing, they will benefit from it because they will in turn get our data or details or whatever is there. So look at this, all of these things. I've put a list over there. Quickly go through the list. There is baseless countdowns for online deals, if you see. 3 hours into the great billion sale. Have you seen another one which is there? They'll show only one left in stock. Who's showing? Reliance is showing. Where they have so much stock inventory, they're saying only one left in stock and you're like, okay, fine, I have to buy it somehow. Got it. So, baseless countdowns for online deals, conditions in fine print that add on to costs. If anyone's ever got onto any site which says that, okay, please subscribe to, you will get free trial, they'll say. You'll go for the free trial and they'll be like, okay, fine, give me your bank details and everything. Now you take free trial, but right now let me have your detail at least. Why do they need the detail? Again, all that would fall under this. Making ads appear as news reports or celebratory endorsements. Auto-playing videos. Some sites you go into, you will start hearing music and all. You will not know where, but it will be an ad playing out. Forcing users to create accounts to finish a transaction. Silently charging credit cards after free trial ends. and using dull colors to wipe out the information or to not show the information that users should be knowing about. The reason I shared this list is because if they ask about question about dark pattern, think of the expanse on what? Anything. Think of you as a user. And if you have done that without you not wanting to do it originally, that would fall under the idea of dark patterns. So understand, this is not a malware or anything. Got it? It's not a malware. It's not something that your computer is getting affected with. The idea is your user experience over here is getting affected. Got it? Okay, next. Facial recognition technology. Here again, we have it important because our national NAFRS, National Automated Facial Recognition System, was in a lot of controversy this particular year. Again, facial recognition, understand, can you tell me, is it just the face of a person that is being detected? What exactly is getting detected in a facial recognition? Every single measurement that is there. For example, what is the measure between the two eyebrows? What is the measure between this particular place to your earlobe, which is there? Each of these measurements are taken, and those are what incorporates into a facial recognition software. So here you see it's an algorithm based technology that creates a digital map of the face to identify and map individuals. Again, just touch and go current affair, not huge question potential, but for those who don't know, we have something called as a National Automated Facial Recognition System, wherein you have all the major police networks of the country connected to this. This is the reason why there is some issue somewhere. Even if you get a normal CCTV image, you can fix the contours of that image, take it, put it into this National Automated Facial Recognition System and collect the information of whoever has, whose face it is related to. You do realize the problem of it. The problem of it is again the fact that it is a very large database containing photos and videos of people's faces which are there. Which means that when we give our information or photographs or anything anywhere, you have the provision of your National Automated Facial Recognition System to store these things. This is the problematic feature. Got it? So I have not done a crime, I have not done anything wrong, but then my name or my pictures and detail and everything would be there. So again, it was in controversy because of that. Not a prominent current affair, but then remember we have a system in this manner. Then I've picked out of all the major viruses that were there and malwares and everything, I've picked few of them called as Anubis, which is a mobile banking Trojan virus which is there. It has been targeting specifically Android users. Okay. Roaming Mantis, which is again a malware targeting mobile banking users. Lian malware, which is a ransomware. You all understand what the ransomware is, that it will affect your system, it will ask you for a specific amount of money, and if you give it, they will de-encrypt all your data and give it back to you. Otherwise, they will not return the data back to you. So Anubis, Roaming Mantis, Lian. I picked it because of where all these systems had affected, not because I found the names nice. Okay, these systems had primarily affected our banking services which were there, and it caused a lot of effort in our nationalized banks also. This is the reason why these were picked. Are you all low on energy at this point? Okay. Huh? What happened? No, I didn't hear. What were you saying? You're tired. This will not feel like tired when you get, let's just hope you get at least 4, 5, maybe 5 to 8 questions from all this. I mean, ideally, let's just hope. At least the difficult ones if you get from this. Normal ones you will somehow manage, I know. AlphaFold. AlphaFold again, it is artificial intelligence, but it's an artificial intelligence used for a health application. So AlphaFold is basically a protein structure prediction tool. Okay. It uses artificial intelligence. Now, how so? I'll tell you. See, in our body, there are several kinds of proteins which are created. How are proteins created in our body? Yesterday's? Yes. Okay. So you have your RNA which gets translated into proteins. You have several proteins. Now, understanding the structure of these proteins will help us identify like, okay, fine. If we have to eliminate this, what can we do? If we have to change its structure in some way, what can we do? But understand, there are so many proteins created in our body that it becomes very difficult to understand or get a clear image of all of this. AlphaFold, what it tries to do is, it tries to create three-dimensional structures which are there. So for example, if I had the AlphaFold, it will maybe do a scan, it will look into some proteins which are there, and based on the structures which it is seeing, it will create, okay, for this particular category of proteins, they all have this helical structure. So it will have base helical. In this way, they are predicting the structure of proteins. Got it? So they're going to do that for almost 200 million proteins using this manner. Got it? It's a huge system. So AlphaFold, protein prediction tool using your artificial intelligence. Defense. Do I have to explain cruise and ballistic? You all know, right? Anybody who doesn't know, please come forward. I can explain it. Okay, cool. We have primarily, when you look into the defense sector of a country, we have two major categories of missiles. You have cruise missiles and you have ballistic missiles. The difference between both being as to what trajectory it takes. Let's take the ballistic missile in the first case. If you look, there's a small picture over here that shows a ballistic missile. See, the idea of a ballistic missile is, if you launch something with a specific velocity, and you aim it to reach a specific height, the idea is it will always have a fixed trajectory, it will go and fall it. Now that is not something that we've designed, it's gravity. Okay, it's the idea of gravity in itself, where with an initial force, now if I take a ball and if I'm throwing like this, it will also have a trajectory. If I'm taking something with more velocity and throwing, it has a clear pathway. You can always calculate the pathway and determine where it will go and fall. Which means, higher if you want, let's just say I want to send something to an enemy country which is there. If I know exactly where that area is, now again, the point is, I know there is a city over there, I want to bomb that particular city. What I have to do is, okay, that city is this much distance from my launching area. So what velocity I can put it at, so that it goes at a particular height and then follows an entire, it will reach to a height. Think about it, reach to a height, and from the height it will follow the same trajectory and fall into that place that is needed. Now the good point about it is being 2-3 things. First, you can, if I want to reach to an enemy country which is quite far away, I can use this, because all I have to determine is what height it should reach, what velocity I have to propel it at, and then it will go and fall into that place. So what if that enemy country is like maybe really far away from the launch pad? This is a system I can use. But the drawback, you see, it's going through all this drama, it's getting launched, it's moving, and then after a point, sometimes it goes, even touches into the not outer atmosphere, but then it goes to a very big height and then comes down. Which means by then, if the enemy is a good enemy, would have already detected your ballistic missile, because it's going all this way, going into the sky, then coming down, which means before it hits the ground, it will be intercepted. That is the problem of a ballistic missile. Then you have another class of missile called as cruise missiles. Cruise missiles are very low nonsense kind of missiles, wherein for your short distances, you want very high precision with very low detection rate. If you want that, ideally what should be your, if you were designing a missile, You want people to not even realize what hit them. It has to go and hit them and at very high point. You are not looking for one large city. You're looking the parliament building in one particular city in the enemy country. Maybe even one specific area where there is. How will you achieve that? I know it's cruise only. I give that entire build up for that only, But why in cruise? You leave there. Oh, now it's all into one sambar situation where you're bringing AI into cruise missiles. Guys, you just have to leave it at super fast speeds. Okay. You see, in some cases and all, people who play with rubber band and all, what they'll do, even before you're looking, it'll come and hit you. You'll not even know from where it happened. Why? Because you are using extremely high speeds and it's flying at a very low stealth range. It's not going and creating so much drama, I'm ballistic missile, there is so much projectile motion or anything. It's going in a stealth manner. But what is the problem? The problem is it cannot go that manner in a long area. Which means if your enemy country is thousands of kilometers away, by the time it's going in that stealth mode, in that super fast speed, somewhere it will get detected. So again, for short distances but high precision, you have cruise missiles. Again, based on the speeds of the cruise missiles, you have subsonic, supersonic and your hypersonic cruise missiles. Based on the range at which a ballistic, because you do realize these are the defining factors of both. For cruise, it is speed. For ballistic, it is range. So for the ballistic, you have small range ballistic missiles, medium range ballistic missiles, intermediate range ballistic missiles, and intercontinental ballistic missiles. In India, your small range would be your Prithvi, which is there. You have medium range, which is your Agni 1, intermediate range Agni 4, and your intercontinental range, your Agni 5. Yeah, it's short range, but in the case of the ballistic missiles which are there, short Agni 1, it is 200 something, right? 1000 kilometers something, right? Where is it listed as short range? I picked it from the DRDO. No, but then Prithvi, I am talking about, when I am saying Prithvi is small range, Prithvi's range is 35 kilometer. 30 to 35 kilometer. That will nowhere compare to your Agni 1, right? I am asking where did you get the definition from? Because see, what I'm trying to say is, when I'm saying short range, the range I'm looking at is somewhere within your 50 kilometer range. Agni 1 has a range even beyond that. Yeah, 700 to 50 and 700 are two different this thing, right? So here, medium range is normally categorized like that. Are you speaking from the notes? Where exactly is the source? Can you tell? Just tell me, it's fine, I'll come there. They put Agni 1 as this thing.
The speed of this ballistic missile is less you don't. But here they given the speed is up to 20 meters speed.
Yes. See, I'm saying when not ballistic missile speed is less, the idea is that, see, when you need high precision, you need a certain speed associated with it. In ballistic, the precision is already compromised. You use ballistic when you have a high impact area which is there. So in that case, you cannot say, see, it's not like I've compared the speeds over there. The problem here is, even if you have a ballistic missile of that speed, you will not compare it to the stealthness of a precision one which is there. Okay, this one I'll have to clarify. Okay, guys, he's shown a fact over here wherein Agni 2 is put under the medium range. So just keep it on for a while. But then again, short range, the Prithvi one example is correct. Don't write any example for your medium range. I'll clarify it onto your group. Guys, what I've said is, for the medium range one, Don't write Agni 1 as an example right now. I'll clarify it on the group. Which sir? So I have one more validation coming in where the science and tech sir has also in the class mentioned medium range. Anyway, I'll clarify it from my end also. So again, this would have been anyway taken from a reliable source. So again, as of now, I've written Agni 1 over here. She says the science and tech sir has also said Agni 1. He has shown me a countering fact. We'll clarify it and I'll put it in the group. Okay? Okay. Let's talk about few current affairs in defense. My God, time is so much more to complete. Huh? How many slides? Even I am trying to figure it out. I cannot find it. It's there. Normally the number comes over here. I'm 23 slides. 25? Okay, 25 slides. But I think it's small facts. It's not big things. Your conceptual part, I think, is almost done. Okay. Coming to this one, we're talking about GSAT 7 series, which is there. See, normally, why is GSAT 7 put over here? We talked about all the satellites in the first part. This is because GSAT 7 series is the group of satellites that is being used by the Indian Armed Forces. So again, this was in news because your Indian Navy and in your Indian Air Force, both of them had specific GSAT satellites which were given to them. For example, Indian Navy had GSAT 7 satellite, Indian Air Force had GSAT 7A satellite. But your Army wing did not have a specific dedicated satellite. This year, they have proclaimed that GSAT 7B will be the Army specific satellite which is given. Army specific means a land-based army which is there. For them, they will have GSAT 7B as their dedicated satellite. Now, the idea that all these GSATs are being used by different wings of the Indian Armed Forces is called by this term called as Operation Skylight. So again, if they ask you a very simple question, Operation Skylight is just related to what system? It's related to the GSAT 7 series of satellites which are there. Okay. Next. Prachand. Prachand, again, out of all the discoveries or not, see, a lot of things that you find in your current affair documents are not new discoveries. What happens is they would be trial doing different versions of it. But Prachand is not like that. Prachand is an indigenously developed light combat helicopter, LCH. It is the only attack helicopter in the world which can land and take off at an altitude of 5,000 meters with a considerable load of payloads and weapons. Got it? This is the reason why Prachand is a matter of huge pride. Again, something that has been quite popularized in a lot of articles. It is powered by 2 Shakti engines which are created by India and France. It is also having an anti-tank guided missile called as Dhruvastra and air-to-air missile called as Mistral 2. Okay, so much detail you will not require, but remember at least Prachand, light combat helicopter. Srijan portal. Again, there's a lot of effort, just like in the case of science, your space technology, where you want private companies to come in. You are now opening certain parts of your defense also to your private sectors which are there. Now, to understand which area can be taken up by private companies, it's a very grey area. As in, because defense has been very protected for a really long time. So if you want to open certain areas, what has happened is now Srijan portal which is there, it's a government portal which is there. It's an online portal that provides information about defense equipment and items that can be taken up for indigenization by private sector companies. because I am on Srijan portal, it's not a related current affair, but just came into my mind again. The mission called as Swamitwa. What all information do you know about it? Which ministry? Ministry of Panchayati Raj. What is the idea? Some one-liner. Land record this thing. Okay, fine. How are you doing it? Using drone. What kind of drone? Mini, micro, bigger than that. What drones? Micro drones. Okay. Is any specific micro drone enlisted for that activity? There is. I kept the name. Wait, there's a screenshot. Wait, let me just take it. It's called as a Rhino. It's a private company's drone which has been enlisted for it. Rhino, unmanned aerial vehicle, which is a micro drone. Okay, so Swamitwa, I hope that is clear. Again, if you still have not studied your government schemes, this is the detail you have to go for their flagship schemes. Okay, because until one layer of Panchayati Raj and land records and everything, and even drones, that will be there. But if it's something that they're going on flouting it and saying that, okay, this is our flagship thing, look at what we've done, look at we've recorded all this, in that case, you have to go details. I was just telling him today morning, if you've noticed last year's question paper, there was one thing called as your different methods were given for road construction. Copper slag, hot asphalt method, cold asphalt method, geotextiles, 4-5 options. Now he told me, he was like, this is coming under science and technology, so please let's do this technology also in class. But it's not a science and technology question, it's basically a government scheme, because your Pradhan Mantri Gram Sadak Yojana was launched in 2019. The idea of your PMG Sadak Yojana was, it has to create rural roads and you have to create it in a sustainable manner. And they've specifically mentioned 5 different techniques that they have to use in road construction so that your carbon dioxide emission is less. Copper slag, cold asphalt and geotextiles or your biotextile materials which are there are listed in it. Got it. And one more thing, which is waste plastic, the ones that are there. So, got it. We will deal with one layer, but if it's an important scheme like Swamitwa or something, go deeper into it. Find out factuals about anything that can be asked as a question in this manner. Then, hypersonic technology. We've already dealt this in one aspect, wherein I told you we've created Scramjet engine. Now, in the hypersonic, again, what is happening is, this specific innovation was also created, or it was customized by DRDO for their usage. And that is the same thing. If you don't get too confused on anything, it's your same Scramjet technology which is there, which can achieve a speed of Mach 6 up to an altitude of 32 kilometers in 20 seconds. And again, India became the 4th country and everything we've already discussed. It was developed by your DRDO. So, that is done. Doomsday clock. Again, picked it up because the concept of it can be just like a one-liner question. Doomsday clock primarily is a symbolic timepiece showing how close the world is to complete annihilation or complete destruction which is there. And here you will see, again, this year what has happened is, when we had your corona and everything itself, a little bit thing changed. When we detected climate change itself, it changed by a little bit. Right now it is being said that it is now at 90 seconds to midnight. You do understand the concept, right? It's a clock. It's come all the way. Now it is standing at 90 seconds to midnight. It is a symbolic representation which shows that we have very little time before it gets into complete annihilation or the world gets completely destroyed. One more point over here coming in the fact, before we had your climate change and related activities, before you had your corona and all that coming up, it was at 100 seconds to midnight. Again, the point is it shows how close the world is to complete destruction. Butterfly minds. Again, in the context of your Russia-Ukraine war, this has been constantly there in news. The takeaways you have to take is, see, these are primarily land mines. But the point is they're covered and it looks like a toy. If you take the pictures of it, it's like a plastic toy which is there. And the reason that they've employed is pretty brutal. The reason why for example, normal landmines and all, it is getting buried and everything. Here what happens is, when it looks very colorful and everything, you will have kids and other people trying to pick it up. And thus, you don't have to necessarily have someone go and stamp on it or anything. By this action, it will get burst open. So again, it came into news because it's difficult to detect because they are made of plastic and can evade metal detectors. So it will not get detected through any of your security checks, but out in the open, people can go and easily take it and it will get bursted. Okay. Nat grid. Again, this happened side by side this year. Not much popularity was given to it, but important current affair. Nat grid primarily says it is basically the grouping of all your intelligence and investigation agencies. What happens over here? See, we all think about it. There are crimes happening in this country, and then you already have certain crimes wherein you can collect ground-based intelligence. A lot of crimes can be cut short when what happens, those who are gathering the intelligence and those who are doing some surveillance activity or investigation activity, primarily your police and everything, they can get connected with each other. And thus, you have NatGrid, which is an IT platform to assist the intelligence and law enforcement agencies to ensure national security. Very simple concept. It's a very good idea wherein you have your different RAW, IB and all sharing the information that they have to other central agencies so that they can go and curb the crime in a good manner. Normally, information is very compartmentalized in these sectors. The point over here is these few points which are coming later on. The idea is, see, it's an attached office of the Ministry of Home Affairs. First thing. It has 11 central agencies in part of this, network which is there. It is coordinated by your CDAC which is in Pune. And it is exempted from the Right to Information Act which is there. Which is quite logical if you think about it because this is a security agency which is there. Again, those who got to, and if you have, there was a slight controversy on the idea that because this is finally leading to an interface, there's a lot of question of privacy getting compromised. There's a lot of profiling that is being allegedly there. So again, just understand, NatGrid was in news, attached office of Home Affairs, exempted from Right to Information, and 11 central agencies are part of it. Next. Nuclear triad. What is the idea of nuclear triad? Yeah, as in the nuclear capability of your army, navy and your air force has been satisfied. All three are nuclear capable at this point. So from the army, if you look at it, I have listed which all can be nuclear powered and nuclear capable. You have the Agni series, Prithvi series, Prahar missile, Shaurya missile, BrahMos and Nirbhay missiles which can be nuclear powered and nuclear capable. From the Air Force side, you have Mirage, Rafale, Jaguar, Sukhoi, which are nuclear powered or nuclear capable. And in the Navy side, you have INS Arihant and INS Arighat, which is there in the trials, which are in this, which have achieved this capability. What? What optical missiles? You asked, this is some factual information. I'll have to check. I'll have to check. See, this is like UPSC asking me some random current affair. I have Pranay tactical missile. This is the question. I'll probably look at the option and choose one logical one which is there. I'll get back to you regarding it. Just drop me a text. We are moving into the drag end of our class. Quickly, we have few concepts that we have to discuss. First thing is we all constantly hear about ultraviolet rays. Okay. This year, there has been a current affair related to it also. So, I am figuring out the necessary information, the base information about it. What is ultraviolet rays? These are the rays that cover a wavelength of 100 to 400 nanometer. Okay? And the wavelength of ultraviolet is shorter than that of visible light, but longer than that of your X-rays. Okay. If you are pretty much clear with the spectrum, you can just take the picture of the spectrum and look at where your ultraviolet radius comes. Now the point over here is ultraviolet rays are of three different types: A, B and C. The different kinds of frequencies of it and the wavelengths of it also have given. C is of 100 to 280, B is of 280 to 315 and A is of 315 to 400, which means A has the highest wavelength, C has the lowest wavelength. Keep this in mind. Now, few details based on, because we are going to the basic details, not a current affair. The current affair we'll talk about it, but the basics of it. The ultraviolet A and B rays which come from the sun, what happens is they get transmitted through our entire atmosphere. It reaches to us. Ultraviolet C doesn't reach. Ultraviolet C is the one that is filtered by the ozone layer. Okay, so it does not reach to us. The ultraviolet A, which reaches to us, can penetrate the middle layer of the skin. We are not talking about the top layer, the middle layer of the skin, and can cause aging of skin cells and indirect damage to the cell's DNA. Now again, coming back to the specificities I told you, ultraviolet A has the highest wavelength. The highest wavelength one can enter into the skin, beyond the layer of the skin, and try to attack or try to change even the structure of DNA which is there. The one which is lesser in wavelength, which is your ultraviolet B, can only reach to the outer layer of skin and just cause sunburns and things like that. You do realize now, again, this is in the context of, there's a lot of importance of sunscreens being told to people because there's a higher degree of skin cancer that is seen in people. So who is the one of which ultraviolet will be causing the skin cancer primarily? C is already filtered out, both your A and B can cause skin cancer. A in the form of going and tampering with your cell's DNA, B on continuous exposure. Got it? Both of them can cause skin cancer. C cannot cause because C is got filtered out. Now, the current affair related to it is related to but UVC technology which is there. And this started doing its rounds primarily when the corona happened. Okay, so corona happened, and in most of your airport closed areas and all, they put these kind of filter like things wherein constantly you will have these radiations coming out, and this will disinfect the area. And very recently, in your parliament houses which were there, they had lodged these UVC technology radiators which are there. Primarily why? To get rid of any germs and anything that infects people. So that context this had come. I picked it up because I felt the base, the crux of it has a good question potential. Okay, so the UV blaster is primarily an UV based area sanitizer, which is very useful for high tech services like electronic equipment, computers, closed labs, office areas, etc., where you cannot have chemical disinfection happening on a regular basis. So you put this over there, UVC radiations comes out of it and kills the germs which are there. Why UVC? UVC, again I told you, it's of those very low wavelength. These will not cause cancer, or these will not go have high energy enough to go and affect our skin and our cells which is there. This is why UVC is used in that specifically. And again, not UVC in the same intensity as it comes from the sun. It will be of much lesser intensity. Okay. If this question comes, you all owe me a treat, by the way, because this just came to me and I was just like, okay, fine, maybe I'll just discuss the crux of it. In fact, if any of these questions come, you owe me a treat. Coming to the next one, the fundamental particles which are there in the universe. You have normal fundamental particles in the term as protons, electrons, and again, you have few others called as neutrons, neutrinos, muons, TOS, etc. So broadly, if I had to tell what all are the fundamental particles of nature, I can divide them into two categories: quarks and leptons. And under quarks and leptons, I can place any of these other systems which are there. Now, my point over here is this particular one, neutrinos. Okay. What do we know about neutrinos? Neutrinos are the second most abundant particles on the earth. Which is the first? Light particles, just photons. This is the second most abundant particles, and they do not carry a charge, which means they will not interact with matter. This is the problem part. Why? Because you want to detect neutrino. You know neutrino is there everywhere. But the neutrino has no charge, which means it will just be moving here and there. It does not interact with matter. Once something interacts with matter only, I will know, right, okay, there is an impact. Let's go and detect it. So this is the reason why neutrino detection is a very difficult process. It is chargeless and it does not interact with matter. The only interaction or the only way, or on Earth if you had to detect neutrinos, one way is when neutrinos move through water or ice, they leave a flash of light. And now when I'm saying a flash of light, it's not like how torch is lit. It will be a very faint flash of light that we cannot anyway see. You need specific observatories to measure it, or it will create a line of bubbles when they interact with matter. So it's not because they have any charge or anything, because they are moving, it creates some kind of a path over there. And we cannot see it, you need neutrino observatory. Coming to the India Neutrino Observatory. India Neutrino Observatory has been in news in the last 2-3 years, primarily because of certain environmental issues associated with it. Starting off with, India Neutrino Observatory is a project to observe your neutrinos, detect it, study it in a good manner. It is being jointly funded by the Department of Atomic Energy and Department of Science and Technology. Okay. The issue is this. You've had it located in the Bodhi Hills in Theni district of Tamil Nadu. Now the issue is, it is being constantly said that this comes under your Western Ghats eco-sensitive zone. And the people over here say that if you create a neutrino observatory over here, it will have a severe impact on the ecosystem over here. So constantly it's a to and fro. Even though this was proclaimed almost 6-7 years ago, till now there is no active construction of it taking place. It will be an underground observatory, and that is the problem, because when it's an underground observatory, this will create a lot of instability in the earth at the, the ground surface. And already, because Western Ghats is already very prone to landslides and quite unstable in nature, people feel there is an environmental risk associated with it. Now, these three, if again it comes out, we already have few neutrino observatories in the world. You have the Baikal GVD, which is there. Where is it, Baikal? Russia. This was in news this time, okay? Baikal GVD was in news, okay? But again, the news part of it is irrelevant, but understand Baikal in Russia, ice cube at South Pole, and Antares in the Mediterranean Sea. All of them are neutrino observatories. Okay? Again, fortunately and unfortunately for you guys, 10 years back, there was a major discovery of mankind called as the Higgs boson. And here we are celebrating the 10th year anniversary. So what is Higgs boson, or otherwise called as the God's particle, which is there? What exactly is this? See, it is now being said that all your fundamental particles got created from maybe a single kind of particle. And now scientists believe that it could be Higgs boson, thereby calling it the God's particle. Because if this particle wasn't there, all the other subparticles would not have been there. And because these subparticles, for example, you had protons and electrons and neutrons, they interacted with each other, and that is how we had entire matter getting created. So if this was not there, none of this would have happened. So consider Higgs boson as the fundamental particle associated with the Higgs field, a field that gives mass to other fundamental particles, which means from the Higgs boson and the field associated with it is where the other particles derived its mass. Get this much in mind. Next thing is, the mass of a Higgs boson technically is 130 times more massive than a proton. Now again, when we are saying mass and all, we are not even talking of grams, we are talking of small quantities. Protons itself have a very small mass. Higgs boson is 130 times the mass of a proton. Next thing is, Higgs boson is also chargeless. This is the reason why it took so long to detect this and to create this. Where did this get created, by the way? In what setup did this get created? I assumed you would know this. Large Hadron Collider. Okay. Large Hadron Collider where? CERN. Where is CERN? Where is CERN? Swiss border. France and Swiss border. Okay. So Large Hadron Collider, CERN, border, all that. Higgs boson is the only elementary particle with no spin. What is the meaning of spin? Like, for example, every particle which is there, it will have a magnetic rotation on its own. You have, for protons it will have, for neutrons it will have. Higgs boson doesn't have any spin associated with it. Okay. Miscellaneous, I've put in few topics that I was just going through materials and I found like some probability. Biofloc technology, have you heard about it? Yeah, so this is an intensive aquaculture system which is there. Along with it, the wastewater treatment also happens. The interesting fact of biofloc technologies, if you look over here, the nitrogen cycle that we had explained in environment, is what is primarily happening and broken down in over here. You have ammonia. Ammonia is broken down into nitrites, and then you have nitrates, and you have nitrogen gas happening over here. This is the point that I found interesting. Biofloc technology is where you have aquaculture. Aquaculture means you have the combined cultivation of fish and agriculture happening. Along with it, you have wastewater treatment also. And the more interesting part is you see a nitrogen getting fixed in this process. On the top of my head, it's not, again, in India, a specific tribe is very famous for this aquaculture, and this biofloc technology is a technological thing, but there's this particular tribe that practices it in a natural manner. Apatani tribe. Okay? Apatani tribe. Where is the Apatani tribe in? Which area? Okay. Next. Talking about this particular Japanese product which is there, which got geographical indication tag in India. Got it. So you have a tag called as the Nihonshu. The Nihonshu is a special valuable alcoholic beverage made from fermenting rice, and it's for the first time that a Japanese product got a GI tag in India. Now my question is it the first time that a foreign product is getting a GI tag in India? No, because all these other products have previously got GI tag in India. You have a German beer, you have a blue cheese of Italy, you have a plant resin from Greece, you have a seed cone from Czech Republic. Use your slides, just go through the names. Okay? Flex fuel vehicles. What is flex fuel? Again, we've heard about, it's a kind of a hybrid vehicle wherein these vehicles will have an internal combustion engine, but instead of regular petrol, it can run on blended fuel. It can take either 100% petrol, or if you want to mix petrol and your bioethanol, it can do it. Petrol and methanol, it can do it. Anything can be mixed, and without any problem, it can be easily run. Okay, again, on the top of my head, bioethanol and petrol, if I had to compare, which is more efficient? Petrol is more efficient. This is one drawback of your bioethanol that is normally said. But the idea is, as technology improves, we can make bioethanol much more on the lines, because bioethanol, the calorific value of it is quite low in comparison to your petrol. Okay? Hyperloop. I won't discuss the entire thing. I put the picture. I want to know what scientific principle is Hyperloop based on. You all know what Hyperloop is, right? It's a very high speed train that is going on, and you have certain features being satisfied over here. But what exact features? Okay, why magnetic levitation? That is where the principle comes. Yes, it becomes frictionless. One is you're trying to avoid friction. Other is you're trying to avoid any kinds of air resistance that is there. Ideally, if they could, they would put it in a vacuum pod, but it's extremely expensive. That is why they've put it under low pressure systems. But the scientific principle that is in picture over here is you have to avoid friction, you have to avoid air resistance. Okay? Scientist that is important this year, J.C. Bose. Okay, Jagdish Chandra Bose is important. Few of his very important achievements I have put over there. He invented something called as the crescograph. What is that? Yeah, what changes a plant undergoes, or what flower, when it is having a flowering thing, when it is having a fruiting thing, what changes it undergoes can be measured by a crescograph. So again, think of it, he's a physicist, but he also has a biological invention also. So he invented crescograph. He had extensive research on what we call as millimeter waves. Millimeter waves are primarily those waves between this range of 10 mm to 1 mm. Okay, and based on this particular thing, he was also the first one to invent the world's first wireless communication link at 5 mm wavelength. Okay, small area, but he is the first one who could identify it. Just keep these points in mind. This is one thing I forgot to tell you yesterday. Mitochondrial DNA. I told you mitochondrial DNA, but one current affair associated with it. Very recently, the last year's Nobel Prize. You don't have to know who got the Nobel Prize or anything, but the Nobel Prize for your physiology and medical sciences and related fields was got by a person who detected the genetic composition of Denisovan man. Okay, now Denisovan man existed millions of years ago, and you had even Neanderthal man who existed beyond that. Now, how did he detect it? What happened is, you had fossils that got from these people. And in the fossils, you didn't have the normal DNA which was there, but you had the mitochondrial DNA. And using this mitochondrial DNA is how they could figure out what was the genetic composition and all of these creatures which existed at that point. Your takeaway over here is this. Mitochondrial DNA might be very minimal in number, very less in number, and it might also only have a fraction of genetic information that we already established. But it is present in thousands of copies for sequencing because it does not get destroyed as fast as your normal DNA. This might not even come as a question about mitochondrial DNA. It will come as a very general question where they will ask, mitochondrial DNA can be detected at a faster rate or something like that. So understand here, in comparison, the nuclear DNA tends to degrade and modify chemically over the time, making it quite difficult to detect. But in the case of mitochondrial DNA, it exists much more in copies. The genetic material you get from it is less, but it exists, thereby equipping people to do research. And obviously, if they've got Nobel Prize for it, it is a very worthy achievement. Nixtamalization. Know about it? There is something called as fortification of food grains. Anything. You take your today's rice grains which are there, you take your salt, you take your milk, any of these things, if they don't have necessary nutrients in it, you can provide it with nutrients. You can lace it with nutrients. This is the reason why if you take your salt, you would see on the covers of it, you would see iron and iodide salt. Iodine is already there in salt. Iron you are adding extra over there because salt we'll anyway eat. So you add iron means even your iron deficiency will get sorted when you have the salt. So this is the idea of fortification. But understand, this idea of fortification existed even ages ago, and this right now we have discovery of this particular process wherein the Mayan people, which occurred in your Peruvian, South American, those regions, what they've done is, they used to soak and cook their maize in an alkaline solution. Thereby what would happen is, this process will preserve the amino acids, and because you're cooking it in the alkaline solutions, you will have extra calcium, vitamin B2, all of this laced onto it. They basically figured out a way then to actually fortify your maize, and this entire process is called as nixtamalization. This is the last topic, Project Vani. Project Vani is a collaborative effort of collaborative effort of IISc, Google and your Art Park. And the idea that they're trying to do is, they're trying to map the language diversity of India by collecting different speech sets at a very district, very local level. Just remember, Project Vani is related to your language preservation, which is there. Okay. Don't go, because I won't get you guys anytime. Let me Okay, there is something called as a free, just give me a minute. Yeah, free space optical communication. Free space optical communication. Okay, let's keep a note of it. Free space optical communication is a system that is devised by Google to give internet connectivity to the unserved and underserved areas of India. They are not planning to give internet connectivity through satellites or anything. What they're planning to do is through light rays, that is optical medium, they're trying to ensure internet connectivity. Okay. Free space optical communication. Again, stressing on the fact because right now you have several places in the southern parts. You have Andhra, you have Karnataka. All of these states are now using this Google method and providing internet to your areas which are there. Just keep a note of that. Through like for example, see. Okay, think of it. You have a kind of, for example, normally internet connectivity happens how? It is happening in a manner wherein you have some kind of wireless networks, you have some radio waves associated with it. Now, instead of the radio waves, you're using light waves. Okay, but it still remains wireless. That is the concept. It's wireless, it uses light rays. Okay. What is bio-ink? Bio-ink is a functional ink that is used in 3D printing. Okay, it's primarily a composition of hydrogel, wherein you put that, and whenever you want to create any of your living organisms, as in like any internal organisms or anything, you use this system called as bio-ink. It's not very important. Yescarta. Have you heard the term Yescarta? Y-E-S-C-A-R-T-A. Yescarta. Y-E-S-C-A-R-T-A. Yescarta again is a type of gene therapy. Just like we were talking about different techniques yesterday. This is a gene therapy to treat your B cell lymphatic cancer that comes about. Gene therapy to treat your B cell related cancerous diseases which comes about. I'm just giving you this because if those one term related, it's not an extensive current affair, but again, if something related to this comes, I want you to be able to solve it. GSAT-7 that we just discussed, it has another name. It's called as the Rukmini satellite. Okay, so now. Project Loon, you know? Yeah. Project Loon is giving internet connectivity through certain balloon-like structures which are there, run by what company? Google, right? Can anyone check quickly? In my mind, it was Google. Google. It was a question when 1 year when I wrote the prelims, so I remember that. Okay guys, so with this, we are coming to the end of your S&T section and generally of your rapid revision thing. Small word, a lot of you who would be confused at this point, or you might be very confident in your attempt. Just want 2-3 things told to you in a clear manner. You have 30 more days, okay? And in these 30 days, the only thing that will make a difference is how you preserve your confidence. Okay, I don't do motivational talks. I'm very bad at motivational talks, so don't expect any of that kind from me. I'm telling you some practical solutions for you to get confidence. One, as I was discussing earlier, now please don't sit and read any new materials. If you're a first-time aspirant, or even if you've written prelims once and you've not cleared it, then also you will have that, okay, my God, I have to get more and more knowledge. No, you don't need more and more knowledge. You only need the presence of mind to apply whatever knowledge you have. You will not have that presence of mind when until 1 week before the exam, someone comes and let me tell you, in this coming 30 days, you will find so many new materials coming out. You will be like, quick revision module for history in 1 hour. 30 minutes, you revise entire science and technology, and you will sit with that material and you will be like, okay, this is going to take at least 3 days for me. Okay, don't fall into the trap. Don't fall into any new material out there. Your material, your notes, whatever you've created over this time, only revise that. Okay, first thing. Second thing, you've 30 days, and this is a formula I tell to anyone at whatever level of preparation there is. I've seen it work for people. At least attempt 20 full-length tests. From wherever source you get, I have already mentioned, but standard full-length tests. Don't go and take some random institute, some test, get some 60 marks and it be like, okay, fine, I'm not going to give the attempt this time. Don't do that to yourself. Standard sources, you know very well what are the sources. Okay, if you don't know, after the class, I can come and personally tell you also. But again and again stressing on the fact that from standard sources, write tests, write full-length tests. If you've not yet done it in an exam atmosphere, do it in the exam atmosphere. Every test you take it on an OMR sheet. Then, coming to the confidence building part. I was just telling him, for every test, you will have an ideal number that you may be attempting. After you finish the test, take up the unattempted questions which are there. Sit and solve it by yourself before you even check the answer key. See how many you're getting correct or wrong over there. This subconsciously has worked. It has worked for me. I know a lot of people it has worked. Wherein you know that, oh fine, if I had done it, I would have got so much more marks extra. This builds into your mind. So maybe right now you are at a score of maybe 85 or 80 or 90 or 95 or whatever it is. But when you do this process, you know you are capable of getting that much extra mark. This is huge. It will be a very important factor in determining your confidence. The next thing I was mentioning, the questions that you get wrong, sit with those questions. When I'm saying sit with those questions, not to sit and get knowledge from those questions. Think about yourself. Why did I make this question wrong? Okay. And don't think of general reasons like I didn't study it. I didn't know it. No, you will not know. In the UPSC paper, if you take 100 questions, you will know pakka sure maybe 26-30 questions. You still attempt more, no? How do you do it? Because you knew it? No. You still attempted it. So similarly in your case, sit and think, when I attempted this, what went into my mind? Where was the block? Maybe there are people who know an answer, don't mark it in the first go, overthink it in the second round, come back to it and again stop. If you are one among those people, figure out what subjects you're doing this in. Okay, you will have a pattern. Because for a lot of us, some subjects which are very close to our heart, which we have studied extensively, is where we tend to do this. we will not mark it in the right go, because in your mind you're like, I need my 2 marks here. I cannot lose this 2 marks in an area which I so thoroughly know. In other one, you can easily guess and be like, okay, fine, A, B, C, something you will mark. But this one, you cannot afford to lose your mark, and this is very psychological because this affects your ego also. I've studied so much, how can I lose this 2 marks? So what do? You know the answer, but you will not mark it then. You will come for the second round. At that point, you will have some new feature you didn't see it in the first round. In that time, you will end up marking something that is not right. So think about it. Are you doing this for a subject that is very close to, that is very familiar for you? Or are you doing this for subjects which you don't know at all? What is the mistake you are making? You can pinpoint it, make it narrow, figure out everyone has a catch. If you don't have a catch, you will not be sitting and doing UPSC exam at this point. Because you will know, okay, I will have something, I'll have something that is a weakness of mine, I'll cross it. This point, you have to figure out what that weakness of yours is. Okay? Don't generalize it, lack of revision, lack of study. No, even if you don't have anything, I've personally seen students with 2 months of preparation and test taking clear this exam on sheer confidence. Wherein lot of aspirants who we feel like, oh, they know a lot, they're scoring 140, 150 and all in the exam at this point, they falter. That doesn't mean that if you're scoring 150, you will falter. The point is, it's a game of confidence. Finally, towards that one, so 30 days you have full length test, continuous revision, no new materials, and finally once you come closer to the exam, again I've specified, those who find CSAT a bit weak, practice only with your UPSC question papers. Practice with time limit lesser than what is being required. If it's a 2-hour paper, practice it with 1 hour, 45 minutes or 1.5 hours. Strategize there. Each test you take, it should be to figure out your strategy on the day of the exam. Like for example, now when I'm saying strategy, it's like, think like you're going for a war. And then you will be like, no, so I'll attack these questions first. I'll know this. So when you take a CSAT paper, instead of going and attempting questions first, skim through the paper once. Find out the questions that you are comfortable with. Attempt those first. Gain a confidence. Then move on to the difficult ones. Got it? It's at the end of the day, UPSC Prelims is only a game of confidence. How well you sustain under that pressure on that particular day, on those 2 hours in that morning and 2 hours in the evening. Keep this in mind. And finally, this is something, don't let, if you by now you all will know, you will have negative things in your life, negative people who come and be like, why are you studying so much, you will not pass only, why are you doing this? Or you have a lot, if you have anything like that. It can even be your own parents who are demotivating you. Keep distance for at least this next 30 days. Okay? Only do you good. Don't let negativity get to you. Okay? For any of the further things, you're free to reach out. I wish all of you the best. Please take care of your health. Please don't fall sick in the next 30 days. The day before the exam, sleep well. Nothing is going to get changed because you lost your sleep on that particular night. You read one more extra page of your spectrum, nothing is going to happen. Okay, I'm telling you, you will only remember things that you have revised in the 1 month, nothing else. So, don't lose sleep, sleep well, even in the 2 hours that you get between the exam. Don't sleep well, but go take a rest or something and come for your CSAT. Okay, so I hope to see you all do very, very well for your exam and come back and tell like, okay, you all did well. So, all the best. Okay, yeah. Bye.